SAP PP ECC to S/4HANA Migration, the complete incident library.
This is not a tutorial. This is a field manual. Across real-world ECC to S/4HANA migrations, production planning fails not because teams lack knowledge, but because they underestimate structural, algorithmic, financial, and integration shifts. In this video series, we are covering 144 enterprise-grade incidents across every migration phase. To ensure clarity and depth, this content is divided into two strategic parts. Part 1 focuses on structural, conversion, planning, and runtime risks. Part 2 focuses on execution, costing, integration, and post-go-live instability. Together, they form the most complete PP migration incident framework.
Video structure, two-part enterprise breakdown.
1. Part 1 Scenarios 1 to 72, Pre-conversion, Conversion Window, MRP Live and HANA Performance Risks. 2. Part 2 Scenarios 73 to 144, Production Execution, Costing, Cross-Module, Extensibility, Ghost Issues, and Advanced Planning.
Part 1 Before it breaks, structural and planning risks.
Before go-live chaos, before costing disputes, before stabilization war rooms, the foundation cracks first. Part 1 focuses on data integrity, conversion execution, planning algorithm shifts, and HANA runtime impact. These incidents occur before or during migration and define whether your transformation succeeds or destabilizes.
Categories covered in Part 1.
Category 1 Scenarios 1 to 26, Pre-conversion structural and data risks. Category 2 Scenarios 27 to 43, During conversion window incidents. Category 3 Scenarios 44 to 62, MRP Live and planning behavior shift. Category 4 Scenarios 63 to 72, HANA performance and parallelism impact.
Category 1 Pre-conversion structural and data risks.
S/4HANA does not introduce new chaos. It exposes old weaknesses. Category 1 focuses on structural misalignments in production versions, bombs, routings, costing, planning files, and CIF data. These risks rarely break ECC, but they block conversion or destabilize MRP Live in S/4HANA.
Scenarios covered in Category 1.
Scenario 1 Inactive or missing production versions. Scenario 2 Bomb inconsistencies or orphan components. Scenario 3 Routing references to obsolete work centers. Scenario 4 Inconsistent control keys in operations. Scenario 5 MRP area misconfiguration. Scenario 6 Planning file inconsistencies pre-migration. Scenario 7 Variant configuration dependencies. Scenario 8 Phantom assembly explosion misalignment. Scenario 9 Incorrect scrap or yield percentages. Scenario 10 Work center capacity formula errors. Scenario 11 Settlement rule inconsistencies. Scenario 12 Production order status inconsistencies. Scenario 13 Open reservations without components. Scenario 14 Custom Z enhancements in PP tables. Scenario 15 Obsolete or overlapping number ranges. Scenario 16 Missing standard cost estimates. Scenario 17 Unreleased engineering change records. Scenario 18 Alternative bomb strategy misalignment. Scenario 19 Incorrect special procurement keys. Scenario 20 Backflush flags inconsistent across plants. Scenario 21 APO CIF master data sync errors. Scenario 22 PPPI master recipe versus routing inconsistencies. Scenario 23 Unarchived data bloating HANA. Scenario 24 aATP custom rules or BOP gaps. Scenario 25 Mandatory data archiving not performed. Scenario 26 aATP product allocation not identified.
Scenario 1 Inactive or missing production versions.
During ECC to S/4HANA conversion, materials without active production versions pass silently in ECC, but fail under MRP Live in S/4HANA. After go-live, MD01N skips critical materials or produces no procurement proposals, bringing production planning to an unexpected halt.
Scenario classification.
1. Complexity high planning blocking. 2. Phase pre-conversion and post-go-live. 3. Primary ownership PP functional lead. 4. Supporting master data team MDM. 5. Business ownership production manager BPO.
Diagnostic dashboard, symptoms and evidence.
How this failure manifests on the shop floor and how to catch it early. 1. Symptom: MRP Live skips critical materials. Production orders fail with no source of supply errors. 2. Red flag: readiness check flags materials without production versions. 3. Business impact: production lead times become unpredictable and customer delivery dates are missed. 4. Detection: SAP readiness check highlights missing production versions before conversion. 5. Technical proof: MD01 and job logs show enforcement errors for materials lacking valid production versions. Insight: if it looks like an MRP bug, it is usually a master data governance gap.
Why this happens, scenario analysis and root cause.
1. ECC allowed BOM and routing combinations without enforcing production version control. 2. S/4HANA MRP Live mandates production versions for accurate planning logic. 3. Legacy materials were maintained without standardized production version governance. 4. Migration activates stricter planning rules that expose dormant master data gaps. S/4HANA does not introduce the problem. It enforces planning discipline.
Why this is a migration-exclusive failure.
1. ECC Classic MRP tolerated missing or inactive production versions. 2. S/4HANA MRP Live enforces production version logic as mandatory. 3. The readiness check identifies gaps that never caused runtime errors in ECC. 4. The shift from permissive logic to enforced planning architecture occurs only during migration. What was optional in ECC becomes mandatory in S/4HANA.
Governance and accountability, RACI model.
In ECC to S/4HANA Brownfield programs, ownership follows a RACI structure where accountability and execution are clearly separated across work streams. 1. Accountable PP functional lead for planning architecture sign-off. 2. Responsible master data team for mass activation and correction of production versions. 3. Consulted CO functional lead for costing implications of BOM and routing alignment. 4. Informed production business process owner for operational validation. Aligned with SAP Insider and enterprise governance practices, where functional leads own module risks, basis owns infrastructure, and a BAP owns custom adaptations.
Ownership, who actually fixes it.
Fixing this issue requires architectural correction, not a temporary MRP workaround. 1. PP functional lead activates and validates mandatory production version logic in configuration. 2. Master data team performs mass creation or correction of production versions. 3. CO functional lead validates costing and valuation impact after version alignment. 4. Production manager confirms that planning proposals align with shop floor execution reality.
Who gets blamed versus who owns it.
1. Blamed basis because MRP Live appears to malfunction. 2. Blamed SAP because planning logic seems stricter. 3. Actual owner PP functional lead for master data governance. 4. Root cause historical planning shortcuts exposed by S/4HANA enforcement.
How this is actually fixed, the right way by a role.
1. PP functional lead standardizes production version strategy across plants. 2. Master data team executes structured cleanup and validation of affected materials. 3. CO functional lead confirms cost roll-up and valuation alignment after corrections. 4. Business process owner validates MRP results through controlled regression testing.
What not to do, common wrong fixes.
1. Bypassing production version checks through configuration switches. 2. Manually creating emergency planned orders without fixing master data. 3. Ignoring readiness check warnings assuming they are low priority. 4. Blaming MRP Live performance without analyzing master data structure. Temporary workarounds in planning create long-term instability in execution.
Follow-up 1. Why did ECC allow planning without production versions?
Answer: ECC Classic MRP used more flexible logic that derived BOM and routing combinations dynamically. It did not enforce structured production version governance. S/4HANA MRP Live introduces deterministic planning logic that requires explicit version control for consistency.
Follow-up 2. Can this be postponed until after go live?
Answer: technically yes, but operationally risky. Missing production versions directly affect planning accuracy and order creation. Addressing it post-go live shifts risk from IT to production operations and increases business disruption.
Follow-up 3. Curveball. Why do experienced teams still miss this during readiness?
Answer: because production versions are often treated as administrative data rather than planning architecture. Teams focus on transactional testing but overlook structural governance. Migration exposes these silent dependencies immediately under MRP Live.
Exclusive pro tip.
If production versions are inconsistent before conversion, MRP Live will not fail randomly. It will enforce discipline. Treat readiness warnings as architectural audits, not optional cleanup tasks.
Scenario 2. BOM inconsistencies or orphan components.
During ECC to S4HANA conversion, inconsistent BOM structures or orphan components that never caused runtime failures in ECC begin to disrupt MRP Live and production execution. After go live, planned orders explode incorrectly or fail to generate dependent requirements, creating material shortages and shop floor confusion.
Scenario classification.
1. Complexity, high planning and execution risk. 2. Phase, pre-conversion and post-go live. 3. Primary ownership, PP functional lead. 4. Supporting master data team, MDM. 5. Business ownership, production manager, BPO.
Diagnostic dashboard, symptoms and evidence.
How this failure manifests on the shop floor and how to catch it early. 1. Symptom: planned orders explode with missing components or unexpected quantities. 2. Red flag: readiness check highlights BOM inconsistencies or missing component master data. 3. Business impact: production stoppages occur due to unplanned material shortages. 4. Detection: BOM where used analysis reveals components without valid plant or procurement views. 5. Technical proof: MD01N logs show explosion errors or skipped dependent requirements. Insight: if MRP results look unstable, the BOM structure is usually the root cause.
Why this happens, scenario analysis and root cause.
1. ECC allowed loosely governed BOM maintenance across plants and engineering changes. 2. Orphan components were never cleaned because transactions continued to function. 3. S4HANA enforces stricter master data consistency for deterministic MRP Live logic. 4. Migration exposes structural inconsistencies that classic MRP tolerated silently. S4HANA planning logic is structured. It does not compensate for master data shortcuts.
Why this is a migration-exclusive failure.
1. ECC classic MRP dynamically handled incomplete BOM relationships. 2. S4HANA MRP Live requires strict master data alignment for explosion logic. 3. Readiness check evaluates BOM integrity before technical conversion. 4. The enforcement of structural consistency happens only during ECC to S4HANA transformation. What was tolerated as technical debt in ECC becomes a structural blocker in S4HANA.
Governance and accountability, RACI model.
In ECC to S4HANA Brownfield programs, ownership follows a RACI structure where architectural accountability and execution responsibility are clearly separated. 1. Accountable PP functional lead for BOM design governance and planning structure. 2. Responsible master data team for cleansing and correcting inconsistent BOM records. 3. Consulted CO functional lead for cost roll-up and component valuation impact. 4. Informed production business process owner for execution feasibility validation. Aligned with enterprise migration governance, where functional leads own configuration risk and data teams execute structural correction.
Ownership, who actually fixes it.
Stabilizing BOM logic requires structural correction, not emergency planning adjustments. 1. PP functional lead reviews and standardizes BOM usage strategy across plants. 2. Master data team performs structured cleanup of orphan components and missing views. 3. CO functional lead validates cost component impact after BOM corrections. 4. Production manager validates that explosion results match real shop floor execution.
Who gets blamed versus who owns it.
1. Blamed basis because MRP runs appear unstable. 2. Blamed SAP because explosion logic seems stricter. 3. Actual owner PP functional lead for BOM governance discipline. 4. Root cause historical master data inconsistencies exposed by enforced planning logic.
How this is actually fixed, the right way by a role.
1. PP functional lead defines a standardized BOM governance and change management framework. 2. Master data team executes mass validation and correction of inconsistent BOM components. 3. CO functional lead recalculates cost roll-ups after structural corrections. 4. Business process owner approves planning results through structured regression testing.
What not to do, common wrong fixes.
1. Manually adjusting planned orders without fixing BOM master data. 2. Deleting orphan components without analyzing historical usage. 3. Ignoring readiness check warnings assuming low operational risk. 4. Blaming MRP Live instead of reviewing structural data integrity. Temporary corrections in planning create deeper instability in execution and costing.
Follow-up 1. Why did ECC not expose these BOM issues earlier?
Answer: ECC classic MRP used flexible explosion logic that tolerated incomplete master data relationships. As long as transactions posted successfully, inconsistencies remained hidden. S/4HANA enforces structural alignment, exposing gaps immediately under MRP Live.
Follow-up 2. Can automated tools fully correct BOM inconsistencies?
Answer: automated validation tools can identify structural gaps, but business validation is mandatory. BOM logic affects costing, availability, and execution flow. Functional governance must define the correct structure before mass updates are executed.
Follow-up 3. Curveball. Why do teams underestimate BOM cleanup during migration?
Answer: because BOM data is often considered operational rather than architectural. Teams prioritize transactional testing over structural integrity. Migration shifts focus from transaction success to data consistency, revealing overlooked weaknesses.
Exclusive pro tip.
If BOM structures are inconsistent before conversion, MRP Live will amplify the instability. Treat BOM cleanup as an architectural redesign exercise, not a technical validation task.
Scenario 3. Routing references to obsolete work centers.
During ECC to S/4HANA conversion, routings that reference obsolete or inconsistently maintained work centers continue to exist in ECC without visible disruption. After migration, capacity planning, scheduling, and cost calculation begin to produce inconsistent or unrealistic results, impacting both shop floor execution and financial accuracy.
Scenario classification.
1. Complexity, high capacity, and costing risk. 2. Phase, pre-conversion, and post-go live. 3. Primary ownership, PP functional lead. 4. Supporting CO functional lead costing. 5. Business ownership, production manager, BPO.
Diagnostic dashboard, symptoms and evidence.
How this failure manifests on the shop floor and how to catch it early. 1. Symptom: production orders show unrealistic scheduling dates or infinite capacity availability. 2. Red flag: routings reference work centers marked for deletion or not aligned to active cost centers. 3. Business impact: capacity leveling becomes unreliable and production sequencing is disrupted. 4. Detection: work center consistency checks reveal inactive or misaligned cost center assignments. 5. Technical proof: capacity evaluation transactions show zero or incorrect available capacity. Insight: if scheduling looks unrealistic, the work center architecture is usually compromised.
Why this happens, scenario analysis and root cause.
1. ECC allowed legacy work centers to remain referenced even after operational changes. 2. Cost center and work center integration was not consistently governed across plants. 3. S/4HANA enforces tighter integration between capacity planning and controlling structures. 4. Migration exposes inactive or inconsistent work center references embedded in routings. S/4HANA planning logic expects structural alignment between capacity and costing.
Why this is a migration-exclusive failure.
1. ECC classic scheduling tolerated loosely maintained work center assignments. 2. S/4HANA integrates planning and controlling data with stricter validation logic. 3. Capacity evaluation and cost integration become more tightly coupled post-migration. 4. The structural misalignment becomes visible only when S/4HANA enforces integrated planning. What was a silent master data weakness in ECC becomes a visible planning defect in S/4HANA.
Governance and accountability, RACI model.
In ECC to S/4HANA brownfield programs, Architectural accountability and execution responsibility are clearly distributed across functional and technical work streams. 1. Accountable PP functional lead for routing and work center design governance. 2. Responsible PP functional lead executes correction of work center assignments in routings. 3. Consulted CO functional lead validates cost center and activity price alignment. 4. Informed production business process owner for operational scheduling validation. Aligned with enterprise governance models, where functional leads own configuration logic and cross-module impacts are validated collaboratively.
Ownership, who actually fixes it.
Correcting this issue requires alignment between production planning and controlling structures. 1. PP functional lead reviews and corrects obsolete work center references in routings. 2. CO functional lead validates cost center integration and activity pricing. 3. PP functional lead retests scheduling logic and capacity evaluation results. 4. Production manager confirms realistic shop floor capacity and sequencing.
Who gets blamed versus who owns it.
1. Blamed basis because capacity planning appears unstable. 2. Blamed SAP because scheduling logic seems inconsistent. 3. Actual owner PP functional lead for routing and work center governance. 4. Root cause historical misalignment between work centers and cost centers.
How this is actually fixed, the right way by a role.
1. PP functional lead standardizes work center lifecycle governance across plants. 2. PP functional lead corrects routing assignments to active and valid work centers. 3. CO functional lead recalculates activity prices and validates costing integration. 4. Business process owner validates scheduling outputs under real production scenarios.
What not to do, common wrong fixes.
1. Recreating work centers without validating cost center alignment. 2. Ignoring inactive work centers assuming they are unused. 3. Adjusting scheduling parameters without correcting master data. 4. Blaming capacity algorithms instead of reviewing configuration integrity. Incorrect structural fixes can create deeper costing and execution inconsistencies.
Follow-up 1. Why did ECC not fail visibly with obsolete work centers?
Answer: ECC scheduling logic was more tolerant and loosely integrated with controlling validation. As long as transactions posted successfully, structural inconsistencies remained hidden. S/4HANA enforces tighter integration between planning and financial structures.
Follow-up 2. Can capacity issues be fixed without touching routings?
Answer: superficial parameter adjustments may mask symptoms temporarily. However, incorrect work center references directly affect scheduling accuracy and cost calculation. Structural correction at the routing level is mandatory for stability.
Follow-up 3. Curveball. Why is this often discovered only after go-live?
Answer: test environments often use limited capacity data and simplified scenarios. Real production load exposes scheduling distortions immediately. The complexity of integrated capacity and costing structures becomes visible only under operational pressure.
Exclusive pro tip.
If work centers are not actively governed before migration, S/4HANA will expose the weakness through scheduling and costing inconsistencies. Treat work center cleanup as a structural planning reform, not a cosmetic adjustment.
Scenario 4. Inconsistent control keys in operations.
During ECC to S/4HANA conversion, inconsistent or incorrectly assigned control keys in routing operations remain unnoticed in ECC. After migration, confirmations, capacity planning, or cost postings behave unpredictably because S/4HANA enforces tighter integration between execution, costing, and scheduling logic.
Scenario classification.
1. Complexity, high execution and cost impact. 2. Phase, pre-conversion and post-go-live. 3. Primary ownership, PP functional lead. 4. Supporting business process owner, BPO. 5. Business ownership, production manager.
Diagnostic dashboard, symptoms and evidence.
How this failure manifests in production execution and how to detect it early. 1. Symptom: confirmations fail to trigger goods movements or capacity updates. 2. Red flag: work centers show plan load but no actual confirmation postings. 3. Business impact: capacity utilization reports become unreliable and order costs deviate. 4. Detection: routing analysis shows inconsistent control key assignments across plants. 5. Technical proof. Order operation logs display missing scheduling or costing integration flags. Insight. If confirmations behave strangely, review control key governance first.
Why this happens, scenario analysis and root cause.
1. Control keys in ECC were often copied across plants without governance. 2. Operations were configured inconsistently regarding scheduling and costing flags. 3. Custom development sometimes bypass standard control key behavior. 4. S/4HANA tightens integration between PP, CO, and capacity evaluation. S/4HANA does not change logic randomly. It exposes inconsistent configuration.
Why this is a migration-exclusive failure.
1. ECC tolerated operational inconsistencies in control key usage. 2. S/4HANA integrates execution, costing, and scheduling more strictly. 3. Migration activates cross-module validations that were previously silent. 4. The shift from loosely coupled to tightly integrated processes occurs during conversion. What looked harmless in ECC becomes structurally visible in S/4HANA.
Governance and accountability, RACI model.
In ECC to S/4HANA Brownfield programs, ownership follows a RACI model. Accountable is the person who gets fired if it fails. Responsible is the person who actually does the work. 1. Accountable PP functional lead for operational configuration integrity. 2. Responsible PP functional lead for correcting control key configuration. 3. Consulted business process owner for execution validation. 4. Informed CO functional lead for costing impact awareness. Accountable owns the outcome. Responsible executes the fix. This defines enterprise governance.
Ownership, who actually fixes it.
This is a configuration architecture correction, not a runtime patch. 1. PP functional lead reviews and standardizes control key configuration across plants. 2. PP functional lead validates scheduling, confirmation, and costing integration flags. 3. Business process owner confirms execution behavior aligns with shop floor operations. 4. CO functional lead validates costing consistency after configuration alignment.
Who gets blamed versus who owns it.
1. Blamed basis because confirmations appear system-related. 2. Blamed SAP because execution behavior changed. 3. Actual owner PP functional lead for configuration governance. 4. Root cause inconsistent control key usage exposed by tighter S/4 integration.
How this is actually fixed, the right way by a role.
1. PP functional lead harmonizes control key definitions across plants. 2. PP functional lead retests routing execution scenarios end-to-end. 3. Business process owner validates production confirmations under real use cases. 4. CO functional lead verifies cost postings and activity allocations.
What not to do, common wrong fixes.
1. Hard-coding confirmation logic to bypass configuration errors. 2. Adjusting capacity reports without fixing control keys. 3. Blaming scheduling performance without root cause analysis. 4. Treating routing inconsistencies as minor configuration issues. Execution inconsistencies today become financial inconsistencies tomorrow.
Follow-up 1. Why did ECC not expose these inconsistencies earlier?
Answer: ECC processes were more tolerant of configuration inconsistencies. Execution, costing, and scheduling were less tightly enforced. S/4HANA integrates these elements more strictly, exposing control key gaps immediately.
Follow-up 2. Can this be solved by adjusting only confirmation settings?
Answer: no. Confirmation behavior is driven by routing control keys. Fixing surface-level settings without correcting control key governance will only create temporary workarounds.
Follow-up 3. Curveball. Why is this more dangerous than a technical failure?
Answer: because the system still runs. Orders are created and confirmed, but financial postings and capacity data become inconsistent. This creates silent operational drift rather than visible technical errors.
Exclusive pro tip.
Control keys define the operational DNA of production orders. If governance is weak before migration, S/4HANA will enforce discipline after go-live.
Scenario 5. MRP area misconfiguration.
During ECC to S/4HANA conversion, improperly defined or inconsistently assigned MRP areas remain technically active but logically misaligned. After go-live, MRP Live generates unexpected procurement proposals or ignores specific storage locations, creating supply planning confusion across plants.
Scenario classification.
1. Complexity, high planning logic impact. 2. Phase, pre-conversion and post-go live. 3. Primary ownership, PP functional lead. 4. Supporting functional lead. 5. Business ownership, supply chain planning manager, BPO.
Diagnostic dashboard, symptoms and evidence.
How this failure manifests in planning results and how to detect it early. 1. Symptom, MRP Live creates duplicate procurement proposals or ignores specific storage locations. 2. Red flag, planning results differ significantly between plant level and MRP area level runs. 3. Business impact, excess inventory in one location and shortages in another. 4. Detection, readiness check highlights inconsistent MRP area assignments. 5. Technical proof, MD01 and logs show planning scope mismatches for defined MRP areas. Insight, when supply is inconsistent across storage locations, review MRP area governance.
Why this happens, scenario analysis and root cause.
1. MRP areas were configured inconsistently across plants in ECC. 2. Some materials were assigned to MRP areas without standardized planning strategy. 3. Storage location planning logic was not harmonized across modules. 4. S/4HANA MRP Live strictly evaluates MRP area configuration during planning runs. Inconsistent planning structures become visible under deterministic MRP Live logic.
Why this is a migration-exclusive failure.
1. ECC allowed hybrid plant and MRP area planning without strict enforcement. 2. S/4HANA MRP Live uses optimized logic that depends on clean MRP area definitions. 3. Migration activates more consistent evaluation across planning levels. 4. Legacy inconsistencies surface only when MRP Live is fully enforced. Planning structure flexibility in ECC becomes controlled architecture in S/4HANA.
Governance and accountability, RACI model.
In ECC to S/4HANA Brownfield programs, ownership follows a RACI model. Accountable is the person who gets fired if it fails. Responsible is the person who actually does the work. 1. Accountable, PP functional lead for planning structure design integrity. 2. Responsible, PP functional lead for correcting MRP area configuration. 3. Consulted, functional lead for storage location and inventory implications. 4. Informed, supply chain planning manager for operational validation. Accountable owns the architecture. Responsible executes the correction.
Ownership, who actually fixes it.
This is a planning architecture correction, not a runtime MRP tweak. 1. PP functional lead reviews and harmonizes MRP area configuration across plants. 2. PP functional lead validates planning scope and material assignments. 3. functional lead confirms storage location logic aligns with inventory processes. 4. Supply chain planning manager validates procurement proposals through controlled test runs.
Who gets blamed versus who owns it.
1. Blamed basis because planning results appear inconsistent. 2. Blamed SAP because MRP Live seems unpredictable. 3. Actual owner, PP functional lead for planning structure governance. 4. Root cause, historical inconsistency in MRP area configuration.
How this is actually fixed, the right way by a role.
1. PP functional lead standardizes MRP area configuration and assignment logic. 2. PP functional lead realigns materials to correct planning structures. 3. functional lead validates inventory visibility across storage locations. 4. Supply chain planning manager confirms stable planning output under real demand scenarios.
What not to do, common wrong fixes.
1. Disabling MRP area planning to simplify troubleshooting. 2. Manually adjusting procurement proposals without fixing configuration. 3. Blaming performance instead of reviewing planning structure. 4. Ignoring plant-to-MRP area mapping inconsistencies. Planning shortcuts create inventory chaos later.
Follow-up 1. Why does this not always appear during testing?
Answer: testing environments often use limited materials and simplified scenarios. Full production volume and real storage location complexity expose MRP area misalignment that smaller datasets may not reveal.
Follow-up 2. Can we revert to plant-level planning temporarily?
Answer: technically possible, but it masks structural problems. Proper MRP area governance ensures accurate stock segmentation and procurement logic. Reverting reduces planning precision and increases long-term risk.
Follow-up 3, curveball. Why is MRP area governance often overlooked?
Answer: because MRP areas are seen as optional enhancements rather than core planning architecture. During migration, teams focus on transactional stability and overlook structural planning design.
Exclusive pro tip.
MRP areas are not technical objects. They define planning boundaries. If those boundaries are inconsistent, S/4HANA will magnify the error under MRP Live.
Scenario 6, planning file inconsistencies, pre-migration.
Before ECC to S/4HANA conversion, inconsistencies in planning file entries remain unnoticed in daily operations. After migration and activation of MRP Live, materials fail to plan correctly because planning file indicators are missing, outdated, or corrupted.
Scenario classification.
1. Complexity, critical planning execution blocking. 2. Phase, pre-conversion and during conversion. 3. Primary ownership basis lead. 4. Supporting PP functional lead. 5. Business ownership supply chain planning manager, BPO.
Diagnostic dashboard, symptoms and evidence.
How this issue appears during planning runs and how to identify it early. 1. Symptom: MRP Live skips materials that should generate proposals. 2. Red flag: inconsistent or missing entries in planning file tables. 3. Business impact: unexpected stock shortages despite valid demand. 4. Detection: pre-conversion consistency checks show planning file errors. 5. Technical proof: MD01N logs show materials not marked for planning despite requirement changes. Insight: if materials are ignored in planning, inspect planning file integrity before blaming MRP logic.
Why this happens, scenario analysis and root cause.
1. Planning file entries were not consistently updated due to legacy batch jobs. 2. Manual table corrections were performed historically without proper synchronization. 3. Custom programs bypass standard planning file update logic. 4. S/4HANA conversion recalculates planning relevance based on stricter data integrity. Planning file corruption is silent in ECC but exposed under S/4HANA enforcement.
Why this is a migration-exclusive failure.
1. ECC tolerated minor planning file inconsistencies. 2. S/4HANA MRP Live depends on precise planning file indicators. 3. Conversion activates new consistency validations. 4. Legacy inconsistencies surface only when deterministic MRP logic is enforced. S/4HANA does not create the inconsistency. It refuses to ignore it.
Governance and accountability, RACI model.
In ECC to S/4HANA Brownfield programs, ownership follows a RACI model. Accountable is the person who gets fired if it fails. Responsible is the person who actually does the work. 1. Accountable basis lead for system-level data integrity during conversion. 2. Responsible basis lead for executing planning file consistency programs. 3. Consulted PP functional lead for validating planning impact. 4. Informed supply chain planning manager for business validation. Accountable owns system integrity. Responsible executes technical correction.
Ownership, who actually fixes it.
This is a system-level correction requiring coordinated validation. 1. Basis lead executes planning file rebuild and consistency checks. 2. Basis lead ensures background jobs properly regenerate planning indicators. 3. PP functional lead validates planning outcomes after rebuild. 4. Supply chain planning manager confirms stable MRP proposal generation.
Who gets blamed versus who owns it.
1. Blamed PP team because MRP results are wrong. 2. Blamed SAP because MRP Live appears inconsistent. 3. Actual owner basis lead for planning file system integrity. 4. Root cause historical inconsistencies in planning indicator updates.
How this is actually fixed, the right way by a role.
1. Basis lead runs planning file regeneration programs. 2. Basis lead validates background job scheduling consistency. 3. PP functional lead executes controlled MRP regression testing. 4. Business process owner verifies restored planning reliability.
What not to do, common wrong fixes.
1. Manually forcing planned orders without rebuilding planning files. 2. Assuming MRP Live logic is defective. 3. Ignoring pre-conversion consistency warnings. 4. Skipping regression testing after regeneration. Temporary planning fixes without system correction create recurring instability.
Follow-up 1. Why does planning file corruption remain hidden in ECC?
Answer: ECC classic MRP relied heavily on periodic full planning runs that masked minor inconsistencies. Planning file indicators were less strictly enforced. S/4HANA MRP Live evaluates relevance more deterministically, exposing gaps immediately.
Follow-up 2. Can planning files be rebuilt safely before conversion?
Answer: yes, and it is recommended. Running consistency checks and rebuilding planning files in sandbox systems reduces post-go-live risk. Early remediation prevents runtime surprises under MRP Live.
Follow-up 3. Curveball. Why is this often mistaken for performance issues?
Answer: because skipped materials appear as incomplete planning runs. Teams may assume runtime bottlenecks. In reality, the system is working correctly but lacks valid planning indicators.
Exclusive pro tip.
Before activating MRP Live, rebuild and validate planning files. Clean planning indicators are the foundation of deterministic planning in S/4HANA.
Scenario 7. Variant configuration dependencies.
During ECC to S/4HANA migration, complex variant configuration dependencies that worked silently in ECC begin failing under stricter dependency checks. Configurable materials generate incomplete or inconsistent BOM explosions, disrupting production planning and sales order processing.
Scenario classification.
1. Complexity, high cross-module planning and sales impact. 2. Phase, pre-conversion and post-go-live. 3. Primary ownership, VC/PP functional lead. 4. Supporting SD functional lead. 5. Business ownership, sales and production business process owners.
Diagnostic dashboard, symptoms and evidence.
How configuration failures appear in both planning and sales execution. 1. Symptom: configurable materials fail to explode correctly in MRP or during sales order entry. 2. Red flag: inconsistent object dependencies or missing characteristic assignments. 3. Business impact: incorrect component selection leading to production delays or rework. 4. Detection: pre-conversion consistency checks highlight broken dependency syntax. 5. Technical proof: sales order configuration logs show unresolved dependency expressions. Insight: if configurable materials behave unpredictably, dependency logic is usually misaligned.
Why this happens, scenario analysis and root cause.
1. ECC allowed loosely maintained object dependencies over time. 2. Legacy syntax or obsolete characteristics were never cleaned. 3. Custom dependency logic was developed without full regression testing. 4. S/4HANA enforces stricter validation of configuration dependencies. Variant configuration is not broken in S/4HANA. Hidden design flaws are exposed.
Why this is a migration-exclusive failure.
1. ECC tolerated outdated dependency logic without runtime enforcement. 2. S/4HANA validates configuration logic more strictly. 3. Data model simplification impacts dependency resolution timing. 4. Migration activates validation rules not previously triggered. The migration enforces structural consistency across configuration objects.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, RACI defines authority. Accountable is the person who gets fired if it fails. Responsible is the person who does the actual correction. 1. Accountable, VC/PP functional lead for configuration architecture integrity. 2. Responsible, VC/PP functional lead for dependency correction and testing. 3. Consulted, SD functional lead for sales configuration impact validation. 4. Informed, sales and production business process owners. Functional leads own logic risk. Technical teams support execution stability.
Ownership, who actually fixes it.
Resolution requires deep understanding of object dependencies and cross-module validation. 1. VC/PP functional lead reviews and corrects object dependency syntax. 2. VC/PP functional lead validates characteristic assignments and variant classes. 3. SD functional lead tests sales order configuration behavior. 4. Business process owners validate production feasibility post-correction.
Who gets blamed versus who owns it?
1. Blamed SAP for stricter configuration validation. 2. Blamed basis for system behavior differences. 3. Actual owner VC/PP functional lead for dependency governance. 4. Root cause years of loosely maintained configuration logic.
How this is actually fixed, the right way by a role.
1. VC/PP functional lead performs dependency consistency review. 2. VC/PP functional lead updates obsolete syntax and cleans unused characteristics. 3. SD functional lead conducts integrated order production testing. 4. Business process owners approve corrected configuration logic.
What not to do, common wrong fixes.
1. Deleting dependencies without understanding cross-object impact. 2. Hard-coding configuration workarounds in custom code. 3. Testing only simple configurations and ignoring edge cases. 4. Assuming ECC behavior guarantees S/4HANA compatibility. Configuration shortcuts create exponential instability in configurable production.
Follow-up 1. Why are configuration issues discovered only after go live?
Answer: because complex variant combinations are not always covered in test cycles. Real production orders trigger rarely used dependency paths. S/4HANA validation exposes inconsistencies immediately.
Follow-up 2. Should we rebuild all dependencies before migration?
Answer: not necessarily rebuild, but review and validate them. Focus on high-volume configurable materials and perform structured regression testing. Proactive validation reduces post-go-live disruptions.
Follow-up 3. Curveball. Why do experienced consultants underestimate variant configuration risk?
Answer: because configuration logic often feels stable in ECC due to long operational history. However, structural validation rules in S/4HANA can expose hidden logical inconsistencies that were never stress-tested.
Exclusive pro tip.
Before conversion, execute configuration regression testing across extreme variant combinations. Migration is not the time to discover hidden dependency gaps.
Scenario 8. Phantom assembly explosion misalignment.
During ECC to S/4HANA conversion, phantom assemblies that previously exploded dynamically in ECC begin behaving inconsistently under MRP Live. Planning results differ from expectations, causing component shortages or incorrect production proposals.
Scenario classification.
1. Complexity, high multi-level planning risk. 2. Phase, pre-conversion and post-go-live. 3. Primary ownership, PP functional lead. 4. Supporting MM functional lead. 5. Business ownership, production planner, BPO.
Diagnostic dashboard, symptoms and evidence.
How phantom assembly behavior shifts surface in planning results. 1. Symptom: components under phantom assemblies are not planned correctly. 2. Red flag: MRP Live generates unexpected dependent requirements. 3. Business impact: component shortages or excess inventory at lower BOM levels. 4. Detection: MD01 in comparison with ECC MD01 shows multi-level explosion differences. 5. Technical proof: MRP logs indicate altered explosion sequence under S/4HANA logic. Insight: if lower-level components behave unpredictably, phantom strategy must be reviewed.
Why this happens, scenario analysis and root cause.
1. Phantom assemblies rely on precise BOM and control key settings. 2. ECC tolerated loosely defined special procurement indicators. 3. S/4HANA MRP Live executes explosion logic differently under HANA optimization. 4. Inconsistent phantom indicators across plants create planning divergence. Phantom logic is sensitive to master data precision.
Why this is a migration-exclusive failure.
1. ECC classic MRP executed explosion with flexible fallback logic. 2. S/4HANA MRP Live uses optimized deterministic planning algorithms. 3. Legacy phantom inconsistencies were never fully validated. 4. Migration activates stricter structural enforcement. The shift to HANA-driven logic exposes structural BOM weaknesses.
Governance and accountability, RACI model.
In ECC to S4 HANA programs, accountable means the person who gets fired if it fails. Responsible means the person who performs the correction. 1. Accountable PP functional lead for BOM explosion architecture. 2. Responsible PP functional lead for correcting phantom indicators and control logic. 3. Consulted MM functional lead for special procurement alignment. 4. Informed production planner and inventory business process owners. Functional leads own configuration integrity. Technical teams support performance validation.
Ownership, who actually fixes it.
Correcting phantom misalignment requires structured BOM and procurement governance. 1. PP functional lead reviews and standardizes phantom assembly settings. 2. PP functional lead validates multi-level BOM consistency across plants. 3. MM functional lead aligns special procurement keys where required. 4. Business process owner validates planning results through controlled test runs.
Who gets blamed versus who owns it.
1. Blamed SAP for changing MRP logic. 2. Blamed basis for HANA planning differences. 3. Actual owner PP functional lead for phantom configuration governance. 4. Root cause historical inconsistencies in BOM and procurement indicators.
How this is actually fixed, the right way by a role.
1. PP functional lead audits and harmonizes phantom indicators in BOMs. 2. PP functional lead validates explosion logic using MD01N regression testing. 3. MM functional lead confirms procurement type alignment for dependent components. 4. Production planner verifies stable multi-level planning outcomes.
What not to do, common wrong fixes.
1. Changing MRP type blindly without analyzing BOM structure. 2. Removing phantom indicators to force temporary planning success. 3. Testing only single-level BOMs and ignoring deeper structures. 4. Assuming ECC explosion logic will replicate identically in S4 HANA. Quick configuration shortcuts distort long-term planning accuracy.
Follow-up 1. Why do phantom issues appear only in complex materials?
Answer: because multi-level BOMs magnify structural inconsistencies. Simple materials rarely expose explosion sequence issues. Complex assemblies amplify dependency errors under MRP Live.
Follow-up 2. Can performance tuning fix phantom explosion differences?
Answer: no. This is a configuration and master data governance issue. Performance tuning addresses runtime speed, not logical planning correctness.
Follow-up 3. Curveball. Why do planners sometimes blame HANA performance instead?
Answer: because the change becomes visible after migration to HANA. However, the root cause is structural master data inconsistency, not database speed.
Exclusive pro tip.
Before conversion, execute structured multi-level BOM simulations in MD01N test mode. Phantom assemblies should behave deterministically across all plants.
Scenario 9. Incorrect scrap or yield percentages.
During ECC to S4 HANA migration, historically maintained scrap and yield percentages that were loosely governed in ECC begin distorting planning and costing results under MRP Live and material ledger integration. After go live, planned quantities and actual cost variances escalate unexpectedly.
Scenario classification.
1. Complexity, high planning and costing impact. 2. Phase, pre-conversion and post-go live. 3. Primary ownership, PP functional lead. 4. Supporting CO functional lead. 5. Business ownership, production manager, BPO.
Diagnostic dashboard, symptoms and evidence.
How scrap and yield inconsistencies surface after migration. 1. Symptom: planned order quantities inflate beyond historical averages. 2. Red flag variance reports show abnormal usage or scrap postings. 3. Business impact: inventory buffers increase and production costs rise unexpectedly. 4. Detection: comparison between ECC and S4 HANA MRP simulations reveals quantity deviations. 5. Technical proof: cost component split reflects unexpected consumption adjustments. Insight: if quantities look inflated, scrap governance must be reviewed.
Why this happens, scenario analysis and root cause.
1. ECC allowed inconsistent scrap and yield percentages across plants. 2. S/4HANA MRP Live calculates requirements with stricter quantity precision. 3. Material ledger integration amplifies valuation impact of scrap differences. 4. Historical master data was never harmonized under a global governance model. Scrap percentages that were tolerated before become financially visible after migration.
Why this is a migration-exclusive failure.
1. ECC Classic MRP masked minor scrap inconsistencies. 2. S/4HANA integrates planning and valuation more tightly. 3. Material ledger enforces actual costing transparency. 4. Migration exposes quantity assumptions that previously remained hidden. Planning tolerance decreases when valuation precision increases.
Governance and accountability, RACI model.
In ECC to S/4HANA Brownfield programs, accountable means the person who gets fired if it fails. Responsible means the person who executes the correction. 1. Accountable PP functional lead for quantity planning architecture. 2. Responsible PP functional lead for scrap and yield master data correction. 3. Consulted CO functional lead for costing and variance validation. 4. Informed production business process owner for operational confirmation. Functional leads own the logic. Supporting leads validate financial consequences.
Ownership, who actually fixes it.
Correcting scrap misalignment requires configuration and master data harmonization. 1. PP functional lead reviews and standardizes scrap and yield settings across plants. 2. PP functional lead validates BOM and routing level quantity adjustments. 3. CO functional lead verifies variance calculation and cost component impact. 4. Production manager confirms realistic operational yield assumptions.
Who gets blamed versus who owns it.
1. Blamed CO because variances increase after go live. 2. Blamed material ledger for unexpected cost shifts. 3. Actual owner PP functional lead for scrap governance consistency. 4. Root cause historical quantity assumptions embedded in master data.
How this is actually fixed, the right way by a role.
1. PP functional lead conducts cross-plant scrap percentage audit. 2. PP functional lead aligns yield settings in BOM and routing operations. 3. CO functional lead recalculates cost roll-up under standardized assumptions. 4. Business process owner validates planning accuracy through simulation runs.
What not to do, common wrong fixes.
1. Adjusting standard cost to hide scrap discrepancies. 2. Ignoring scrap differences assuming they are minor. 3. Applying blanket percentage changes without plant-level validation. 4. Blaming material ledger without reviewing quantity structure. Cost distortions are usually planning distortions in disguise.
Follow-up 1. Why were scrap differences not visible in ECC?
Answer: because ECC tolerated minor quantity deviations without tightly linking them to valuation transparency. S/4HANA integrates planning and costing more closely, making such differences financially visible.
Follow-up 2. Can scrap corrections be done after go-live safely?
Answer: yes, but they require structured governance. Changes affect planning quantities, cost roll-up, and potentially open production orders. Corrections must be validated in controlled cycles.
Follow-up 3. Curveball. Why do finance teams often discover this first?
Answer: because increased variances appear in financial reports before planners detect quantity inflation. Cost transparency acts as the first alert mechanism.
Exclusive pro tip.
Before migration, execute quantity sensitivity simulations. Small scrap inconsistencies can create large multi-level cost distortions under S/4HANA.
Scenario 10. Work center capacity formula errors.
During ECC to S/4HANA migration, inaccurate or historically customized capacity formulas in work centers begin producing distorted scheduling results. Under S/4HANA's stricter planning logic and performance optimization, small formula inconsistencies create large-scale capacity overloads or underutilization after go-live.
Scenario classification.
1. Complexity, high capacity, and scheduling risk. 2. Phase, pre-conversion, and post-go-live. 3. Primary ownership, PP functional lead. 4. Supporting CO functional lead. 5. Business ownership, production manager, BPO.
Diagnostic dashboard, symptoms and evidence.
How capacity formula inconsistencies surface in real operations. 1. Symptom: capacity leveling shows overloads despite unchanged order volumes. 2. Red flag: finite scheduling results differ significantly from ECC simulations. 3. Business impact: production planning instability and frequent manual rescheduling. 4. Detection: capacity evaluation reports reveal abnormal formula-driven runtime values. 5. Technical proof: work center formula parameters differ from documented standard templates. Insight: if capacity spikes without volume change, formula logic must be reviewed.
Why this happens, scenario analysis and root cause.
1. ECC tolerated custom capacity formulas without global validation. 2. S/4HANA planning engines calculate capacity with higher precision and performance sensitivity. 3. Work center formulas were often modified locally without governance control. 4. Migration activates optimized scheduling logic that amplifies formula deviations. Capacity formulas are architectural elements, not administrative settings.
Why this is a migration-exclusive failure.
1. ECC classic scheduling masked minor formula inefficiencies. 2. S/4HANA recalculates capacity with enhanced performance logic. 3. Optimization routines amplify small parameter misalignments. 4. The migration transition exposes formula precision gaps that never surfaced before. Stricter calculation engines expose relaxed historical governance.
Governance and accountability, RACI model.
In ECC to S/4HANA Brownfield programs, accountable means the person who gets fired if it fails. Responsible means the person who executes the correction. 1. Accountable PP functional lead for capacity planning architecture. 2. Responsible PP functional lead for correcting work center formula settings. 3. Consulted CO functional lead for activity price and costing alignment. 4. Informed production business process owner for scheduling validation. Functional leads own planning logic. Financial leads validate valuation impact.
Ownership: who actually fixes it.
Correcting capacity distortions requires structural review, not reactive scheduling. 1. PP functional lead audits and standardizes capacity formulas across work centers. 2. PP functional lead aligns formulas with documented production standards. 3. CO functional lead validates activity type costing implications. 4. Production manager validates realistic shop floor throughput assumptions.
Who gets blamed versus who owns it.
1. Blamed basis for performance issues. 2. Blamed PP or DS or MRP Live Scheduling engine. 3. Actual owner PP functional lead for incorrect capacity formulas. 4. Root cause historical local customization without governance control.
How this is actually fixed, the right way by a role.
1. PP functional lead performs cross-plant capacity formula harmonization. 2. PP functional lead validates scheduling consistency using controlled test scenarios. 3. CO functional lead recalculates activity price rates under corrected capacity assumptions. 4. Business process owner signs off on realistic scheduling outcomes.
What not to do, common wrong fixes.
1. Adjusting capacity numbers manually to hide formula issues. 2. Blaming scheduling engines without reviewing configuration. 3. Increasing machine capacity artificially without operational validation. 4. Ignoring cross-plant inconsistencies in formula definitions. Artificial capacity adjustments create deeper operational instability.
Follow-up 1. Why were formula errors not visible in ECC?
Answer: ECC scheduling tolerated small computational inconsistencies and often relied on manual planner adjustments. S/4HANA's optimized planning logic exposes calculation deviations more clearly and consistently.
Follow-up 2. Does this affect costing as well as planning?
Answer: yes. Work center capacity formulas directly influence activity allocation and cost calculations. Incorrect formulas can distort both production schedules and financial valuations.
Follow-up 3. Curveball. Why do planners often misinterpret this as a system bug?
Answer: because scheduling deviations appear suddenly after go live. However, the underlying issue is not new logic but stricter enforcement of existing parameters that were previously misconfigured.
Exclusive pro tip.
Before migration, simulate capacity planning using standardized formula templates. Capacity precision: errors compound quickly under S/4HANA optimization engines.
Please check description or comments section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Scenario 11. Settlement Rule Inconsistencies.
During ECC to S/4HANA conversion, open production orders with inconsistent or incomplete settlement rules pass unnoticed in ECC, but create financial reconciliation conflicts after migration. Under S/4HANA's stricter integration between PP and CO, WIP and variance postings begin to fail or post to unexpected accounts.
Scenario Classification.
1. Complexity, critical financial reconciliation risk. 2. Phase, pre-conversion and post-go live. 3. Primary ownership, CO functional lead. 4. Supporting PP functional lead. 5. Business ownership, finance controller.
Diagnostic Dashboard, Symptoms and Evidence.
How settlement inconsistencies surface in financial closing cycles. 1. Symptom, production orders failed during settlement with account assignment errors. 2. Red flag, open orders show incomplete or incorrect settlement receiver data. 3. Business impact, WIP and variance postings mismatched during month-end close. 4. Detection, pre-conversion order audits reveal missing or inconsistent settlement rules. 5. Technical proof. Settlement log messages indicate invalid cost object assignments. Insight. If month-end settlement fails after migration, historical order governance must be reviewed.
Why this happens, Scenario Analysis and Root Cause.
1. ECC allowed flexible settlement rule maintenance with limited enforcement. 2. Open production orders accumulated inconsistent or outdated settlement receivers. 3. S/4HANA enforces tighter integration between PP and CO for financial accuracy. 4. Migration activates stricter validation logic that exposes incomplete configuration. Settlement rules are financial architecture, not optional configuration.
Why this is a migration-exclusive failure.
1. ECC tolerated incomplete settlement assignments as long as postings executed. 2. S/4HANA enforces consistent cost object alignment across modules. 3. Ledger integration magnifies settlement inconsistencies. 4. The enforcement shift occurs only during structural migration. Migration reveals financial shortcuts that ECC silently allowed.
Governance and Accountability, RACI Model.
In Brownfield S/4HANA programs, accountable means the person who gets fired if it fails. Responsible means the person who executes the correction. 1. Accountable, CO functional lead for settlement architecture integrity. 2. Responsible, CO functional lead for correcting settlement rule configuration. 3. Consulted, PP functional lead for production order structure validation. 4. Informed, finance controller for financial sign-off. Financial module risks are owned by CO. PP validates operational alignment.
Ownership, who actually fixes it.
Resolving settlement conflicts requires financial and operational coordination. 1. CO functional lead audits and corrects settlement rule assignments in open orders. 2. PP functional lead validates order type and receiver alignment. 3. CO functional lead tests WIP and variance postings under S/4HANA logic. 4. Finance controller approves corrected settlement outcomes during controlled close simulation.
Who gets blamed versus who owns it.
1. Blamed basis because financial jobs failed during close. 2. Blamed SAP because settlement behavior appears stricter. 3. Actual owner CO functional lead for incomplete settlement governance. 4. Root cause historical open order inconsistencies carried into migration.
How this is actually fixed, the right way by a role.
1. CO functional lead performs open order settlement rule validation before conversion. 2. CO functional lead corrects invalid receiver assignments in coordination with PP. 3. PP functional lead ensures order types align with controlling structures. 4. Finance team validates end-to-end settlement through simulated month-end close.
What not to do, common wrong fixes.
1. Force closing production orders without financial reconciliation. 2. Deleting settlement rules to bypass validation checks. 3. Ignoring open order inconsistencies assuming they will auto-correct. 4. Postponing cleanup until after go-live. Settlement shortcuts create audit risks and financial instability.
Follow-up 1. Why do open orders create higher risk than closed ones?
Answer: open orders carry active cost flows and settlement logic into S/4HANA. If inconsistent, they immediately impact WIP, variance, and reconciliation processes during the first financial close.
Follow-up 2. Can this be fixed post-go-live?
Answer: yes, but it increases financial reporting risk. Correcting settlement logic after live postings may require reversals and resettlement, complicating month-end closing cycles.
Follow-up 3. Curveball. Why do teams often underestimate settlement rules?
Answer: because settlement is viewed as a financial back-office process. In reality, it is tightly integrated with production execution and valuation logic. Migration exposes that hidden dependency.
Exclusive pro tip.
Before conversion, freeze and audit all open production orders for settlement rule consistency. Financial stability in S/4HANA begins long before go-live.
Scenario 12. Production order status inconsistencies.
During ECC to S/4HANA conversion, open production orders with inconsistent or technically corrupted status combinations migrate without visible errors. After go-live, planners discover orders stuck in REL, CNF, or TICO states that no longer behave correctly under S/4HANA validation logic.
Scenario classification.
1. Complexity, high execution disruption. 2. Phase during conversion and post-go-live. 3. Primary ownership PP functional lead. 4. Supporting ABAP lead correction scripts. 5. Business ownership production manager BPO.
Diagnostic dashboard, symptoms and evidence.
How order status inconsistencies surface during operations. 1. Symptom: orders cannot be technically completed or settled. 2. Red flag status combinations appear logically contradictory in CUIs. 3. Business impact: production confirmations fail or financial settlement blocks. 4. Detection: pre-conversion order status consistency checks reveal invalid combinations. 5. Technical proof: status management tables show inconsistent system and user status flags. Insight: status inconsistencies rarely crash ECC, but they break discipline in S/4HANA.
Why this happens, scenario analysis and root cause.
1. ECC tolerated certain inconsistent user and system status overlaps. 2. Manual interventions and custom code created status misalignment over years. 3. S/4HANA enforces stricter status transition validation. 4. Migration exposes historical transactional shortcuts. Status integrity is enforced more rigorously in S/4HANA.
Why this is a migration-exclusive failure.
1. ECC allowed certain order lifecycle inconsistencies without blocking execution. 2. S/4HANA integrates order status tightly with finance and logistics validation. 3. Conversion activates stricter cross-module validation logic. 4. The issue appears only when legacy statuses are structurally audited. Migration converts tolerated irregularities into enforced corrections.
Governance and accountability, RACI model.
In Brownfield S/4HANA programs, accountable means the person who gets fired if it fails. Responsible means the person who executes the correction. 1. Accountable PP functional lead for order lifecycle governance. 2. Responsible ABAP lead for executing correction scripts on inconsistent orders. 3. Consulted CO functional lead for settlement and valuation implications. 4. Informed production manager for operational validation. Functional leads own lifecycle logic. Technical leads execute structural remediation.
Ownership, who actually fixes it.
Correcting order status inconsistencies requires both governance and technical remediation. 1. PP functional lead defines valid lifecycle transitions and validates business impact. 2. ABAP lead develops and executes controlled correction programs for affected orders. 3. PP functional lead performs regression testing of order execution scenarios. 4. Production manager confirms corrected status flow aligns with shop floor operations.
Who gets blamed versus who owns it.
1. Blamed basis because conversion completed but orders malfunction. 2. Blamed SAP because status logic appears stricter. 3. Actual owner PP functional lead for lifecycle governance gaps. 4. Root cause historical manual overrides and weak status control.
How this is actually fixed, the right way by a role.
1. PP functional lead defines clean lifecycle state transitions. 2. ABAP lead executes targeted correction scripts for inconsistent status combinations. 3. CO functional lead validates financial impact for corrected orders. 4. Business process owner signs off after controlled execution testing.
What not to do, common wrong fixes.
1. Manually editing status tables without impact analysis. 2. Force closing orders to bypass validation. 3. Ignoring inconsistent status flags during pre-check. 4. Assuming status issues will auto-correct post-go-live. Improper status fixes create deeper financial and operational corruption.
Follow-up 1. Why does S/4HANA enforce stricter order status validation?
Answer: S/4HANA integrates production, finance, and logistics processes more tightly. Order status directly influences postings and reporting. Stricter validation ensures consistency across modules.
Follow-up 2. How can teams detect this before go live?
Answer: by running status consistency audits on open production orders and analyzing invalid combinations. Early detection prevents operational disruption after migration.
Follow-up 3. Curveball. Why do experienced teams still miss this?
Answer: because order status is viewed as transactional rather than architectural. Teams focus on planning logic and overlook lifecycle integrity. Migration exposes these hidden weaknesses.
Exclusive pro tip.
Before conversion, perform a full lifecycle audit of open production orders. Status consistency is not cosmetic, it is structural.
Scenario 13. Open reservations without components.
During ECC to S/4HANA migration, legacy reservations created manually or through inconsistent production orders exist without valid component references. ECC tolerated these incomplete reservations, but S/4HANA enforces stricter validation, causing planning and goods movement failures post-go-live.
Scenario classification.
1. Complexity, medium execution disruption. 2. Phase, pre-conversion and post-go-live. 3. Primary ownership, MM functional lead. 4. Supporting PP functional lead. 5. Business ownership, warehouse manager, BPO.
Diagnostic dashboard, symptoms and evidence.
How incomplete reservations manifest operationally and how to detect them early. 1. Symptom: goods issue transactions fail with missing component or reference errors. 2. Red flag: reservations show zero or inconsistent component assignments in reports. 3. Business impact: production staging delays and warehouse confusion increase. 4. Detection: pre-conversion consistency checks reveal reservations without linked BOM items. 5. Technical proof: reservation tables show entries without valid material or order linkage. Insight: incomplete reservations are silent in ECC, but enforced strictly in S/4HANA.
Why this happens, scenario analysis and root cause.
1. ECC allowed manual reservation creation without strict dependency validation. 2. Custom enhancements bypass standard component consistency checks. 3. Historical cleanup processes were never enforced. 4. S/4HANA introduces tighter integration between reservations and production orders. Legacy operational shortcuts become structural violations in S/4HANA.
Why this is a migration-exclusive failure.
1. ECC tolerated incomplete or loosely structured reservations. 2. S/4HANA validates component and order dependencies more rigorously. 3. Migration activates stricter cross-module integration logic. 4. The issue surfaces only when legacy data is structurally audited. What was operationally tolerated becomes technically blocked.
Governance and accountability, RACI model.
In Brownfield S/4HANA programs, accountable means the person who gets fired if it fails. Responsible means the person who executes the correction. 1. Accountable functional lead for reservation governance. 2. Responsible PP functional lead for validating production linkage consistency. 3. Consulted ABAP lead if correction utilities are required. 4. Informed warehouse business process owner for operational impact. Functional leads own process integrity. Technical teams execute corrections.
Ownership, who actually fixes it.
Reservation inconsistencies require both functional validation and structural cleanup. 1. functional lead defines correct reservation creation governance. 2. PP functional lead validates linkage between reservations and production orders. 3. ABAP lead executes correction scripts for inconsistent historical reservations. 4. Warehouse manager validates goods movement stability after cleanup.
Who gets blamed versus who owns it.
1. Blamed warehouse team because goods issue fails. 2. Blamed SAP for strict validation behavior. 3. Actual owner functional lead for weak reservation governance. 4. Root cause historical manual shortcuts and missing controls.
How this is actually fixed, the right way by a role.
1. functional lead redesigns reservation governance rules. 2. PP functional lead ensures production orders generate structured reservations. 3. ABAP lead executes controlled cleanup scripts for inconsistent records. 4. Business process owner validates stable goods issue execution.
What not to do, common wrong fixes.
1. Deleting reservations without analyzing dependent transactions. 2. Force posting goods issues to bypass validation. 3. Ignoring readiness check inconsistencies. 4. Blaming S/4HANA enforcement instead of correcting master data. Reservation integrity is operational stability.
Follow-up 1. Why did ECC allow incomplete reservations?
Answer: ECC allowed flexible manual reservation handling and tolerated partial records. It focused more on transactional completion than structural integrity. S/4HANA shifts toward deterministic integration across modules.
Follow-up 2. How can teams prevent this before migration?
Answer: by running reservation consistency reports and validating component-to-order relationships before conversion. Early audits reduce post-go-live operational disruptions significantly.
Follow-up 3. Curveball. Why do teams underestimate reservation governance?
Answer: because reservations seem operational and low risk. However, they directly impact goods movements, staging, and financial postings. Structural weaknesses become visible only under S/4HANA enforcement.
Exclusive pro tip.
Treat reservations as structural production controls, not temporary staging documents. S/4HANA enforces what ECC tolerated.
Scenario 14. Custom Z enhancements in PP tables.
During ECC to S/4HANA conversion, custom Z enhancements built on classic PP tables such as AFKO, AFPO, and RESP continue to run but behave inconsistently. Some enhancements stop triggering, while others cause data corruption due to structural and semantic changes introduced in S/4HANA.
Scenario classification.
1. Complexity, high technical and functional risk. 2. Phase, pre-conversion and during conversion. 3. Primary ownership, ABAP lead classic. 4. Supporting PP functional lead spec. 5. Business ownership, production systems owner, BPO.
Diagnostic dashboard, symptoms and evidence.
How broken enhancements surface and how to identify them early. 1. Symptom, production orders behave differently than ECC for identical transactions. 2. Red flag, SPDD or SBAU logs show overwritten or inactive enhancements. 3. Business impact, order confirmations, goods movements, or costing logic behave unpredictably. 4. Detection, custom code scans identify direct table updates or obsolete fields. 5. Technical proof, dumps or inconsistent data entries appear in PP transactional tables. Insight, if behavior changes without config updates, custom code is the first suspect.
Why this happens, scenario analysis and root cause.
1. S/4HANA simplifies or replaces classic tables with compatibility views. 2. Custom enhancements directly update tables instead of using released APIs. 3. Implicit enhancements are lost or deactivated during SBAU adjustments. 4. Legacy assumptions about table structures no longer hold true in S/4HANA. Clean core enforcement exposes fragile customization patterns.
Why this is a migration-exclusive failure.
1. ECC allowed direct table manipulation without architectural restrictions. 2. S/4HANA enforces clean core and released object usage. 3. Compatibility views hide structural shifts but do not preserve logic integrity. 4. Migration activates stricter technical governance. What worked in ECC as customization becomes technical debt in S/4HANA.
Governance and accountability, RACI model.
In brownfield programs, accountable means the person who gets fired if it fails. Responsible means the person who does the actual technical remediation. 1. Accountable, ABAP lead classic for custom code integrity. 2. Responsible, ABAP developer team for code refactoring and SBAU/SPDD correction. 3. Consulted, PP functional lead for business logic validation. 4. Informed, production business process owner for behavioral changes. Functional leads define behavior. ABAP leads safeguard technical architecture.
Ownership, who actually fixes it.
Custom enhancement failures require structured remediation, not quick patches. 1. ABAP lead classic performs comprehensive custom code analysis. 2. ABAP team refactors direct table updates to released APIs or baddies. 3. PP functional lead validates functional correctness after remediation. 4. Business owner performs regression validation across production scenarios.
Who gets blamed versus who owns it.
1. Blamed, SAP for removing or simplifying tables. 2. Blamed, basis for technical dumps post-upgrade. 3. Actual owner, ABAP lead for legacy custom code decisions. 4. Root cause, direct table manipulation without future-proof design.
How this is actually fixed, the right way by a role.
1. ABAP lead classic initiates custom code remediation strategy. 2. ABAP team replaces obsolete logic with released enhancement frameworks. 3. PP functional lead ensures business logic consistency after refactoring. 4. Architecture team enforces clean core standards for future developments.
What not to do, common wrong fixes.
1. Reactivating obsolete enhancements without analysis. 2. Bypassing clean core guidelines to preserve old logic. 3. Ignoring SBAU/SPDD conflicts during conversion. 4. Assuming compatibility views guarantee functional correctness. Quick fixes in custom code become long-term system instability.
Follow-up 1. Why do some enhancements appear to work after migration?
Answer: compatibility views mask underlying structural changes, allowing some custom logic to function temporarily. However, performance and semantic consistency may degrade over time. This delayed failure pattern makes remediation harder if ignored.
Follow-up 2. How can teams prepare before conversion?
Answer: by running custom code analysis tools and identifying direct table updates early. Refactoring before SUM reduces emergency remediation pressure during the conversion window.
Follow-up 3. Curveball. Why do executives underestimate custom code risk?
Answer: because custom enhancements often operate silently for years. Migration exposes their architectural fragility instantly. What was once a competitive advantage becomes a conversion blocker.
Exclusive pro tip.
If you cannot explain why a Z enhancement exists, It should not survive migration. S/4HANA rewards disciplined architecture.
Scenario 15. Obsolete or overlapping number ranges.
During ECC to S/4HANA conversion, legacy number range intervals for production orders, planned orders, or confirmations overlap across plants or controlling areas. ECC tolerated structural inconsistencies, but during conversion, these overlaps cause technical conflicts and runtime errors.
Scenario classification.
1. Complexity, high conversion blocking risk. 2. Phase, pre-conversion and during conversion. 3. Primary ownership, PP functional lead. 4. Supporting basis lead. 5. Business ownership, production systems owner, BPO.
Diagnostic dashboard, symptoms and evidence.
How number range conflicts surface and how to detect them early. 1. Symptom, order creation fails or duplicate number errors appear during conversion testing. 2. Red flag, simplification or consistency checks show overlapping intervals. 3. Business impact, production orders cannot be created, delaying shop floor execution. 4. Detection, pre-conversion number range audit across plants and object types. 5. Technical proof. System logs show NR interval conflicts during document creation. Insight, number ranges are technical infrastructure with direct business impact.
Why this happens, scenario analysis and root cause.
1. ECC allowed decentralized plant-specific number range definitions. 2. Mergers or system copies created overlapping intervals over time. 3. Number ranges were never globally harmonized. 4. S/4HANA conversion enforces structural consistency across objects. Legacy decentralization becomes a central governance issue in S/4HANA.
Why this is a migration-exclusive failure.
1. ECC runtime rarely detected structural overlaps unless intervals were exhausted. 2. Conversion performs consistency validation across all organizational units. 3. S/4HANA centralizes governance across plants. 4. Structural conflicts become visible only during transformation. Migration is the first time the system performs a structural audit.
Governance and accountability, RACI model.
Accountable is the person who gets fired if it fails. Responsible is the person who executes the correction. 1. Accountable, PP functional lead for harmonized number range strategy. 2. Responsible, basis lead for technical interval correction and transport alignment. 3. Consulted, CO functional lead for document consistency validation. 4. Informed, production business process owner for operational continuity. Functional governance defines structure. Basis executes technical enforcement.
Ownership, who actually fixes it.
Number range conflicts require structural harmonization before conversion proceeds. 1. PP functional lead defines global number range strategy. 2. Basis lead adjusts overlapping intervals and transports corrected configuration. 3. CO functional lead validates financial document references. 4. Business owner confirms uninterrupted production order creation.
Who gets blamed versus who owns it.
1. Blamed basis for conversion errors. 2. Blamed SAP for stricter validations. 3. Actual owner, PP functional lead for decentralized governance gaps. 4. Root cause, years of uncoordinated number range management.
How this is actually fixed, the right way by a role.
1. PP functional lead designs centralized number range architecture. 2. Basis lead restructures intervals without disrupting historical documents. 3. CO functional lead validates financial document references remain intact. 4. Architecture governance enforces single ownership of number range management.
What not to do, common wrong fixes.
1. Deleting intervals without impact analysis. 2. Adjusting ranges directly in production during conversion. 3. Ignoring overlaps assuming they are harmless. 4. Treating number ranges as purely technical objects. Number ranges control document integrity. Structural negligence causes systemic failure.
Follow-up 1. Why were overlaps not detected earlier?
Answer: because ECC systems often operated within separate plant boundaries. Overlaps only become visible when cross-plant harmonization or structural audits are executed during conversion.
Follow-up 2. Can we correct this after go-live?
Answer: technically yes, but extremely risky. Changing number ranges post-go-live can disrupt document continuity and audit trails. It is far safer to resolve before conversion freeze.
Follow-up 3, curveball. Why do executives ignore number range governance?
Answer: because number ranges appear administrative. In reality, they define document uniqueness and legal traceability. Structural negligence here can escalate into compliance exposure.
Exclusive pro tip.
If number ranges are not centrally governed before migration, S/4HANA will force the conversation for you, usually at the worst possible moment.
Scenario 16, missing standard cost estimates.
During ECC to S/4HANA migration, materials without release standard cost estimates pass unnoticed in ECC but create valuation and planning inconsistencies after go-live. Production orders are created, but costing, variance analysis, and settlement processes begin to fail silently.
Scenario classification.
1. Complexity, high financial impact. 2. Phase, pre-conversion and post-go-live. 3. Primary ownership, CO functional lead. 4. Supporting PP functional lead. 5. Business ownership, finance business process owner.
Diagnostic dashboard, symptoms and evidence.
How missing standard cost estimates manifest in operations and how to detect them early. 1. Symptom: production orders show zero or unexpected planned costs. 2. Red flag: cost roll-up reports show materials without released estimates. 3. Business impact: variance analysis becomes unreliable and financial reporting is distorted. 4. Detection: costing run analysis identifies materials without valid standard cost estimates. 5. Technical proof: CK24 release logs show missing or incomplete costing runs for specific materials. Insight: if valuation looks unstable, the root cause is usually cost estimate governance.
Why this happens, scenario analysis and root cause.
1. ECC allowed materials to operate without strictly enforced cost release cycles. 2. Costing runs were performed inconsistently across plants. 3. Master data governance for standard cost estimates was weak or decentralized. 4. S/4HANA integrates valuation and planning more tightly, exposing missing releases. Costing discipline becomes mandatory under integrated S/4HANA valuation.
Why this is a migration, exclusive failure.
1. ECC tolerated planning with outdated or missing cost estimates. 2. S/4HANA financial integration increases dependency on released cost structures. 3. Migration centralizes valuation governance across company codes. 4. Transformation activates stricter financial reconciliation logic. What was administratively tolerated becomes financially visible in S/4HANA.
Governance and accountability, RACI model.
Accountable is the person who gets fired if it fails. Responsible is the person who executes the correction. 1. Accountable, CO functional lead for valuation architecture and release governance. 2. Responsible, PP functional lead for quantity structure alignment in BOM and routing. 3. Consulted, master data team for material master consistency. 4. Informed, finance business process owner for financial reporting validation. Financial ownership defines valuation structure. Functional teams execute master data alignment.
Ownership, who actually fixes it.
Resolving missing standard cost estimates requires coordinated costing and master data governance. 1. CO functional lead performs costing run and enforces release strategy. 2. PP functional lead validates BOM and routing completeness for accurate roll-up. 3. Master data team ensures material master valuation views are consistent. 4. Finance business process owner confirms alignment with financial closing cycles.
Who gets blamed versus who owns it.
1. Blamed finance for reporting inconsistencies. 2. Blamed S/4HANA for valuation differences. 3. Actual owner, CO functional lead for cost release governance. 4. Root cause, inconsistent costing discipline in ECC.
How this is actually fixed, the right way by a role.
1. CO functional lead executes structured costing runs and enforces release calendar. 2. PP functional lead validates quantity structure completeness before cost roll up. 3. Master data team corrects material valuation inconsistencies. 4. Finance validates reconciliation before first month-end close.
What not to do, common wrong fixes.
1. Releasing incomplete cost estimates just to pass reconciliation. 2. Manually adjusting variances without fixing quantity structures. 3. Delaying costing until after go live. 4. Treating costing as purely financial rather than cross-functional. Improper cost governance creates compounding financial distortion.
Follow-up 1. Why did ECC allow operations without strict cost releases?
Answer: ECC environments often operated with flexible costing governance. Materials could continue production even if cost releases were delayed. S/4HANA integrates planning and valuation more tightly, exposing these gaps.
Follow-up 2. How can teams prevent this before conversion?
Answer: by executing full cost roll-up and release validation months before conversion freeze. Cross-plant costing reconciliation should be part of readiness planning, not a post-go-live activity.
Follow-up 3. Curveball. Why do experienced projects still miss costing governance?
Answer: because costing appears cyclical and administrative. Teams focus on transactional flows and overlook valuation architecture. Migration exposes structural costing weaknesses immediately.
Exclusive pro tip.
If standard cost estimates are inconsistent before migration, financial instability after go-live is guaranteed. Treat costing governance as production-critical infrastructure.
Scenario 17. Unreleased engineering change records.
During ECC to S/4HANA conversion, open or unreleased engineering change records remain dormant in ECC, but disrupt BOM validity and production execution after go-live. Materials suddenly follow outdated structures or incorrect effectivity dates.
Scenario classification.
1. Complexity, high structural planning risk. 2. Phase, pre-conversion and post-go-live. 3. Primary ownership, PLM and PP lead. 4. Supporting engineering business process owner. 5. Business ownership, production manager.
Diagnostic dashboard, symptoms and evidence.
How unreleased change records create instability in production and how to detect them early. 1. Symptom: production orders use incorrect BOM components or outdated routings. 2. Red flag: engineering change records remain in created or inactive status before cutover. 3. Business impact: shop floor builds wrong product versions leading to rework and scrap. 4. Detection: change management reports show open engineering change records with pending effectivity. 5. Technical proof: BOM validity intervals conflict with effective dates after migration. Insight: engineering governance failures surface immediately under strict S/4HANA validity control.
Why this happens, scenario analysis and root cause.
1. ECC allowed open change records without strict closure governance. 2. Engineering teams postponed release cycles assuming future activation. 3. Effectivity dates overlapped or were misaligned across plants. 4. S/4HANA enforces stricter integration between BOM, routing, and change management. Change discipline becomes mandatory when planning and execution are tightly integrated.
Why this is a migration, exclusive failure.
1. ECC tolerated dormant change records without runtime impact. 2. S/4HANA activates integrated planning that respects precise effectivity control. 3. Migration consolidates data validation rules across modules. 4. Transformation exposes historical engineering governance gaps. What remained hidden in ECC becomes operationally visible in S/4HANA.
Governance and accountability, RACI model.
Accountable is the person who gets fired if it fails. Responsible is the person who performs the correction. 1. Accountable: PLM and PP lead for change management governance. 2. Responsible: engineering business process owner for release and validation of change records. 3. Consulted: CO functional lead for costing impact of structural modifications. 4. Informed: production manager for operational confirmation. Engineering architecture ownership defines product integrity across planning and execution.
Ownership: who actually fixes it.
Fixing this requires structural engineering cleanup before production stabilization. 1. PLM and PP lead enforces closure and release governance for all open engineering change records. 2. Engineering business process owner validates effectivity dates and plant-level applicability. 3. CO functional lead revalidates cost roll-up after structural corrections. 4. Production manager confirms operational alignment through controlled testing.
Who gets blamed versus who owns it.
1. Blamed: SAP system for incorrect BOM explosion. 2. Blamed: migration team for missing data. 3. Actual owner, PLM and PP lead for change governance. 4. Root cause, unreleased or improperly managed engineering change records.
How this is actually fixed, the right way by a role.
1. PLM and PP lead audits and enforces release of all open change records before cutover. 2. Engineering business process owner validates effectivity intervals and plant scope. 3. CO functional lead performs cost impact validation after structural updates. 4. Production manager signs off after execution level regression testing.
What not to do, common wrong fixes.
1. Force releasing change records without engineering validation. 2. Ignoring open change records assuming no runtime impact. 3. Adjusting BOMs manually after go live without governance. 4. Blaming planning logic instead of reviewing effectivity control. Uncontrolled structural fixes create cascading execution risks.
Follow-up 1. Why were open change records not a major issue in ECC?
Answer: ECC environments often allowed flexibility in release timing. As long as production used existing structures, dormant records caused limited visible disruption. S/4HANA enforces stricter integration across planning and execution.
Follow-up 2. Should all change records be closed before conversion?
Answer: yes. All open or inactive engineering change records should be reviewed, released, or formally closed before migration freeze to avoid structural conflicts in S/4HANA.
Follow-up 3. Curveball. Why do experienced teams still underestimate change governance?
Answer: because change records are seen as engineering artifacts rather than planning architecture controls. Migration reveals how deeply effectivity management impacts production stability.
Exclusive pro tip.
If engineering change records are unmanaged before migration, S/4HANA will enforce structural discipline immediately. Clean architecture before cutover prevents production chaos.
Scenario 18. Alternative BOM strategy misalignment.
During ECC to S/4HANA conversion, alternative bill of material strategies that were loosely governed in ECC begin producing inconsistent planning results in S/4HANA. After go live, MRP selects unexpected BOM alternatives, causing material shortages or cost variances.
Scenario classification.
1. Complexity, high planning and costing impact. 2. Phase, pre-conversion and post-go live. 3. Primary ownership, PP functional lead. 4. Supporting CO functional lead. 5. Business ownership, production manager.
Diagnostic dashboard, symptoms and evidence.
How alternative BOM misalignment impacts planning accuracy and how to detect it early. 1. Symptom: MRP generates planned orders using unexpected component structures. 2. Red flag: multiple active BOM alternatives without clear usage strategy. 3. Business impact: component shortages, unexpected scrap and cost variance spikes. 4. Detection: BOM analysis reports show overlapping validity intervals or inconsistent selection indicators. 5. Technical proof: MRP Live logs indicate alternative selection based on priority and validity conflicts. Insight: when planning logic changes, structural ambiguity becomes operational risk.
Why this happens, scenario analysis and root cause.
1. ECC allowed loosely defined alternative BOM usage without strict governance. 2. Selection methods were not consistently aligned across plants. 3. Validity intervals overlapped without clear priority rules. 4. S/4HANA enforces more deterministic planning behavior under MRP Live. Structural ambiguity tolerated in ECC becomes deterministic conflict in S/4HANA.
Why this is a migration, exclusive failure.
1. ECC classic MRP tolerated ambiguous BOM alternatives. 2. S/4HANA planning logic strictly evaluates priority and validity. 3. Migration activates consolidated planning rules across plants. 4. Transformation exposes historical design shortcuts in BOM governance. Migration does not create new logic. It enforces structured selection.
Governance and accountability, RACI model.
Accountable is the person who gets fired if it fails. Responsible is the person who executes the correction. 1. Accountable PP functional lead for BOM governance architecture. 2. Responsible master data team for validation and cleanup of alternative strategies. 3. Consulted CO functional lead for costing and variance impact. 4. Informed production business process owner for operational alignment. Clear accountability prevents structural ambiguity from becoming operational disruption.
Ownership, who actually fixes it.
Resolving this issue requires structured alternative BOM governance, not planning overrides. 1. PP functional lead defines standardized alternative BOM strategy and selection criteria. 2. Master data team cleans overlapping validity intervals and priority conflicts. 3. CO functional lead validates cost roll-up differences after alignment. 4. Production manager confirms that selected alternatives match operational reality.
Who gets blamed versus who owns it.
1. Blamed MRP Live for generating incorrect components. 2. Blamed system performance for unexpected shortages. 3. Actual owner PP functional lead for BOM strategy governance. 4. Root cause historical ambiguity in alternative BOM configuration.
How this is actually fixed, the right way by a role.
1. PP functional lead standardizes alternative selection method and usage indicators. 2. Master data team corrects validity periods and plant-level applicability. 3. CO functional lead revalidates standard cost and variance structure. 4. Business process owner performs regression testing to validate planning output.
What not to do, common wrong fixes.
1. Deleting alternative BOMs without analyzing production impact. 2. Forcing manual component substitutions in production orders. 3. Ignoring cost variance spikes assuming they are temporary. 4. Blaming MRP logic without reviewing structural governance. Structural cleanup is safer than operational firefighting.
Follow-up 1. Why did ECC not expose this clearly?
Answer: ECC classic MRP used flexible explosion logic that tolerated overlapping alternatives. As long as production continued normally, ambiguity remained hidden. S/4HANA enforces deterministic selection rules.
Follow-up 2. Can planning be adjusted temporarily?
Answer: temporary planning adjustments may work, but they introduce inconsistent costing and material shortages. Structural BOM governance correction is the only stable solution.
Follow-up 3. Curveball. Why do teams underestimate alternative strategies?
Answer: because alternatives are often maintained for flexibility. However, without strict governance, flexibility becomes ambiguity. Migration forces clarity in structural decision rules.
Exclusive pro tip.
If alternative BOM strategies are not clearly governed before conversion, S/4HANA will enforce deterministic planning behavior. Clean structural ambiguity before go live to prevent operational disruption.
Scenario 19. Incorrect special procurement keys.
During ECC to S/4HANA migration, incorrectly assigned special procurement keys that were historically tolerated begin causing unexpected supply proposals. After go live, MRP generates in-house production instead of subcontracting or vice versa, disrupting supply chain alignment.
Scenario classification.
1. Complexity, high supply chain disruption risk. 2. Phase, pre-conversion and post-go live. 3. Primary ownership, MM functional lead. 4. Supporting PP functional lead. 5. Business ownership, supply chain manager.
Diagnostic dashboard, symptoms and evidence.
How incorrect special procurement keys distort supply strategy and how to detect it early. 1. Symptom: MRP creates unexpected purchase requisitions or planned orders. 2. Red flag: materials show inconsistent procurement type and special procurement key combination. 3. Business impact: delayed production, incorrect subcontracting flows, or excess internal load. 4. Detection: material master analysis reveals inconsistent procurement indicators across plants. 5. Technical proof: MRP Live Planning Log shows procurement type override due to special procurement configuration. Insight: procurement strategy errors appear as planning instability.
Why this happens, scenario analysis and root cause.
1. ECC allowed flexible use of special procurement keys without strict review. 2. Over time, materials were assigned keys without strategic alignment. 3. Cross-plant procurement logic was not consistently validated. 4. S/4HANA MRP Live strictly interprets procurement indicators and sourcing logic. Migration enforces strategic clarity in procurement logic.
Why this is a migration, exclusive failure.
1. ECC Classic MRP tolerated inconsistent procurement strategies. 2. S/4HANA planning logic applies deterministic sourcing behavior. 3. Migration activates consolidated plant-level logic validation. 4. Transformation exposes historical inconsistencies in supply design. In S/4HANA, supply strategy cannot be ambiguous.
Governance and accountability, RACI model.
Accountable is the person who gets fired if it fails. Responsible is the person who executes the correction. 1. Accountable functional lead for procurement architecture alignment. 2. Responsible master data team for correction of procurement indicators and special procurement keys. 3. Consulted PP functional lead for production impact validation. 4. Informed supply chain business process owner for sourcing strategy confirmation. Clear accountability ensures supply chain stability during migration.
Ownership, who actually fixes it.
Resolving procurement inconsistencies requires structural master data correction, not manual overrides. 1. Functional lead reviews and standardizes special procurement strategy. 2. Master data team updates procurement type and special procurement assignments. 3. PP functional lead validates impact on planning and capacity. 4. Supply chain manager confirms sourcing behavior matches operational design.
Who gets blamed versus who owns it.
1. Blamed MRP Live for generating incorrect sourcing proposals. 2. Blamed purchasing team for supply disruption. 3. Actual owner functional lead for procurement governance. 4. Root cause historical master data inconsistency in special procurement assignment.
How this is actually fixed, the right way by a role.
1. Functional lead defines plant-level procurement strategy and governance rules. 2. Master data team performs structured cleanup of special procurement assignments. 3. PP functional lead validates MRP behavior across scenarios. 4. Business process owner approves final sourcing design through controlled testing.
What not to do, common wrong fixes.
1. Manually adjusting purchase requisitions without correcting master data. 2. Deleting special procurement keys without impact analysis. 3. Overriding procurement type in emergency mode. 4. Ignoring cross-plant sourcing dependencies. Temporary sourcing overrides create long-term supply instability.
Follow-up 1. Why did ECC not expose this clearly?
Answer: ECC Classic MRP often allowed flexible sourcing behavior without strict validation. As long as procurement executed successfully, inconsistencies remained hidden. S/4HANA planning logic enforces clear sourcing definitions.
Follow-up 2. Can this be corrected after go live?
Answer: yes, but operational risk increases significantly. Incorrect sourcing directly impacts production continuity and vendor coordination. Correcting master data before go live prevents emergency procurement disruptions.
Follow-up 3. Curveball. Why is this often blamed on purchasing?
Answer: because purchasing sees incorrect requisitions first. However, the root cause usually lies in master data governance and procurement strategy design, not transactional execution.
Exclusive pro tip.
If special procurement keys are inconsistent before conversion, S/4HANA will not adapt to your ambiguity. Align sourcing architecture before go live to protect supply continuity.
Scenario 20. Backflush flags inconsistent across plants.
During ECC to S/4HANA migration, inconsistent backflush indicators across plants begin causing unexpected inventory postings. After go live, confirmations either fail to consume components automatically or overconsume materials, creating stock mismatches and financial discrepancies.
Scenario classification.
1. Complexity, high inventory and financial risk. 2. Phase, pre-conversion and post-go live. 3. Primary ownership, PP functional lead. 4. Supporting functional lead. 5. Business ownership, production manager.
Diagnostic dashboard, symptoms and evidence.
How inconsistent backflush configuration impacts execution and how to detect it early. 1. Symptom: component consumption not posted automatically during confirmation. 2. Red flag: same material behaves differently across plants during goods issue. 3. Business impact: inventory mismatches, delayed order settlement and audit findings. 4. Detection comparison of backflush indicators in BOM and material master across plants. 5. Technical proof. Confirmation logs show missing automatic goods movements or duplicate postings. Insight, execution inconsistencies are usually configuration governance gaps.
Why this happens, scenario analysis and root cause.
1. Backflush indicators were maintained inconsistently in BOMs and routing operations. 2. Plant-specific configuration evolved differently over years. 3. Material master and BOM settings were not centrally governed. 4. S/4HANA enforces tighter integration between confirmation and inventory posting logic. Migration exposes configuration fragmentation across plants.
Why this is a migration, exclusive failure.
1. ECC tolerated minor inconsistencies without immediate failure. 2. S/4HANA confirmation logic interacts more strictly with inventory integration. 3. HANA real-time postings expose timing and configuration gaps. 4. Cross-plant harmonization becomes mandatory during migration. What worked locally in ECC fails globally in S/4HANA.
Governance and accountability, RACI model.
Accountable is the person who gets fired if it fails. Responsible is the person who executes the correction. 1. Accountable PP functional lead for confirmation and backflush architecture. 2. Responsible master data team for harmonizing backflush indicators in BOM and material master. 3. Consulted MM functional lead for inventory posting validation. 4. Informed production business process owner for shop floor confirmation impact. Clear separation of authority and execution prevents inventory instability.
Ownership, who actually fixes it.
Backflush inconsistencies require structured harmonization, not manual stock correction. 1. PP functional lead defines plant-level backflush governance standards. 2. Master data team aligns BOM and material master indicators across plants. 3. MM functional lead validates goods movement postings and inventory impact. 4. Production manager confirms confirmation behavior aligns with operational practice.
Who gets blamed versus who owns it.
1. Blamed inventory team for stock mismatches. 2. Blamed finance for valuation discrepancies. 3. Actual owner PP functional lead for execution configuration governance. 4. Root cause historical inconsistency in backflush master data maintenance.
How this is actually fixed, the right way by a role.
1. PP functional lead standardizes backflush strategy across plants. 2. Master data team performs mass update of inconsistent indicators. 3. MM functional lead tests inventory postings through controlled confirmation cycles. 4. Business process owner validates financial and stock alignment post-correction.
What not to do, common wrong fixes.
1. Manually adjusting inventory differences without correcting master data. 2. Switching off automatic goods movement temporarily. 3. Ignoring cross-plant configuration inconsistencies. 4. Blaming confirmation performance without configuration analysis. Temporary inventory adjustments hide systemic configuration issues.
Follow-up 1. Why does this become visible only after migration?
Answer: S/4HANA enforces tighter integration between confirmation and inventory postings. Real-time posting visibility exposes configuration gaps that ECC did not strictly validate. Migration harmonization makes inconsistencies more visible.
Follow-up 2. Is this a configuration or data issue?
Answer: it is both. Configuration defines the logic, while master data enforces plant-level behavior. Without alignment between them, execution becomes unstable.
Follow-up 3. Curveball. Why is this often discovered by auditors first?
Answer: because stock mismatches and valuation inconsistencies surface during financial close. Operational teams may compensate manually, but auditors identify systemic posting inconsistencies during reconciliation.
Exclusive pro tip.
Backflush governance must be harmonized before conversion. In S/4HANA, execution errors propagate instantly into finance and inventory visibility.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem solving, generally most asked system design. Most asked implementation project-related interview questions and answers. Most asked support project-related interview questions and answers. Required for your SAP functional modules interviews jobs like SAP Consultant jobs, SAP FICO Consultant jobs, SAP SD Consultant jobs, SAP PP Consultant jobs, SAP Ariba Consultant jobs, SAP Extended Warehouse Management EWM Consultant jobs, SAP Plant Maintenance PM Consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving. Interview questions and answers where almost 80% of the people are failing to answer. System design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Scenario 21. APO-CIF Master Data Sync Errors.
During ECC to S/4HANA migration, legacy APO-CIF integrations are decommissioned. Master data such as resources, production data structures, and planning versions do not synchronize properly into embedded planning. After go live, planning results differ significantly due to unsynchronized or incomplete data.
Scenario classification.
1. Complexity critical planning architecture risk. 2. Phase pre-conversion and cutover. 3. Primary ownership PPDS lead. 4. Supporting basis lead queue management. 5. Business ownership planning manager.
Diagnostic dashboard, symptoms and evidence.
How CIF elimination creates silent planning data gaps and how to detect them early. 1. Symptom planning results inconsistent between legacy APO and S/4HANA. 2. Red flag missing resources or planning data structures in embedded planning. 3. Business impact capacity overload, missing planned orders, and unstable supply planning. 4. Detection comparison of APO master data objects with S4 embedded planning data. 5. Technical proof. Queue logs show incomplete or failed master data synchronization prior to cutover. Insight. Planning drift after go live often begins with incomplete data migration.
Why this happens, scenario analysis and root cause.
1. CIF logic used in APO is eliminated during S/4HANA migration. 2. Embedded planning requires direct master data mapping without automated replication. 3. Legacy APO planning versions and models do not migrate automatically. 4. Queue monitoring gaps allow incomplete synchronization to pass unnoticed. Migration removes technical layers that previously masked synchronization gaps.
Why this is a migration, exclusive failure.
1. APO relied on CIF for controlled master data replication. 2. S/4HANA embedded planning requires direct configuration alignment. 3. The architectural shift eliminates automatic data buffering. 4. This structural transition occurs only during ECC to S/4HANA migration. Planning architecture redesign exposes data synchronization debt.
Governance and accountability, RACI model.
Accountable is the person who gets fired if it fails. Responsible is the person who executes the migration or correction. 1. Accountable PPDS lead for planning architecture integrity. 2. Responsible basis lead for queue monitoring and system-level synchronization validation. 3. Consulted PP functional lead for master data mapping alignment. 4. Informed planning manager for operational validation of planning results. In enterprise governance, planning accountability remains with the planning lead even if technical layers change.
Ownership, who actually fixes it.
CIF elimination requires structured architectural redesign rather than manual correction. 1. PPDS lead defines embedded planning data model alignment. 2. Basis lead monitors queues and validates synchronization during cutover. 3. PP functional lead validates master data completeness in S/4HANA. 4. Planning manager confirms planning stability under production load.
Who gets blamed versus who owns it?
1. Blamed basis for failed queues. 2. Blamed SAP for removing CIF. 3. Actual owner PPDS lead for planning architecture governance. 4. Root cause incomplete planning data migration strategy.
How this is actually fixed, the right way by a role.
1. PPDS lead redesigns planning model for embedded architecture. 2. Basis lead ensures complete queue monitoring and reconciliation. 3. PP functional lead performs master data reconciliation validation. 4. Planning manager validates planning accuracy under simulated load.
What not to do, common wrong fixes.
1. Assuming embedded planning automatically mirrors APO behavior. 2. Skipping queue validation during cutover. 3. Performing manual master data fixes without architectural review. 4. Blaming planning logic without validating data completeness. Planning errors after migration are rarely algorithm failures. They are usually data alignment gaps.
Follow-up 1. Why is CIF elimination risky during migration?
Answer: CIF handled structured replication between systems. Its removal requires direct embedded mapping without buffer layers. Without careful validation, planning objects may not migrate completely, creating planning drift.
Follow-up 2. Can queue errors be ignored if planning seems stable?
Answer: no. Queue inconsistencies may not appear immediately, but will create cumulative drift in capacity and order generation. Early reconciliation prevents long-term planning instability.
Follow-up 3. Curveball. Why do experienced teams underestimate CIF migration impact?
Answer: because CIF operated silently in the background for years. Its stability created overconfidence. Migration removes that abstraction layer and exposes direct dependency on master data completeness.
Exclusive pro tip.
If APO existed in ECC, treat CIF elimination as an architectural redesign, not a technical switch. Embedded planning demands full data reconciliation before go live.
Scenario 22. PPPI master recipe versus routing inconsistencies.
During ECC to S/4HANA conversion in process industry environments, inconsistencies between master recipes and routings become visible. Validity dates, phases, or secondary resources do not align. After go live, production orders fail to generate correctly or process messages behave unpredictably.
Scenario classification.
1. Complexity high process execution risk. 2. Phase pre-conversion and post-go live. 3. Primary ownership PPPI lead. 4. Supporting QM functional lead. 5. Business ownership process production manager.
Diagnostic dashboard, symptoms and evidence.
How structural inconsistencies in process recipes create execution instability and how to detect them early. 1. Symptom: process orders fail during creation or confirmation due to missing phases. 2. Red flag: validity dates for master recipes do not match material master production settings. 3. Business impact: batch production delays and unexpected shop floor interruptions. 4. Detection: pre-conversion master data validation comparing master recipe phases with routing references. 5. Technical proof: order creation logs show missing or inconsistent phase or resource assignments. Insight: in process industry, minor master data misalignment can halt entire production cycles.
Why this happens, scenario analysis and root cause.
1. ECC tolerated loosely aligned master recipe and routing structures. 2. S/4HANA enforces stricter validity and resource mapping checks. 3. Secondary resources and phases were historically maintained inconsistently. 4. Migration activates structural validations that expose dormant inconsistencies. The enforcement is new. The inconsistency is old.
Why this is a migration, exclusive failure.
1. Process industry configurations were often customized heavily in ECC. 2. S/4HANA simplifies and standardizes process execution logic. 3. Validity control and resource assignment rules are stricter. 4. The enforcement of structural consistency appears during conversion. Migration transforms permissive configuration into enforced discipline.
Governance and accountability, RACI model.
Accountable is the person who gets fired if it fails. Responsible is the person who executes the correction. 1. Accountable PPPI lead for process recipe architecture alignment. 2. Responsible PPPI lead and master data team for structural corrections. 3. Consulted QM functional lead for compliance and batch validation alignment. 4. Informed process production manager for operational validation. In regulated industries, process ownership remains with the functional lead, even if technical errors surface.
Ownership, who actually fixes it.
Correction requires structural alignment of process definitions, not runtime adjustments. 1. PPPI lead aligns master recipe phases with routing and resource definitions. 2. Master data team corrects validity dates and secondary resource assignments. 3. QM functional lead validates compliance and inspection integration impact. 4. Process production manager verifies stable execution through controlled testing.
Who gets blamed versus who owns it.
1. Blamed basis for order creation failures. 2. Blamed SAP for change process logic. 3. Actual owner PPPI lead for master data architecture governance. 4. Root cause historical inconsistencies tolerated in ECC master data.
How this is actually fixed, the right way by a role.
1. PPPI lead standardizes recipe structure across plants. 2. Master data team performs structured validity and phase alignment corrections. 3. QM functional lead validates batch management and inspection integration. 4. Process production manager confirms execution stability under real production scenarios.
What not to do, common wrong fixes.
1. Creating temporary manual overrides to bypass phase checks. 2. Ignoring validity date conflicts assuming they are harmless. 3. Blaming system performance instead of master data alignment. 4. Proceeding to go live without cross-plant structural validation. Process industry instability usually begins with neglected master data governance.
Follow-up 1. Why are master recipe inconsistencies more visible in S/4HANA?
Answer: S/4HANA enforces stricter structural validations during order creation and confirmation. Master recipe phases and resource mappings must align precisely. ECC tolerated minor inconsistencies that S/4HANA no longer ignores.
Follow-up 2. Can we delay cleanup until after go live?
Answer: technically possible but operationally dangerous. Process industry environments often involve compliance and regulatory controls. Postponing alignment increases production risk and potential audit exposure.
Follow-up 3. Curveball. Why do experienced teams underestimate process recipe alignment?
Answer: because master recipes evolve gradually over years without centralized governance. Migration forces centralized validation. What looked operationally stable may not be structurally compliant.
Exclusive pro tip.
In process industry migrations, treat master recipe alignment as a regulatory control checkpoint. S/4HANA will enforce structure whether governance existed before or not.
Scenario 23. Unarchived data bloating HANA.
During ECC to S/4HANA conversion, historical production orders, confirmations, reservations, and planning data that were never archived dramatically increase HANA memory consumption. After go live, planning runs slow down, reports time out, and background jobs compete for resources.
Scenario classification.
1. Complexity, critical performance, and stability risk. 2. Phase, pre-conversion and post-go live. 3. Primary ownership basis lead. 4. Supporting PP functional lead. 5. Business ownership project lead.
Diagnostic dashboard, symptoms and evidence.
How excessive historical data silently degrades performance and how to detect it early. 1. Symptom: MRP Live Runtime increases significantly after go live. 2. Red flag: HANA memory growth spikes during planning or reporting windows. 3. Business impact: production planning delays and background job overlaps. 4. Detection: readiness check highlights large historical table volumes before conversion. 5. Technical proof: SD22 dumps and performance traces show high memory consumption during MD01N runs. Insight: HANA is fast, but only when unnecessary history is removed.
Why this happens, scenario analysis and root cause.
1. ECC systems often accumulated years of production data without archiving. 2. S/4HANA loads larger datasets into memory for real-time processing. 3. Conversion migrates historical data without enforcing cleanup. 4. Performance degradation appears only under production-scale workload. HANA magnifies data volume issues that ECC masked.
Why this is a migration, exclusive failure.
1. ECC performance degradation was gradual and often unnoticed. 2. S/4HANA introduces in-memory processing that exposes table volume issues. 3. Conversion moves historical technical debt into a real-time architecture. 4. The performance collapse becomes visible only after go live. Migration does not create volume problems. It exposes them at speed.
Governance and accountability, RACI model.
Accountable is the person who gets fired if it fails. Responsible is the person who executes the correction. 1. Accountable basis lead for infrastructure stability and database sizing. 2. Responsible basis team for archiving execution and HANA optimization. 3. Consulted PP functional lead for retention rules and production data validation. 4. Informed project lead for go-live risk assessment. Infrastructure accountability remains with basis, but functional validation protects business continuity.
Ownership, who actually fixes it.
Performance stabilization requires structured data governance, not hardware scaling alone. 1. Basis lead defines archiving strategy and executes technical cleanup. 2. PP functional lead validates which historical production data must be retained. 3. Basis team monitors memory usage and adjusts system parameters. 4. Project lead enforces cutoff dates and retention governance policies.
Who gets blamed versus who owns it.
1. Blamed HANA for being slow. 2. Blamed SAP for performance regression. 3. Actual owner basis lead for infrastructure and archiving governance. 4. Root cause, years of unarchived production history migrated without cleanup.
How this is actually fixed, the right way by a role.
1. Basis lead defines structured archiving and retention strategy before conversion. 2. Basis team executes mass archiving of obsolete production orders and confirmations. 3. PP functional lead confirms business retention compliance. 4. Project lead ensures archiving is mandatory milestone before production cutover.
What not to do, common wrong fixes.
1. Upgrading hardware without addressing data volume. 2. Ignoring readiness check volume warnings. 3. Archiving after go live under production pressure. 4. Assuming HANA performance eliminates need for governance. Hardware scaling does not replace data discipline.
Follow-up 1. Why does performance degrade only after go live?
Answer: test environments rarely simulate full production volume and concurrency. Real production workload combines historical data, parallel users, and background jobs. This exposes volume and memory pressure that testing did not replicate.
Follow-up 2. Can archiving be postponed until after stabilization?
Answer: technically yes, but risky. Postponing cleanup increases runtime instability and impacts business users. Archiving should be treated as a pre-conversion milestone, not a post-go-live optimization.
Follow-up 3. Curveball. Why do executives underestimate archiving risk?
Answer: because archiving is perceived as housekeeping rather than architecture. In S/4HANA, data volume directly affects runtime performance. What looks like a minor technical activity can determine system stability.
Exclusive pro tip.
If you skip archiving before conversion, you are not migrating a system. You are migrating technical debt into a faster database.
Scenario 24. aATP custom rules and BOP gaps.
During ECC to S/4HANA conversion, classic ATP logic and backorder processing configurations are not automatically migrated to advanced ATP. After go live, sales orders behave differently, confirmations are reduced, and production planning receives unstable demand signals.
Scenario classification.
1. Complexity, high demand planning distortion. 2. Phase, pre-conversion and post-go live. 3. Primary ownership, SD functional lead. 4. Supporting PP functional lead. 5. Business ownership sales director.
Diagnostic dashboard, symptoms and evidence.
How advanced ATP logic gaps impact planning reliability and how to detect them early. 1. Symptom sales order confirmations differ from ECC behavior. 2. Red flag backorder processing results appear inconsistent after migration. 3. Business impact production plans change frequently due to unstable confirmations. 4. Detection readiness check highlights missing mapping between classic ATP and advanced ATP rules. 5. Technical proof advanced ATP simulation shows rule gaps compared to historical ECC confirmations. Insight when confirmations shift, planning stability collapses.
Why this happens, scenario analysis and root cause.
1. ECC used classic ATP logic embedded within SD configuration. 2. S/4HANA Advanced ATP requires explicit rule and scope of check redesign. 3. Custom backorder processing logic is not automatically transferred. 4. Migration activates a new confirmation engine without replicating legacy behavior. Advanced ATP is a redesign, not an upgrade.
Why this is a migration, exclusive failure.
1. Classic ATP behavior worked predictably in ECC. 2. Advanced ATP introduces rule-based logic requiring reconfiguration. 3. Conversion does not auto-translate legacy backorder processing strategies. 4. Demand confirmation logic changes only during migration. What was implicit in ECC becomes explicit in S/4HANA.
Governance and accountability, RACI model.
Accountable is the person who gets fired if it fails. Responsible is the person who executes the correction. 1. Accountable SD functional lead for confirmation strategy architecture. 2. Responsible SD configuration team for advanced ATP rule setup. 3. Consulted PP functional lead for planning impact validation. 4. Informed sales business process owner for customer commitment alignment. Demand architecture ownership sits with sales, but planning stability depends on cross-module validation.
Ownership, who actually fixes it.
Stabilizing demand confirmation requires structured rule redesign, not reactive order changes. 1. SD functional lead redesigns advanced ATP rule sets and backorder processing logic. 2. SD configuration team maps legacy confirmation logic to new rule framework. 3. PP functional lead validates demand signal impact on MRP stability. 4. Sales director approves revised confirmation governance model.
Who gets blamed versus who owns it.
1. Blamed production planning for unstable schedules. 2. Blamed system performance for confirmation changes. 3. Actual owner SD functional lead for demand architecture redesign. 4. Root cause advanced ATP introduced without proper legacy rule mapping.
How this is actually fixed, the right way by a role.
1. SD functional lead documents and redesigns advanced ATP confirmation logic. 2. SD team performs structured rule testing and backorder processing simulation. 3. PP functional lead validates impact on production plan stability. 4. Sales director signs off on revised confirmation governance.
What not to do, common wrong fixes.
1. Manually adjusting confirmations without redesigning rules. 2. Blaming MRP for demand instability. 3. Ignoring advanced ATP readiness warnings. 4. Replicating ECC logic without understanding advanced ATP framework. Confirmation governance must be redesigned, not copied.
Follow-up 1. Why is advanced ATP not automatically aligned with ECC logic?
Answer: advanced ATP uses a different architecture based on rule frameworks and scope of check definitions. ECC confirmations were often implicit in configuration. Migration requires deliberate redesign rather than automatic translation.
Follow-up 2. How does this impact production planning stability?
Answer: when confirmations change unpredictably, MRP receives fluctuating demand signals. This causes frequent replanning and increases schedule volatility. Production reliability depends on stable confirmation governance.
Follow-up 3. Curveball. Why do organizations underestimate ATP migration complexity?
Answer: because ATP is perceived as a sales configuration topic. In reality, it drives demand architecture across planning and production. Advanced ATP redesign can fundamentally shift how commitments are calculated.
Exclusive pro tip.
If you migrate to advanced ATP without redesigning confirmation logic, you are not upgrading availability. You are redefining demand behavior.
Scenario 25. Mandatory data archiving not performed.
During ECC to S/4HANA conversion, historical production orders, confirmations, and planning data are migrated without proper archiving discipline. The system technically converts successfully, but after go live, HANA tables grow rapidly, and performance degradation appears across planning and reporting processes.
Scenario classification.
1. Complexity, critical performance and stability risk. 2. Phase, pre-conversion and post-go live. 3. Primary ownership basis lead. 4. Supporting project lead sign-off. 5. Business ownership operations director.
Diagnostic dashboard, symptoms and evidence.
How insufficient archiving silently impacts system stability and how to detect it early. 1. Symptom, MRP Live and production reports slow down progressively after go live. 2. Red flag, HANA memory consumption grows rapidly without business volume increase. 3. Business impact, planning runtime increases and shop floor decisions are delayed. 4. Detection, readiness check identifies excessive historical data volumes in production tables. 5. Technical proof, table growth analysis shows abnormal size in order and confirmation history tables. Insight, performance collapse rarely starts with configuration. It starts with ignored data discipline.
Why this happens, scenario analysis and root cause.
1. ECC systems accumulated years of historical production data without structured archiving. 2. S/4HANA architecture is sensitive to unnecessary data volume. 3. Conversion migrates technical history but does not enforce retention policies. 4. Project timelines often prioritize conversion speed over data rationalization. Migration transfers data volume. It does not correct data governance.
Why this is a migration, exclusive failure.
1. ECC performance masked excessive data growth over time. 2. S/4HANA consolidates and accelerates data access, exposing inefficiencies immediately. 3. Readiness checks highlight archiving gaps that never triggered visible runtime failures. 4. The shift to HANA makes legacy data volume a strategic performance risk. S/4HANA performance requires disciplined data lifecycle management.
Governance and accountability, RACI model.
Accountable is the person who gets fired if it fails. Responsible is the person who executes the correction. 1. Accountable basis lead for system performance governance. 2. Responsible basis team for executing archiving and retention configuration. 3. Consulted PP functional lead for retention policy validation. 4. Informed operations director for performance and planning stability awareness. Infrastructure ownership lies with basis, but functional validation ensures operational continuity.
Ownership, who actually fixes it.
Archiving is not a technical cleanup task. It is a governance decision. 1. Basis lead defines and executes structured archiving strategy before conversion. 2. Basis team monitors table growth and memory allocation after go live. 3. PP functional lead validates business data retention requirements. 4. Project lead signs off on acceptable data retention scope.
Who gets blamed versus who owns it.
1. Blamed HANA database for slow performance. 2. Blamed MRP Live for runtime spikes. 3. Actual owner basis lead for data lifecycle governance. 4. Root cause historical data migrated without archiving discipline.
How this is actually fixed, the right way by a role.
1. Basis lead implements archiving objects for production orders and confirmations. 2. Basis team performs pre-conversion data volume analysis and cleanup. 3. PP functional lead confirms retention rules meet operational requirements. 4. Project lead enforces archiving completion before final conversion approval.
What not to do, common wrong fixes.
1. Ignoring readiness check warnings about data volume. 2. Blaming database performance without archiving analysis. 3. Attempting hardware scaling without addressing retention policies. 4. Postponing archiving until after go-live stabilization. Hardware scaling cannot compensate for poor data governance.
Follow-up 1. Why did ECC not show performance degradation earlier?
Answer: ECC database architecture and indexing patterns masked slow accumulation of historical data. Performance degradation appeared gradually. S/4HANA architecture surfaces volume and efficiencies more aggressively due to in-memory processing.
Follow-up 2. Can archiving be safely done after go live?
Answer: yes, but it increases risk during stabilization. Post-go-live archiving requires careful coordination to avoid locking or performance interruptions. Pre-conversion archiving reduces system shock significantly.
Follow-up 3. Curveball. Why do executive teams underestimate archiving importance?
Answer: because archiving does not deliver visible business features. It is seen as maintenance work. In reality, it is foundational to system scalability and long-term performance stability.
Exclusive pro tip.
If you migrate 10 years of production history without a retention strategy, you are not future-proofing the system. You are importing performance debt.
Scenario 26. aATP product allocation not identified during readiness.
During ECC to S/4HANA conversion, classic ATP or product allocation logic is assumed to behave the same in S/4HANA. After go live, confirmed quantities change unexpectedly because advanced available to promise enforces different allocation rules that were never identified in readiness analysis.
Scenario classification.
1. Complexity critical order fulfillment risk. 2. Phase pre-conversion and post-go live. 3. Primary ownership SD functional lead. 4. Supporting basis lead readiness check. 5. Business ownership sales operations director.
Diagnostic dashboard, symptoms and evidence.
How allocation logic changes appear in sales and planning and how to detect them early. 1. Symptom sales orders confirm different quantities compared to ECC. 2. Red flag advanced available to promise configuration not fully mapped from classic logic. 3. Business impact customer delivery commitments become unreliable and disputes increase. 4. Detection. Readiness check identifies migration to advanced available to promise without rule mapping validation. 5. Technical proof. Backorder processing results differ when simulation is executed in S/4HANA. Insight. If confirmations change after migration, it is usually allocation logic, not stock.
Why this happens, scenario analysis and root cause.
1. Classic available to promise logic in ECC use simpler confirmation rules. 2. S/4HANA advanced available to promise introduces new allocation and prioritization algorithms. 3. Product allocation objects were not reconfigured during migration preparation. 4. Readiness focus remained on master data rather than allocation governance. S/4HANA does not replicate classic confirmation behavior automatically.
Why this is a migration, exclusive failure.
1. ECC and S/4HANA use fundamentally different confirmation engines. 2. Advanced available to promise replaces classic logic during conversion. 3. Allocation objects require manual redesign rather than technical conversion. 4. Behavior shift occurs only when advanced available to promise becomes active. What was predictable in ECC becomes algorithm-driven in S/4HANA.
Governance and accountability, RACI model.
Accountable is the person who gets fired if it fails. Responsible is the person who executes the correction. 1. Accountable SD functional lead for allocation strategy governance. 2. Responsible SD configuration team for advanced available to promise rule setup. 3. Consulted PP functional lead for supply alignment impact. 4. Informed sales operations director for delivery commitment validation. Allocation governance sits with sales, while cross-module validation protects planning stability.
Ownership, who actually fixes it.
Fixing allocation drift requires redesigning confirmation logic, not manual overrides. 1. SD functional lead redesigns product allocation and prioritization strategy. 2. SD configuration team maps advanced available to promise rules correctly. 3. PP functional lead validates supply alignment impact on production planning. 4. Sales operations director approves final confirmation logic behavior.
Who gets blamed versus who owns it.
1. Blamed system because confirmations look incorrect. 2. Blamed inventory levels for insufficient stock. 3. Actual owner, SD functional lead for allocation governance. 4. Root cause, advanced available to promise activated without strategic mapping.
How this is actually fixed, the right way by a role.
1. SD functional lead defines allocation and prioritization business rules. 2. SD configuration team configures advanced available to promise objects correctly. 3. PP functional lead validates planning impact across plants. 4. Business process owner performs controlled backorder simulation testing.
What not to do, common wrong fixes.
1. Manually adjusting confirmations without reviewing allocation rules. 2. Disabling advanced available to promise without business impact assessment. 3. Assuming classic available to promise behavior will replicate automatically. 4. Blaming stock accuracy without analyzing allocation configuration. Manual corrections hide configuration flaws and create recurring instability.
Follow-up 1. Why is advanced available to promise more complex than classic logic?
Answer: advanced available to promise introduces rule-based prioritization, backorder processing, and product allocation strategies. Classic logic was simpler and less restrictive. Migration replaces a static confirmation engine with a rule-driven allocation framework.
Follow-up 2. Can we avoid using advanced available to promise?
Answer: technically possible in limited scenarios, but most S/4HANA environments activate it by default. Avoiding it reduces functionality and does not eliminate the need for allocation governance.
Follow-up 3. Curveball. Why do planners assume stock is wrong instead of allocation?
Answer: because allocation logic is less visible than inventory levels. Users see quantity differences and assume stock issues. In reality, prioritization rules may be reallocating supply based on strategic configuration.
Exclusive pro tip.
Before activating advanced available to promise in production, simulate high-volume backorder scenarios. Allocation logic errors surface faster under competitive demand conditions.
Category 1 wrap-up. Structural risks are silent until enforced.
Pre-conversion structural and data risks are not system bugs. They are architectural gaps that ECC tolerated for years. S/4HANA does not create these failures. It exposes them by enforcing stricter planning, valuation, and governance rules.
Transition from structural readiness to conversion execution.
If Category 1 was about cleaning the foundation, Category 2 is about surviving the surgery. This is where technical execution, downtime pressure, and hidden technical debt collide during the actual conversion window.
Category 2. During conversion window incidents.
Focus, technical execution, and technical debt. These incidents occur during SUM execution, data migration runs, and system downtime. They are not theoretical design flaws. They are real-time failures that can delay cutover, corrupt transactional integrity, or destabilize production planning before go live.
Scenarios covered in Category 2.
Scenario 27 MRP Live Activation Conflicts. Primary owner PP functional lead. Supporting basis lead. Scenario 28 Planning file PPH_DBVM conversion. Primary owner basis lead. Supporting PP functional lead validation. Scenario 29 AFKO and AFPO table inconsistencies. Primary owner basis lead. Supporting ABAP lead remediation. Scenario 30 Production order conversion runtime spike. Primary owner basis lead. Supporting PP functional lead. Scenario 31 Capacity recalculation runtime overrun. Primary owner basis lead. Supporting PP functional lead. Scenario 32 Lock conflicts during SUM. Primary owner basis lead. Supporting not applicable. Scenario 33 Ledger realignment affecting work in progress. Primary owner FI functional lead. Supporting CO functional lead. Scenario 34 Open order settlement conflicts. Primary owner CO functional lead. Supporting PP functional lead. Scenario 35 Material ledger mandatory impact on orders. Primary owner CO functional lead. Supporting MM functional lead and PP functional lead. Scenario 36 Number range conflicts technical. Primary owner basis lead. Supporting PP functional lead. Scenario 37 SPDD and SBAU removes PP enhancements. Primary owner ABAP lead. Supporting PP functional lead. Scenario 38 Migration cockpit failures. Primary owner data migration lead. supporting PP functional lead. Scenario 39. Background jobs overlap during downtime. Primary owner basis lead, supporting PP functional lead scheduling. Scenario 40. Order status corruption during conversion. Primary owner ABAP lead, supporting PP functional lead. Scenario 41. Data freeze management failure. Primary owner project manager, supporting functional leads. Scenario 42. PPDS license and activation conflicts. Primary owner basis lead, supporting solution architect. Scenario 43. Embedded PPDS migration failures. Primary owner PPDS lead, supporting basis lead.
Scenario 27. MRP Live activation conflicts.
During ECC to S/4HANA conversion, MRP Live activation creates unexpected conflicts in planning configuration. What worked under classic MD01 begins to fail or produce inconsistent results once MD01N becomes active. Planning jobs terminate, materials are skipped, and cutover timelines are immediately threatened.
Scenario classification.
1. Complexity critical planning architecture shift. 2. Phase during conversion window. 3. Primary ownership PP functional lead. 4. Supporting basis lead. 5. Business ownership planning manager BPO.
Diagnostic dashboard, symptoms and evidence.
How this failure manifests during activation and how to detect it early. 1. Symptom: MD01N produces fewer planned orders compared to ECC MD01. 2. Red flag: activation logs show unsupported configuration objects for MRP Live. 3. Business impact: planning reliability collapses immediately before go live. 4. Detection: conversion testing reveals discrepancies between classic MRP and MRP Live results. 5. Technical proof: job logs highlight materials excluded from MRP Live due to unsupported features. Insight: if planning output changes drastically, the issue is architectural, not performance.
Why this happens, scenario analysis and root cause.
1. MRP Live uses optimized HANA-based logic different from classic MRP. 2. Certain custom enhancements are not compatible with MRP Live. 3. Unsupported planning features are silently ignored in MD01N. 4. Activation occurs during conversion, exposing planning model gaps. MRP Live is not a faster MD01. It is a different planning engine.
Why this is a migration-exclusive failure.
1. Classic MRP logic was tolerant of custom enhancements. 2. MRP Live enforces strict compatibility rules. 3. Activation happens only during ECC to S/4HANA conversion. 4. The planning engine shift exposes hidden technical debt. This conflict appears only when the engine is replaced.
Governance and accountability, RACI model.
In ECC to S/4HANA Brownfield programs, ownership follows a RACI model. Accountable is the person who gets fired if it fails. Responsible is the person who does the work. 1. Accountable PP functional lead for planning architecture sign-off. 2. Responsible basis lead for activation execution and runtime validation. 3. Consulted ABAP lead for enhancement compatibility analysis. 4. Informed planning business process owner for operational validation. Accountable owns the outcome. Responsible executes the technical activation.
Ownership, who actually fixes it.
Fixing this requires planning redesign, not engine rollback. 1. PP functional lead reviews planning configuration and removes unsupported features. 2. Basis lead executes activation and monitors runtime performance. 3. ABAP lead adapts incompatible enhancements to HANA-compliant logic. 4. Planning manager validates output stability through regression testing.
Who gets blamed versus who owns it.
1. Blamed basis because activation failed. 2. Blamed SAP because MD01 and output differs. 3. Actual owner PP functional lead for planning model governance. 4. Root cause architectural mismatch between classic MRP and MRP Live.
How this is actually fixed, the right way by a role.
1. PP functional lead standardizes planning logic to MRP Live supported scope. 2. ABAP lead reimplements incompatible logic using HANA-compliant methods. 3. Basis lead validates job execution stability after activation. 4. Planning business process owner signs off planning consistency before go live.
What not to do, common wrong fixes.
1. Deactivating MRP Live without root cause analysis. 2. Blaming performance instead of reviewing configuration. 3. Forcing classic logic through unsupported enhancements. 4. Skipping regression comparison between MD01 and MD01N. Rolling back activation delays the problem. It does not solve it.
Follow-up 1. Why does MD01 still appear to work while MD01N fails?
Answer: classic MD01 uses legacy planning logic that tolerates custom enhancements and flexible configuration. MD01N relies on optimized HANA-based algorithms with stricter compatibility rules. The difference is architectural, not performance-related.
Follow-up 2. Can MRP Live be safely postponed?
Answer: temporarily yes, but long-term no. S/4HANA is designed around MRP Live as the primary planning engine. Postponing activation delays architectural alignment and increases technical debt.
Follow-up 3. Curveball. Why do planning differences sometimes look like data errors?
Answer: because when planning output changes, business users assume master data corruption. In reality, the planning engine logic has changed. The data is correct, but the algorithm applying it is different.
Exclusive pro tip.
Before activating MRP Live in production, perform controlled comparison runs between MD01 and MD01N. Treat output differences as architectural signals, not system bugs.
Scenario 28. Planning file conversion errors.
During ECC to S/4HANA conversion, inconsistencies in the planning file table pph_dbvm cause unexpected planning failures. Materials that should be planned are ignored, while others are incorrectly flagged. The issue surfaces during cutover testing and threatens production readiness.
Scenario classification.
1. Complexity high planning stability risk. 2. Phase during conversion window. 3. Primary ownership basis lead. 4. Supporting PP functional lead. 5. Business ownership planning manager BPO.
Diagnostic dashboard, symptoms and evidence.
How this failure appears during conversion testing and how to detect it early. 1. Symptom: MRP Live does not plan materials that previously generated proposals in ECC. 2. Red flag: conversion logs show inconsistencies in pph_dbvm planning file entries. 3. Business impact: material shortages occur due to missing procurement proposals. 4. Detection: pre-go live MRP simulation highlights unexplained gaps in net requirements. 5. Technical proof: planning file consistency checks show missing or corrupted indicators. Insight: when MRP skips materials silently, check the planning file first.
Why this happens, scenario analysis and root cause.
1. S/4HANA replaces classic planning file logic with HANA-optimized structures. 2. Conversion programs rebuild planning file entries from legacy data. 3. Pre-existing inconsistencies in ECC are exposed during transformation. 4. Incomplete planning file regeneration leads to inaccurate planning triggers. The issue is not MRP logic. It is the trigger mechanism behind it.
Why this is a migration-exclusive failure.
1. ECC tolerated minor planning file inconsistencies. 2. S/4HANA enforces strict trigger-based planning logic. 3. Planning file regeneration occurs only during conversion. 4. Structural inconsistencies surface only when tables are rebuilt. Migration reconstructs planning foundations and reveals hidden defects.
Governance and accountability, RACI model.
In ECC to S/4HANA Brownfield programs, ownership follows a RACI model. Accountable is the person who gets fired if it fails. Responsible is the person who performs the technical correction. 1. Accountable basis lead for successful technical conversion execution. 2. Responsible basis lead for planning file regeneration and consistency validation. 3. Consulted PP functional lead for planning validation and business impact analysis. 4. Informed planning business process owner for operational readiness. Accountability lies with conversion execution. Validation lies with functional governance.
Ownership, who actually fixes it.
Fixing planning file issues requires coordinated technical and functional validation. 1. Basis lead runs planning file consistency reports and regeneration programs. 2. PP functional lead validates that plan materials generate correct proposals. 3. ABAP lead supports if custom planning enhancements interfere with triggers. 4. Planning manager signs off after regression testing confirms stability.
Who gets blamed versus who owns it?
1. Blamed PP team because materials are not planned. 2. Blamed SAP because MRP appears inconsistent. 3. Actual owner basis lead for planning file technical integrity. 4. Root cause legacy inconsistencies exposed during table reconstruction.
How this is actually fixed, the right way by a role.
1. Basis lead executes full planning file regeneration using standard programs. 2. PP functional lead conducts controlled MRP test cycles across key materials. 3. ABAP lead reviews and adapts any custom planning triggers if required. 4. Planning business process owner confirms operational alignment before go live.
What not to do, common wrong fixes.
1. Running MRP repeatedly without fixing planning file inconsistencies. 2. Assuming missing proposals are master data errors. 3. Ignoring minor warnings in conversion logs. 4. Proceeding to go live without cross-plant planning validation. Repeated MRP runs do not fix structural trigger problems.
Follow-up 1. Why do some materials plan correctly while others fail?
Answer: because planning file indicators are material specific. If regeneration partially succeeds, some entries are rebuilt correctly while others remain inconsistent. The inconsistency creates selective planning failures.
Follow-up 2. Can a full MRP run correct planning file errors automatically?
Answer: no. MRP relies on planning file triggers to determine what to plan. If those triggers are corrupted, MRP will not evaluate the material correctly. Regeneration of the planning file structure is required.
Follow-up 3. Curveball. Why does this often get misdiagnosed as performance degradation?
Answer: because users see missing proposals and assume the system skipped processing due to speed issues. In reality, the trigger table itself is inconsistent. The engine never receives the signal to plan.
Exclusive pro tip.
Always perform a complete planning file regeneration before go live. Treat planning triggers as architectural infrastructure, not transactional data.
Scenario 29. AFKO and AFPO table inconsistencies.
During ECC to S/4HANA conversion, inconsistencies between production order header table AFKO and item table AFPO surfaced during technical validation. Orders that appeared stable in ECC begin throwing structural errors, blocking further processing and creating cutover instability.
Scenario classification.
1. Complexity critical conversion blocking. 2. Phase during conversion window. 3. Primary ownership basis lead. 4. Supporting ABAP lead. 5. Business ownership PP functional lead.
Diagnostic dashboard, symptoms and evidence.
How this structural inconsistency appears during technical conversion and how to detect it early. 1. Symptom: production orders fail validation during SUM or early post-conversion testing. 2. Red flag: conversion logs show header item mismatch errors for specific order numbers. 3. Business impact: open production orders cannot be processed or settled. 4. Detection: pre-conversion consistency checks highlight missing or orphan records. 5. Technical proof: table comparison reports show record count mismatch between AFKO and AFPO. Insight: when header and item counts differ, structural integrity is already compromised.
Why this happens, scenario analysis and root cause.
1. Historical inconsistencies accumulated through manual corrections in ECC. 2. Custom reports updated one table without updating the related table. 3. Legacy repair programs fix transactional symptoms but not relational integrity. 4. S/4HANA conversion enforces strict relational consistency validation. ECC tolerated silent inconsistencies. S/4HANA enforces structural discipline.
Why this is a migration-exclusive failure.
1. ECC allowed minor structural inconsistencies without blocking execution. 2. S/4HANA conversion performs deep relational validation. 3. The conversion rebuilds order structures and cross-references. 4. Latent data defects surface only when technical enforcement begins. Migration does not create corruption. It exposes it.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, accountable is the person who gets fired if the conversion fails. Responsible is the person who executes the technical correction. 1. Accountable basis lead for technical conversion stability. 2. Responsible ABAP lead for remediation scripts and data correction programs. 3. Consulted PP functional lead for validation of corrected order structures. 4. Informed production business process owner regarding order impact. Structural integrity during conversion is owned technically but validated functionally.
Ownership, who actually fixes it.
Fixing table inconsistencies requires controlled technical remediation and functional validation. 1. ABAP lead develops correction utilities to realign header and item records. 2. Basis lead reruns technical validation after data repair. 3. PP functional lead verifies order integrity and status consistency. 4. Production manager confirms operational usability of corrected orders.
Who gets blamed versus who owns it.
1. Blamed basis because conversion stopped. 2. Blamed SAP for enforcing strict validation. 3. Actual owner technical data governance oversight from legacy ECC. 4. Root cause historical inconsistencies ignored during steady-state operations.
How this is actually fixed, the right way by a role.
1. ABAP lead executes controlled repair scripts to synchronize header and item tables. 2. Basis lead performs integrity rechecks before restarting conversion. 3. PP functional lead validates corrected orders against business scenarios. 4. Project manager ensures no new inconsistent orders are created during freeze.
What not to do, common wrong fixes.
1. Deleting corrupted production orders without impact analysis. 2. Manually updating database tables directly in production. 3. Restarting conversion without full relational validation. 4. Ignoring minor inconsistencies assuming they will self-correct. Direct database fixes without governance can create audit exposure.
Follow-up 1. Why did these inconsistencies not block ECC operations?
Answer: ECC execution logic focused on transactional processing and often tolerated minor relational defects. As long as operational transactions worked, structural misalignment remained hidden. S/4HANA conversion introduces stricter integrity checks.
Follow-up 2. Can this be prevented before conversion?
Answer: yes. Running data consistency reports and reconciling order tables months before conversion significantly reduces risk. Proactive technical validation prevents emergency remediation during the conversion window.
Follow-up 3. Curveball. Why do some companies still ignore minor relational warnings?
Answer: because the system appears operational. When daily execution works, structural warnings are deprioritized. Migration changes the tolerance threshold and forces architectural correctness.
Exclusive pro tip.
Treat relational consistency as architectural hygiene. If header and item tables disagree before conversion, S/4HANA will enforce the correction during conversion.
Scenario 30. Production order conversion runtime spike.
During ECC to S/4HANA conversion, the technical migration of open production orders takes significantly longer than estimated. SUM phases stall, background processes consume excessive memory, and the downtime window starts slipping, creating executive-level pressure.
Scenario classification.
1. Complexity critical downtime risk. 2. Phase during conversion window. 3. Primary ownership basis lead. 4. Supporting PP functional lead. 5. Business ownership project sponsor.
Diagnostic dashboard, symptoms and evidence.
How this runtime spike appears during cutover and how to detect it early. 1. Symptom: SUM execution phase related to order conversion exceeds planned runtime. 2. Red flag: CPU and memory utilization spike during order data transformation. 3. Business impact: go live timeline at risk due to extended downtime window. 4. Detection: pre-conversion sizing reports show unusually high volume of open or historical production orders. 5. Technical proof: SUM logs display prolonged execution in order transformation steps. Insight: volume is not the only risk. Poorly archived data multiplies runtime impact.
Why this happens, scenario analysis and root cause.
1. Large volume of open or technically complete production orders not archived in ECC. 2. Complex historical order structures requiring transformation into S/4HANA-compatible format. 3. Custom enhancements attached to order tables increase transformation overhead. 4. Underestimated system sizing assumptions during planning phase. Conversion runtime reflects years of data accumulation.
Why this is a migration-exclusive failure.
1. ECC steady-state operations do not reprocess all historical orders simultaneously. 2. S/4HANA conversion transforms every relevant order structure in one execution window. 3. The technical enforcement occurs only during migration. 4. Downtime pressure amplifies impact of data volume and structural complexity. This risk exists only when the entire order history is revalidated at once.
Governance and accountability, RACI model.
In brownfield migrations, accountable means the person who gets fired if downtime fails. Responsible means the person executing the technical remediation. 1. Accountable basis lead for technical conversion performance. 2. Responsible basis team for system sizing, monitoring, and runtime optimization. 3. Consulted PP functional lead for identifying unnecessary open orders. 4. Informed project sponsor and steering committee. Infrastructure stability during conversion is a technical accountability with functional validation.
Ownership, who actually fixes it.
Runtime spikes require both technical and functional mitigation. 1. Basis lead optimizes system parameters and validates hardware sizing. 2. PP functional lead identifies and closes unnecessary open production orders before conversion. 3. Data team executes archival of historical completed orders. 4. Project manager adjusts downtime planning based on revised estimates.
Who gets blamed versus who owns it.
1. Blamed basis for slow system performance. 2. Blamed SAP for inefficient conversion process. 3. Actual owner data governance and pre-conversion cleanup oversight. 4. Root cause years of unarchived transactional buildup.
How this is actually fixed, the right way by a role.
1. Basis lead performs performance simulations and hardware validation before cutover. 2. PP functional lead closes or technically completes unnecessary orders. 3. Data team archives historical orders to reduce transformation volume. 4. Steering committee approves revised downtime window if required.
What not to do, common wrong fixes.
1. Ignoring order volume assumptions during readiness planning. 2. Attempting last-minute deletion of orders without impact validation. 3. Blaming hardware without analyzing data volume. 4. Reducing testing cycles to compensate for lost downtime. Downtime shortcuts create post-go-live instability.
Follow-up 1. Why was runtime underestimated?
Answer: because conversion sizing often focuses on database size rather than transactional object complexity. Production orders carry dependencies such as components, confirmations, and settlements. Each object increases transformation overhead.
Follow-up 2. Can simulation prevent this?
Answer: yes. Dry run conversions and performance benchmarks provide realistic runtime estimates. Without simulation, downtime planning relies on theoretical projections rather than empirical evidence.
Follow-up 3. Curveball. Why do sponsors push unrealistic downtime windows?
Answer: because conversion is often seen as a technical upgrade rather than a full system revalidation. Business leadership may underestimate the structural transformation happening beneath the surface.
Exclusive pro tip.
Archiving is not optional before conversion. Every unnecessary open order increases transformation runtime and executive risk.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP Consultant jobs, SAP FICO Consultant jobs, SAP SD Consultant jobs, SAP PP Consultant jobs, SAP Ariba Consultant jobs, SAP Extended Warehouse Management EWM, consultant jobs, SAP plant maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Scenario 31. Capacity Recalculation Runtime Overrun.
During ECC to S/4HANA conversion, capacity data linked to work centers is recalculated under new logic. What appears as a simple structural adjustment triggers excessive runtime, delaying conversion phases and stressing the downtime window.
Scenario Classification.
1. Complexity, high downtime risk. 2. Phase during conversion window. 3. Primary ownership basis lead. 4. Supporting PP functional lead. 5. Business ownership manufacturing operations head.
Diagnostic Dashboard, Symptoms and Evidence.
How this issue surfaces during cutover and how to detect it early. 1. Symptom, conversion phases related to work centers and capacity run significantly longer than estimated. 2. Red flag, high CPU utilization during capacity transformation steps. 3. Business impact, downtime extension risk and delayed production restart. 4. Detection, pre-conversion checks show complex capacity formulas and high work center volume. 5. Technical proof, SUM logs show prolonged execution in capacity recalculation routines. Insight, capacity data complexity multiplies conversion effort.
Why this happens, Scenario Analysis and Root Cause.
1. Work centers contain complex capacity formulas accumulated over years. 2. Custom enhancements extend standard capacity calculation logic. 3. Large number of historical capacity requirements linked to open orders. 4. Underestimated impact of recalculation during migration. Capacity transformation revalidates structural assumptions.
Why this is a migration-exclusive failure.
1. ECC does not reprocess all historical capacity data simultaneously. 2. S/4HANA conversion forces structural recalculation in one execution window. 3. Capacity formulas are validated under new architectural constraints. 4. The transformation stress occurs only during migration. Steady-state operations never expose this load.
Governance and Accountability, RACI Model.
Accountable means the person who answers to leadership if downtime fails. Responsible means the person performing the technical execution. 1. Accountable basis lead for conversion performance stability. 2. Responsible basis team for runtime monitoring and parameter optimization. 3. Consulted PP functional lead for capacity structure validation. 4. Informed manufacturing operations leadership. Conversion governance separates technical accountability from functional validation.
Ownership, who actually fixes it.
Mitigation requires proactive sizing and data rationalization. 1. Basis lead validates hardware sizing and optimizes runtime parameters. 2. PP functional lead simplifies complex capacity formulas where possible. 3. Data team archives obsolete capacity requirements linked to closed orders. 4. Project manager recalibrates downtime assumptions based on simulation.
Who gets blamed versus who owns it.
1. Blamed basis for system slowdown. 2. Blamed SAP conversion tool performance. 3. Actual owner, structural data complexity and historical accumulation. 4. Root cause, underestimated work center and capacity model depth.
How this is actually fixed, the right way by a role.
1. Basis lead executes performance simulation before final cutover. 2. PP functional lead rationalizes and standardizes capacity formulas. 3. Data team cleans obsolete open capacity requirements. 4. Steering committee validates revised downtime window if required.
What not to do, common wrong fixes.
1. Ignoring complex work center structures during readiness. 2. Blaming hardware without reviewing data design. 3. Skipping performance rehearsal before final conversion. 4. Assuming capacity recalculation is negligible. Conversion discipline begins with structural simplicity.
Follow-up 1. Why are capacity formulas risky during migration?
Answer: capacity formulas often include custom logic accumulated over years. During migration, all of them are revalidated simultaneously. Complex formulas multiply processing time significantly.
Follow-up 2. Can reducing open orders help?
Answer: yes. Reducing open production orders decreases linked capacity requirements. This lowers transformation load and improves runtime predictability during conversion.
Follow-up 3. Curveball. Why does this rarely appear in sandbox conversions?
Answer: because sandbox systems usually contain limited data. Production scale complexity exposes runtime bottlenecks that test systems cannot replicate.
Exclusive pro tip.
Capacity design simplicity is a migration advantage. The more complex the work center formulas, the higher the downtime risk.
Scenario 32. Lock conflicts during SUM.
During the ECC to S/4HANA conversion window, SUM execution encounters unexpected table locks related to production orders, reservations, or capacity tables. The upgrade pauses or fails because background processes or open sessions still hold locks on critical PP tables.
Scenario classification.
1. Complexity critical conversion blocking. 2. Phase during conversion window. 3. Primary ownership basis lead. 4. Supporting not applicable. 5. Business ownership project manager.
Diagnostic dashboard. Symptoms and evidence.
How this issue manifests during downtime and how to detect it early. 1. Symptom: SUM phase halts with table lock errors. 2. Red flag: active user sessions or background jobs still running in PP tables. 3. Business impact: downtime extension and production restart delays. 4. Detection: pre-cutover system check shows open production-related jobs or transactions. 5. Technical proof: SM12 and SUM logs show active locks on AFKO, AFPO, or related tables. Insight: conversion requires a clean technical state, not just user sign-off.
Why this happens. Scenario analysis and root cause.
1. Background jobs related to production planning were not fully stopped. 2. Users remained logged into production transactions during freeze. 3. Integration interfaces continued posting during downtime. 4. Lock monitoring was not part of the final technical checklist. Even one active lock can halt an enterprise conversion.
Why this is a migration-exclusive failure.
1. Normal operations tolerate concurrent locks. 2. SUM requires exclusive control over critical tables. 3. Conversion enforces strict database consistency. 4. This level of locking enforcement exists only during migration. What is normal in daily operations becomes fatal during upgrade.
Governance and accountability. RACI model.
Accountable is the person who answers for downtime failure. Responsible is the person who performs the technical shutdown and validation. 1. Accountable basis lead for technical system integrity during conversion. 2. Responsible basis team for lock monitoring and job termination. 3. Consulted PP functional lead for confirmation that business freeze is respected. 4. Informed project manager and steering committee. Technical ownership during conversion cannot be delegated.
Ownership: who actually fixes it.
Resolution requires strict enforcement of freeze governance. 1. Basis lead validates no active locks exist before SUM execution. 2. Basis team stops and disables all production-related background jobs. 3. PP functional lead confirms business users are logged off and freeze is active. 4. Project manager enforces formal freeze confirmation before technical start.
Who gets blamed versus who owns it.
1. Blamed basis for upgrade interruption. 2. Blamed SAP tool stability. 3. Actual owner weak freeze governance and incomplete shutdown checklist. 4. Root cause operational discipline gap before technical start.
How this is actually fixed, the right way by a role.
1. Basis lead executes full lock validation using SM12 and database tools. 2. Basis team terminates residual sessions and background jobs. 3. PP functional lead validates no transactional activity continues. 4. Project manager formalizes freeze sign-off documentation.
What not to do, common wrong fixes.
1. Restarting SUM without investigating lock origin. 2. Blaming the tool without reviewing freeze checklist. 3. Allowing selective user access during downtime. 4. Skipping final lock verification before restart. Conversion discipline is measured in minutes of precision.
Follow-up 1. Why are locks more critical during migration than daily operations?
Answer: during daily operations, locks coordinate transactional consistency. During migration, the system requires exclusive control over structural tables. Any active lock prevents schema adjustments and data transformations.
Follow-up 2. How can teams prevent this proactively?
Answer: by running a dry run conversion with full freeze simulation. Lock monitoring must be part of the official technical checklist before downtime begins.
Follow-up 3. Curveball. Why do projects underestimate freeze governance?
Answer: because functional teams assume communication is enough. Technical conversion requires absolute enforcement, not verbal confirmation.
Exclusive pro tip.
Before pressing the conversion start button, verify locks as if your entire downtime window depends on it, because it does.
Scenario 33. Ledger realignment affecting WIP.
During ECC to S/4HANA conversion, ledger realignment and universal journal activation change how work in progress is calculated and stored. After technical conversion, open production orders show unexpected WIP balances or reconciliation gaps between production planning, controlling, and finance.
Scenario classification.
1. Complexity, critical financial exposure. 2. Phase during conversion window and first period close. 3. Primary ownership FI functional lead. 4. Supporting CO functional lead. 5. Business ownership finance controller.
Diagnostic dashboard, symptoms and evidence.
How this issue surfaces during financial validation and how to detect it early. 1. Symptom: WIP balances differ from pre-conversion values. 2. Red flag settlement simulation shows ledger-specific discrepancies. 3. Business impact period close delays and audit concerns. 4. Detection pre-conversion reconciliation between controlling and finance ledgers shows misalignment. 5. Technical proof. Post-conversion tables in Universal Journal reflect ledger-specific postings not present in ECC. Insight: if WIP does not reconcile, conversion architecture is incomplete.
Why this happens, scenario analysis and root cause.
1. S/4HANA introduces Universal Journal architecture. 2. Ledger realignment affects how controlling and finance integrate. 3. Open production orders carry legacy settlement logic. 4. Material ledger and parallel valuation settings amplify discrepancies. Financial architecture shifts during migration expose legacy inconsistencies.
Why this is a migration-exclusive failure.
1. ECC stored financial data across multiple tables. 2. S/4HANA consolidates controlling and finance into one journal. 3. Ledger conversion happens only during system transformation. 4. The shift activates reconciliation differences not visible before. Migration forces financial truth alignment.
Governance and accountability, RACI model.
Accountable is the person who answers for financial discrepancies. Responsible is the person executing the ledger validation and correction. 1. Accountable FI functional lead for ledger architecture and financial integrity. 2. Responsible finance team for reconciliation and validation of WIP balances. 3. Consulted CO functional lead for production order settlement alignment. 4. Informed finance controller and executive stakeholders. Financial ownership cannot be delegated during conversion.
Ownership, who actually fixes it.
Resolution requires coordinated financial validation. 1. FI functional lead validates ledger configuration and realignment settings. 2. CO functional lead reviews settlement rules of open production orders. 3. Finance team executes reconciliation between pre- and post-conversion balances. 4. Basis lead supports performance and data consistency checks during closing simulation.
Who gets blamed versus who owns it?
1. Blamed production planning for incorrect order data. 2. Blamed SAP conversion logic. 3. Actual owner, ledger configuration and financial governance. 4. Root cause misalignment between controlling and finance architecture.
How this is actually fixed, the right way by a role.
1. FI functional lead revalidates ledger realignment and universal journal configuration. 2. CO functional lead adjusts settlement rules where required. 3. Finance team performs controlled period close simulation before go live. 4. Project leadership enforces reconciliation sign-off before production restart.
What not to do, common wrong fixes.
1. Adjusting balances manually without root cause validation. 2. Ignoring minor WIP discrepancies assuming rounding issues. 3. Proceeding to go live without reconciliation documentation. 4. Blaming production orders without financial review. Financial shortcuts during migration become audit findings later.
Follow-up 1. Why does ledger realignment affect production orders?
Answer: production orders carry settlement logic tied to controlling and finance integration. When ledger structure changes, the posting logic and reporting layers shift, exposing differences.
Follow-up 2. Can WIP differences be ignored if small?
Answer: even small discrepancies can accumulate over periods and raise audit questions. Migration requires full financial transparency before period close.
Follow-up 3. Curveball. Why do finance teams often detect this first?
Answer: because financial reconciliation is the first true stress test of migration. Operational teams may not notice structural differences until finance validates balances.
Exclusive pro tip.
Always simulate a full period close in a conversion rehearsal. If WIP does not reconcile there, it will not reconcile in production.
Scenario 34. Open order settlement conflicts.
During ECC to S/4HANA conversion, open production orders with incomplete or inconsistent settlement rules create unexpected settlement errors. After go live, order settlement fails or posts to incorrect receivers, delaying financial close and creating cross-module reconciliation issues.
Scenario classification.
1. Complexity high period close risk. 2. Phase during conversion window and first settlement cycle. 3. Primary ownership CO functional lead. 4. Supporting PP functional lead. 5. Business ownership finance controller.
Diagnostic dashboard, symptoms and evidence.
How this issue appears during financial processing and how to detect it early. 1. Symptom: settlement run produces errors or incomplete postings. 2. Red flag: orders show missing or outdated settlement rules. 3. Business impact: month-end closes delayed and financial statements become unreliable. 4. Detection: pre-conversion validation reports show open orders without proper settlement receivers. 5. Technical proof: settlement logs display account assignment or receiver determination errors. Insight: settlement errors are rarely technical. They reflect configuration or governance gaps.
Why this happens, scenario analysis and root cause.
1. Open production orders were created under legacy controlling structures. 2. S/4HANA activates stricter integration between controlling and finance. 3. Settlement profiles or receivers were never standardized across plants. 4. Material ledger and universal journal changes amplify receiver inconsistencies. Conversion exposes settlement weaknesses that existed silently in ECC.
Why this is a migration-exclusive failure.
1. ECC allowed certain settlement inconsistencies without immediate impact. 2. S/4HANA enforces tighter validation at settlement execution. 3. Ledger alignment occurs only during system conversion. 4. Open legacy orders collide with new financial architecture. The failure is triggered by structural transition, not new business behavior.
Governance and accountability, RACI model.
Accountable is the person who answers for incorrect financial postings. Responsible is the person executing and correcting the settlement setup. 1. Accountable CO functional lead for settlement rule integrity. 2. Responsible CO team for reviewing and correcting open order receivers. 3. Consulted PP functional lead for production order structure validation. 4. Informed finance controller for close cycle approval. Financial accountability: cannot be delegated during conversion stabilization.
Ownership, who actually fixes it.
Resolution requires structured financial cleanup before go live. 1. CO functional lead reviews and standardizes settlement profiles. 2. PP functional lead validates production order master data consistency. 3. Finance team simulates settlement in a controlled test cycle. 4. Project manager ensures all open orders are validated before cut over.
Who gets blamed versus who owns it.
1. Blamed production planning for incorrect order setup. 2. Blamed system conversion logic. 3. Actual owner controlling configuration governance. 4. Root cause legacy settlement rules not aligned with S/4HANA financial architecture.
How this is actually fixed. The right way by a role.
1. CO functional lead cleans and updates settlement rules on open production orders. 2. PP functional lead verifies that order types align with settlement profiles. 3. Finance team executes controlled settlement simulation before go live. 4. Basis lead ensures background settlement jobs are scheduled correctly post-conversion.
What not to do. Common wrong fixes.
1. Manually posting corrective journal entries without fixing order settlement rules. 2. Closing orders prematurely to avoid reconciliation. 3. Ignoring settlement errors during first period close. 4. Blaming material ledger without reviewing configuration. Settlement shortcuts during migration create long-term financial risk.
Follow-up 1. Why do open orders create more risk than closed orders?
Answer: open orders carry active settlement rules and pending postings. When financial architecture changes during conversion, these live objects can produce errors or inconsistent allocations during the first close.
Follow-up 2. Can we technically convert without cleaning open orders?
Answer: yes, but financial risk increases significantly. Unclean open orders may pass technical conversion yet fail during settlement execution, creating reconciliation pressure during period close.
Follow-up 3. Curveball. Why do settlement issues often appear only after go live?
Answer: because settlement logic is triggered during actual financial closing cycles. Testing environments rarely simulate real volume and closing pressure, which exposes hidden configuration gaps.
Exclusive pro tip.
Before cutover, freeze new order creation and validate settlement integrity of all open orders. Conversion is not complete until financial settlement is proven stable.
Scenario 35. Material ledger mandatory impact on production orders.
During ECC to S/4HANA conversion, material ledger becomes mandatory. Production orders that were historically valuated under classic costing logic now operate under actual costing and multi-valuation structures. After go live, unexpected price differences and variance postings begin appearing in production order settlements.
Scenario classification.
1. Complexity critical financial architecture shift. 2. Phase during conversion window and first actual costing run. 3. Primary ownership CO functional lead. 4. Supporting MM functional lead and PP functional lead. 5. Business ownership finance director.
Diagnostic dashboard, symptoms and evidence.
How this structural shift appears in production costing and how to detect it early. 1. Symptom: production order variances increase unexpectedly after go live. 2. Red flag material ledger activation logs show new valuation areas or currencies. 3. Business impact: inventory valuation and production cost fluctuate unpredictably. 4. Detection: pre-conversion simulation of actual costing shows price differences not seen in ECC. 5. Technical proof: CKMLCP run generates unplanned revaluation postings. Insight: when costing behavior changes suddenly, the root is usually material ledger activation.
Why this happens, scenario analysis and root cause.
1. S/4HANA enforces material ledger as mandatory for all materials. 2. Actual costing logic introduces periodic price revaluation. 3. Legacy costing configuration did not account for parallel valuation layers. 4. Production orders now integrate directly with the universal journal. Material ledger is not an enhancement. It is a structural financial redesign.
Why this is a migration-exclusive failure.
1. ECC allowed classic costing without mandatory actual costing. 2. S/4HANA enforces material ledger activation during conversion. 3. Historical price structures collide with new valuation logic. 4. The change occurs only because of platform migration. The issue is triggered by system architecture enforcement, not user behavior.
Governance and accountability, RACI model.
Accountable means the person who answers for financial misstatement risk. Responsible means the team performing configuration and validation tasks. 1. Accountable, CO functional lead for valuation and costing integrity. 2. Responsible, CO team for configuring material ledger and actual costing. 3. Consulted, MM functional lead for inventory valuation settings. 4. Informed, finance director for financial statement approval. Material ledger activation requires coordinated financial governance.
Ownership, who actually fixes it.
Fixing this requires configuration alignment and simulation, not reactive postings. 1. CO functional lead aligns valuation areas and costing variance with material ledger structure. 2. MM functional lead validates inventory valuation configuration. 3. PP functional lead reviews production order costing integration. 4. Finance team executes controlled actual costing simulation before productive run.
Who gets blamed versus who owns it.
1. Blamed production planning for variance increase. 2. Blamed system performance or migration scripts. 3. Actual owner CO configuration of material ledger. 4. Root cause mandatory valuation redesign in S/4HANA.
How this is actually fixed, the right way by a role.
1. CO functional lead configures actual costing and parallel valuation structure. 2. MM functional lead verifies price control and valuation class alignment. 3. PP functional lead tests production order cost estimate consistency. 4. Basis lead ensures material ledger closing jobs execute in correct sequence.
What not to do, common wrong fixes.
1. Suppressing price difference postings to hide variance. 2. Changing price control settings without architectural review. 3. Running actual costing in production without sandbox validation. 4. Treating material ledger as optional configuration. Shortcuts in valuation logic create long-term audit exposure.
Follow-up 1. Why is material ledger mandatory in S/4HANA?
Answer: Material ledger supports real-time valuation, multiple currencies, and integration with the Universal Journal. S/4HANA financial architecture depends on this unified valuation model.
Follow-up 2. Does this always increase production variances?
Answer: Not necessarily. It increases transparency. Variances that were previously hidden within inventory valuation become visible under actual costing logic.
Follow-up 3. Curveball. Why do some companies experience inventory value drift months after go live?
Answer: Because actual costing recalculates periodically. If configuration or master data inconsistencies remain, cumulative revaluation impacts surface over multiple closing cycles.
Exclusive pro tip.
Before activating material ledger in production, simulate at least 2 full closing cycles in a controlled environment. True stability is proven only after actual costing behaves predictably.
Scenario 36. Number range conflicts during technical conversion.
During ECC to S/4HANA conversion, technical number range objects for production orders, planned orders, or reservations collide or overlap. After conversion, order creation fails or generates duplicate number errors, disrupting production execution.
Scenario classification.
1. Complexity high transaction blocking. 2. Phase during conversion window. 3. Primary ownership basis lead. 4. Supporting PP functional lead. 5. Business ownership production operations manager.
Diagnostic dashboard, symptoms and evidence.
How number range misalignment surfaces during or after cutover and how to detect it early. 1. Symptom: production order creation fails with number range interval errors. 2. Red flag: overlapping or exhausted intervals identified in SNR row before go live. 3. Business impact: shop floor order processing stops due to technical numbering conflicts. 4. Detection: pre-conversion number range audit reveals inconsistent internal and external intervals. 5. Technical proof: system logs show object-specific number range conflict messages. Insight, number ranges look technical, but they directly block operations.
Why this happens, scenario analysis and root cause.
1. Historical ECC systems often reused or manually adjusted number range intervals. 2. Conversion harmonizes technical objects and may reset intervals. 3. Parallel systems or legacy clients may share overlapping ranges. 4. Transport sequencing may overwrite corrected intervals during cutover. Number range governance is often ignored until it blocks transactions.
Why this is a migration-exclusive failure.
1. ECC tolerated legacy overlaps if operational usage never collided. 2. S/4HANA conversion consolidates technical objects under stricter controls. 3. Data freeze and cutover introduce timing risks for interval exhaustion. 4. The issue surfaces only when technical layers are restructured. Migration exposes structural weaknesses in numbering governance.
Governance and accountability, RACI model.
Accountable means the person who answers if transactions cannot be created. Responsible means the person executing the correction. 1. Accountable basis lead for technical number range integrity. 2. Responsible basis team for interval correction and transport control. 3. Consulted PP functional lead for object validation and impact review. 4. Informed production operations manager for operational readiness. Technical governance failures quickly become operational crises.
Ownership, who actually fixes it.
Correction must be controlled and synchronized across environments. 1. Basis lead audits and corrects all production-relevant number range objects. 2. PP functional lead validates correct object assignment for production orders and planned orders. 3. Transport management team ensures interval corrections are not overwritten. 4. Operations team confirms order creation works under productive load.
Who gets blamed versus who owns it.
1. Blamed PP functional team because orders cannot be created. 2. Blamed conversion tool for corrupting data. 3. Actual owner basis technical governance. 4. Root cause poor number range lifecycle control.
How this is actually fixed, the right way by a role.
1. Basis lead performs full number range reconciliation across all relevant objects. 2. PP functional lead validates alignment between order types and number range objects. 3. Basis team transports intervals carefully with freeze control during cutover. 4. Operations executes regression testing under real load conditions.
What not to do, common wrong fixes.
1. Manually adjusting intervals in production without documentation. 2. Extending intervals blindly without checking historical overlaps. 3. Ignoring cross-client number range conflicts. 4. Transporting interval corrections without freeze governance. Uncontrolled number range fixes can corrupt historical references.
Follow-up 1. Why do number range issues appear only after go live?
Answer: because transaction volume increases under real usage. What looked sufficient in testing may exhaust or collide under production scale.
Follow-up 2. Can number ranges be adjusted without downtime?
Answer: yes, but it requires controlled change management and awareness of concurrent transaction processing.
Follow-up 3. Curveball. Why are number range conflicts considered audit risks?
Answer: because duplicate or overlapping numbers can compromise document traceability, which directly impacts compliance and financial audit integrity.
Exclusive pro tip.
Treat number ranges as architectural assets, not technical counters. Audit them before conversion and validate them under production scale simulation.
Scenario 37. SPDD or SBAU removes PP enhancements.
During technical conversion, SPDD or SBAU adjustments overwrite or remove custom enhancements in PP programs, user exits, or implicit enhancements. After go live, critical validations, default values, or automation logic silently stop working.
Scenario classification.
1. Complexity, critical hidden logic loss. 2. Phase during conversion window. 3. Primary ownership ABAP lead. 4. Supporting PP functional lead. 5. Business ownership, production business process owner.
Diagnostic dashboard, symptoms and evidence.
How enhancement loss appears after technical upgrade and how to detect it early. 1. Symptom: production orders miss default values or validations that existed in ECC. 2. Red flag: SPDD or SBAU adjustment logs show overwritten custom objects. 3. Business impact, incorrect orders created, compliance controls bypassed, or shop floor automation fails. 4. Detection. Code comparison reports show missing enhancements after upgrade tasks. 5. Technical proof. Custom includes or enhancement spots inactive or reset to SAP standard. Insight. If behavior changes without configuration updates, check SPDD and SBAU first.
Why this happens, scenario analysis and root cause.
1. Technical upgrade replaces SAP standard objects containing custom modifications. 2. Improper SBAU or SPDD adjustment decisions overwrite custom logic. 3. Lack of documented functional specifications for enhancements. 4. Upgrade teams prioritize activation over deep regression validation. Enhancements disappear not because SAP removed them, but because governance was weak.
Why this is a migration-exclusive failure.
1. SPDD and SBAU processes exist only during upgrade or conversion. 2. Legacy ECC enhancements may rely on deprecated objects. 3. S/4HANA enforces clean core principles that discourage modifications. 4. The technical upgrade phase exposes undocumented customizations. Upgrade enforcement exposes hidden technical debt.
Governance and accountability, RACI model.
Accountable means the person who answers if business logic disappears. Responsible means the person executing the adjustment and restoration. 1. Accountable, ABAP lead for preservation of custom logic. 2. Responsible, ABAP development team for SPDD and SBAU adjustments. 3. Consulted, PP functional lead for validating business impact of enhancements. 4. Informed, production business process owner for process validation. Technical upgrade decisions must be validated against functional architecture.
Ownership, who actually fixes it.
Restoring enhancements requires both technical recovery and functional validation. 1. ABAP lead reviews SPDD and SBAU logs and restores required enhancements. 2. PP functional lead confirms restored logic aligns with process design. 3. Development team regression tests impacted transactions end-to-end. 4. Business process owner validates shop floor scenarios under controlled testing.
Who gets blamed versus who owns it.
1. Blamed SAP for removing functionality. 2. Blamed functional team for missing configuration. 3. Actual owner ABAP upgrade governance. 4. Root cause inadequate enhancement documentation and validation.
How this is actually fixed. The right way by a role.
1. ABAP lead re-implements enhancements using supported extension techniques. 2. PP functional lead revalidates business scenarios impacted by logic changes. 3. Solution architect ensures future enhancements follow clean core principles. 4. Testing team executes regression scripts across production critical processes.
What not to do, common wrong fixes.
1. Reactivating old implicit enhancements without redesign. 2. Ignoring SBAU logs assuming no business impact. 3. Skipping regression testing for production order transactions. 4. Copying old code into new objects without architectural review. Quick technical restoration without redesign creates future instability.
Follow-up 1. Why are PP enhancements especially vulnerable during upgrade?
Answer: PP modules often contain deep process-specific enhancements embedded in standard programs. When SAP replaces or simplifies those objects, undocumented modifications are easily overwritten.
Follow-up 2. How can teams protect enhancements before conversion?
Answer: by conducting custom code analysis, documenting business justification, and converting modifications into supported extension frameworks before technical conversion begins.
Follow-up 3. Curveball. Why is enhancement loss more dangerous than a system crash?
Answer: because the system continues running while critical business controls silently fail. Hidden logic loss can compromise compliance, costing, or planning accuracy without immediate technical errors.
Exclusive pro tip.
Before touching SPDD or SBAU, treat every enhancement as a business control. Upgrade is not just technical alignment. It is architectural risk management.
Scenario 38. Migration cockpit failures.
During ECC to S/4HANA conversion, data loads through migration cockpit fail or produce inconsistent production planning master data. Materials, BOMs, routings, or production versions appear partially migrated, leading to broken planning logic immediately after go live.
Scenario classification.
1. Complexity, high data integrity risk. 2. Phase during conversion window. 3. Primary ownership data migration lead. 4. Supporting PP functional lead. 5. Business ownership production business process owner.
Diagnostic dashboard, symptoms and evidence.
How migration defects surface during cutover and how to detect them before business impact escalates. 1. Symptom, planned orders fail due to missing BOM components or inactive routings. 2. Red flag migration logs show warnings ignored during test cycles. 3. Business impact, production cannot generate reliable procurement or manufacturing proposals. 4. Detection, data load simulation reports show incomplete object dependencies. 5. Technical proof, inconsistent key relationships between material master, BOM, and routing tables. Insight, partial master data migration creates full-scale planning instability.
Why this happens, scenario analysis and root cause.
1. Migration templates do not enforce cross-object dependencies strictly. 2. Data cleansing was incomplete before final load. 3. Test loads focused on volume instead of relational consistency. 4. Cutover pressure reduces validation depth. Migration failure is rarely technical alone. It is governance and validation discipline.
Why this is a migration-exclusive failure.
1. Migration cockpit is used only during conversion programs. 2. Legacy ECC inconsistencies were tolerated until reloaded into S/4HANA structures. 3. S/4HANA enforces stricter master data relationships. 4. Cutover windows amplify validation risk under time constraints. Data migration exposes every historical inconsistency at once.
Governance and accountability, RACI model.
Accountable means the person who answers if corrupted data enters production. Responsible means the person executing the load and reconciliation. 1. Accountable data migration lead for integrity of loaded PP objects. 2. Responsible data migration team for executing structured loads and reconciliation. 3. Consulted PP functional lead for validating planning logic alignment. 4. Informed production business process owner for operational sign-off. Migration governance separates architectural accountability from technical execution.
Ownership, who actually fixes it.
Correcting migration defects requires both technical reload and functional validation. 1. Data migration lead redesigns load sequencing to preserve object dependencies. 2. PP functional lead validates BOM, routing, and production version alignment. 3. Reconciliation team performs record-level consistency checks. 4. Business process owner validates end-to-end planning execution scenarios.
Who gets blamed versus who owns it.
1. Blamed technical team for load failures. 2. Blamed SAP tool limitations. 3. Actual owner data governance and validation discipline. 4. Root cause, incomplete cross-object dependency validation.
How this is actually fixed, the right way by a role.
1. Data migration lead sequences loads according to dependency hierarchy. 2. PP functional lead signs off planning simulation results before cutover. 3. Data team executes reconciliation reports between source and target. 4. Project manager enforces go-live criteria based on data validation checkpoints.
What not to do, common wrong fixes.
1. Reloading data without root cause analysis. 2. Ignoring warning logs during migration cockpit execution. 3. Validating only record count instead of relational integrity. 4. Assuming test load success guarantees production stability. Data volume validation is not equal to data integrity validation.
Follow-up 1. Why do migration errors sometimes appear only after go live?
Answer: because initial validation often checks record existence rather than planning behavior. Only when MRP Live runs with real production scenarios do missing dependencies surface as functional failures.
Follow-up 2. Can automated tools prevent this completely?
Answer: automated tools reduce technical errors but cannot replace functional validation. Cross-object dependencies require domain knowledge that automation alone cannot guarantee.
Follow-up 3. Curveball. Why is migration governance more important than migration tooling?
Answer: because tools execute instructions. Governance defines validation depth and accountability. Without governance discipline, even the best tool will migrate flawed data accurately.
Exclusive pro tip.
Never treat migration cockpit as a technical formality. In production planning, master data relationships define system intelligence. Validate behavior, not just load completion.
Scenario 39. Background jobs overlap.
During ECC to S/4HANA conversion downtime, legacy background jobs are not fully reviewed or rescheduled. After technical upgrade, planning jobs, settlement jobs, and costing jobs begin overlapping. This creates table locks, inconsistent results, and unstable planning execution.
Scenario classification.
1. Complexity, high system stability risk. 2. Phase during conversion window and post-go live. 3. Primary ownership basis lead. 4. Supporting PP functional lead. 5. Business ownership production business process owner.
Diagnostic dashboard, symptoms and evidence.
How job overlap instability appears in planning operations and how to detect it early. 1. Symptom, MRP runs inconsistently or fails intermittently. 2. Red flag job monitoring shows overlapping execution windows for critical PP jobs. 3. Business impact production plans fluctuate and settlement timing becomes unpredictable. 4. Detection background job logs show lock weights or runtime spikes. 5. Technical proof. Table lock entries appear during simultaneous execution of planning and costing jobs. Insight. Faster HANA processing exposes scheduling weaknesses rather than solving them.
Why this happens, scenario analysis and root cause.
1. Legacy job schedules were designed around slower ECC processing times. 2. S/4HANA processes data faster, compressing job windows and increasing overlap risk. 3. Parallel execution parameters were not recalibrated after conversion. 4. Downtime planning focused on upgrade success rather than job architecture redesign. System acceleration without governance redesign creates collision points.
Why this is a migration-exclusive failure.
1. ECC job timing was tuned for legacy database performance. 2. S/4HANA shifts processing speed and concurrency patterns. 3. Conversion activates new runtime characteristics instantly. 4. Only migration changes infrastructure behavior at this scale. Infrastructure evolution forces scheduling discipline.
Governance and accountability, RACI model.
Accountable means the person who answers if system stability fails. Responsible means the person redesigning and executing the job schedule corrections. 1. Accountable basis lead for job scheduling architecture. 2. Responsible basis team for adjusting runtime parameters and execution windows. 3. Consulted PP functional lead for business critical job prioritization. 4. Informed production business process owner for operational schedule alignment. Enterprise governance separates system stability ownership from business validation.
Ownership, who actually fixes it.
Resolving job overlap requires architectural scheduling redesign. 1. Basis lead redesigns background job architecture based on new runtime patterns. 2. PP functional lead identifies critical planning windows and sequence priorities. 3. Technical team monitors lock statistics during controlled retesting. 4. Business process owner validates planning and settlement stability.
Who gets blamed versus who owns it.
1. Blamed HANA performance for instability. 2. Blamed SAP upgrade changes. 3. Actual owner background job scheduling governance. 4. Root cause legacy ECC scheduling logic not redesigned for S/4HANA.
How this is actually fixed, the right way by a role.
1. Basis lead restructures job timing and parallelization parameters. 2. PP functional lead sequences planning and costing jobs logically. 3. Technical monitoring team tracks lock and runtime metrics. 4. Project governance enforces periodic review of job architecture.
What not to do, common wrong fixes.
1. Randomly shifting job times without analyzing dependencies. 2. Disabling critical jobs temporarily without root cause review. 3. Assuming performance tuning alone resolves overlap. 4. Ignoring lock statistics as minor warnings. Job stability is architectural, not cosmetic.
Follow-up 1. Why did this not happen in ECC?
Answer: ECC operated on slower database processing, which naturally staggered execution. S/4HANA compresses runtime and exposes concurrency conflicts that were previously hidden by slower processing.
Follow-up 2. Should all background jobs be redesigned after migration?
Answer: not necessarily redesigned, but definitely reviewed. Critical PP jobs must be sequenced according to dependency hierarchy and validated under S/4HANA runtime behavior.
Follow-up 3. Curveball. Why is this considered a governance issue rather than a technical bug?
Answer: because the system executes what it was scheduled to execute. If architecture and sequencing are flawed, the instability reflects governance oversight rather than software malfunction.
Exclusive pro tip.
After ECC to S/4HANA conversion, treat background job design as a fresh architecture exercise. Faster processing amplifies structural weaknesses in scheduling logic.
Scenario 40. Order status corruption.
During ECC to S/4HANA conversion, inconsistencies in production order status tables surface when data structures are adjusted. After go-live, some orders appear technically released but behave as if they are locked, partially closed, or financially inconsistent.
Scenario classification.
1. Complexity, critical transactional integrity risk. 2. Phase during conversion window. 3. Primary ownership ABAP lead. 4. Supporting PP functional lead. 5. Business ownership production business process owner.
Diagnostic dashboard. Symptoms and evidence.
How status corruption appears in operations and how to detect it early. 1. Symptom: production orders cannot be confirmed or technically completed. 2. Red flag: status inconsistencies between header and operation levels. 3. Business impact: shop floor execution delays and financial posting blocks. 4. Detection: order status reports show mismatched system and user statuses. 5. Technical proof: inconsistent entries found in status management tables during validation. Insight: status corruption is rarely visible until execution fails.
Why this happens. Scenario analysis and root cause.
1. Custom enhancements updated order statuses directly in ECC. 2. Conversion adjusts status handling logic and table consistency rules. 3. Historical inconsistencies were tolerated in legacy execution. 4. Migration validation enforces stricter status coherence across objects. Status integrity becomes enforced during structural migration.
Why this is a migration-exclusive failure.
1. ECC allowed some manual or programmatic status overrides. 2. S/4HANA enforces tighter cross-table validation. 3. Conversion scripts reconcile historical data inconsistencies. 4. The structural rewrite only occurs during migration. Old inconsistencies are exposed when the data model is hardened.
Governance and accountability. RACI model.
Accountable means the person who answers if transactional integrity fails. Responsible means the person executing correction logic. 1. Accountable PP functional lead for process correctness. 2. Responsible ABAP lead for status correction scripts. 3. Consulted basis lead for data validation during downtime. 4. Informed production business process owner for operational impact. Enterprise governance ensures process leads own logic, while technical leads correct data.
Ownership: who actually fixes it.
Correcting status corruption requires coordinated data repair. 1. ABAP lead develops correction programs to reconcile inconsistent statuses. 2. PP functional lead validates correct lifecycle state transitions. 3. Basis lead supports safe data correction in controlled downtime. 4. Production business process owner confirms operational correctness.
Who gets blamed versus who owns it.
1. Blamed SAP upgrade logic. 2. Blamed database inconsistency. 3. Actual owner legacy enhancement logic and inconsistent status governance. 4. Root cause historical shortcuts exposed by stricter validation.
How this is actually fixed. The right way by a role.
1. ABAP lead executes validated correction scripts on affected orders. 2. PP functional lead reviews status schema and process design. 3. Basis lead ensures backup and rollback readiness before data correction. 4. Business process owner validates order lifecycle consistency post-fix.
What not to do, common wrong fixes.
1. Manually adjusting statuses in production without root cause. 2. Ignoring small inconsistencies assuming limited impact. 3. Blaming conversion tools without reviewing enhancements. 4. Restarting conversion without data validation. Status repair without governance creates recurring instability.
Follow-up 1. Why do status inconsistencies appear only after conversion?
Answer: because migration scripts enforce alignment between header and operation states. ECC often allowed loosely controlled updates. Structural validation during S/4HANA conversion reveals inconsistencies that never blocked execution before.
Follow-up 2. Can this impact financial closing?
Answer: yes. Orders stuck in incorrect status may block settlement, variance calculation, or goods movement postings. Transactional integrity directly influences financial reporting.
Follow-up 3. Curveball. Why is this more dangerous than a performance issue?
Answer: performance issues slow processes. Status corruption invalidates processes. It affects execution accuracy, financial postings, and audit traceability simultaneously.
Exclusive pro tip.
Before conversion freeze, run a full production order status integrity audit. It is easier to fix inconsistencies in ECC than during S/4HANA downtime.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Scenario 41. Data freeze mismanaged for open orders.
During ECC to S/4HANA conversion, open production orders continue to be created, confirmed, or technically completed close to downtime. If data freeze rules are unclear, orders change status during SUM execution, creating inconsistencies between pre-conversion and post-conversion states.
Scenario classification.
1. Complexity critical cutover governance risk. 2. Phase during conversion window. 3. Primary ownership project manager. 4. Supporting functional leads. 5. Business ownership production business process owner.
Diagnostic dashboard, symptoms and evidence.
How poor data freeze discipline disrupts conversion stability. 1. Symptom production orders appear partially updated after go live. 2. Red flag order confirmations posted during technical downtime window. 3. Business impact settlement errors duplicate postings or missing goods movements. 4. Detection audit logs show user activity during declared freeze period. 5. Technical proof. Timestamp mismatches between converted data and ECC source logs. Insight: most conversion failures are governance failures, not technical ones.
Why this happens, scenario analysis and root cause.
1. Cutover freeze windows are not clearly communicated. 2. Business continues processing under operational pressure. 3. Conversion scripts assume static data state. 4. Lack of ownership over final transaction cutoff timing. Technical execution depends entirely on disciplined governance.
Why this is a migration-exclusive failure.
1. Only during conversion is a full transactional freeze required. 2. ECC daily operations never require system-wide freeze. 3. SUM execution assumes zero transactional drift. 4. The risk window exists only during system transformation. Conversion amplifies minor governance lapses into major failures.
Governance and accountability, RACI model.
Accountable means the person who answers if cut-over discipline fails. Responsible means the person executing freeze enforcement. 1. Accountable project manager for cut-over governance. 2. Responsible functional leads for enforcing transaction freeze. 3. Consulted basis lead for system lock execution. 4. Informed production business process owner regarding operational stoppage. Enterprise governance frameworks emphasize that migration failure is often leadership failure.
Ownership, who actually fixes it.
Recovery requires coordinated reconciliation. 1. Project manager defines strict freeze and communication protocol. 2. Functional leads reconcile open orders before restart. 3. Basis lead validates no transactional changes during SUM window. 4. Production business process owner approves corrected state.
Who gets blamed versus who owns it.
1. Blamed basis for conversion instability. 2. Blamed SAP for conversion tool errors. 3. Actual owner cut over governance discipline. 4. Root cause lack of enforced freeze management.
How this is actually fixed. The right way by a role.
1. Project manager establishes hard transactional freeze checkpoints. 2. Functional leads reconcile and lock open production orders. 3. Basis lead executes system-level locks and validates no user sessions remain active. 4. Business process owner signs off final freeze compliance.
What not to do, common wrong fixes.
1. Allowing limited production activity during downtime window. 2. Assuming business users will self-enforce freeze discipline. 3. Skipping reconciliation after go live. 4. Blaming technical team for governance lapses. Without discipline, conversion becomes uncontrolled risk.
Follow-up 1. Why is data freeze more critical for PP than other modules?
Answer: because production orders have operational and financial implications simultaneously. Changes affect confirmations, goods movements, and settlement. Any drift during conversion creates cascading inconsistencies.
Follow-up 2. Can technical locks alone prevent this?
Answer: technical locks help but are insufficient without communication discipline. Business users may still attempt updates before freeze enforcement. Governance must combine system control and process enforcement.
Follow-up 3. Curveball. Why do experienced teams still fail in freeze management?
Answer: because conversion focuses heavily on technical tasks. Operational governance receives less attention. In reality, the highest risk during migration is uncontrolled transactional drift.
Exclusive pro tip.
Treat cutover governance as seriously as technical conversion. A perfectly executed SUM can still fail if business discipline collapses.
Scenario 42. PP and DS license and activation conflicts.
During ECC to S/4HANA conversion, embedded production planning and detailed scheduling functionality is expected to activate seamlessly. However, missing licenses or incomplete business function activation blocks planning execution, leaving advanced planning inactive after go live.
Scenario classification.
1. Complexity critical planning architecture risk. 2. Phase during conversion window. 3. Primary ownership basis lead. 4. Supporting solution architect. 5. Business ownership head of supply chain planning.
Diagnostic dashboard, symptoms and evidence.
How license and activation conflicts surface during conversion. 1. Symptom: advanced planning transactions are unavailable after system startup. 2. Red flag: business function activation logs show incomplete activation. 3. Business impact: planners cannot execute detailed scheduling or finite capacity planning. 4. Detection: license audit reports show missing or expired planning components. 5. technical proof. System status transactions indicate inactive planning switches. Insight, advanced planning does not fail silently. It fails structurally.
Why this happens, scenario analysis and root cause.
1. Embedded planning requires explicit license activation. 2. Conversion assumes architectural decisions were finalized. 3. Business function switches were not validated pre-conversion. 4. Planning architecture ownership was unclear between teams. Architecture decisions cannot be improvised during conversion.
Why this is a migration-exclusive failure.
1. ECC did not include embedded advanced planning. 2. License dependencies are triggered only in S/4HANA. 3. Conversion activates dormant functionality layers. 4. The conflict exists only during system transformation. Migration exposes architectural assumptions about planning strategy.
Governance and accountability, RACI model.
Accountable means the person who answers if advanced planning fails. Responsible means the person who activates and configures it. 1. Accountable, solution architect for overall planning architecture design. 2. Responsible, basis lead for license validation and activation. 3. Consulted, PP functional lead for planning configuration alignment. 4. Informed, head of supply chain planning for operational readiness. Enterprise governance separates architecture accountability from technical activation execution.
Ownership, who actually fixes it.
Fixing activation conflicts requires architectural clarity and technical validation. 1. Basis lead validates system licenses and activates required business functions. 2. Solution architect confirms advanced planning strategy alignment. 3. PP functional lead configures planning parameters after activation. 4. Head of supply chain planning validates operational readiness.
Who gets blamed versus who owns it.
1. Blamed basis for missing activation. 2. Blamed SAP for complex licensing model. 3. Actual owner planning architecture governance. 4. Root cause strategic planning decisions not finalized before conversion.
How this is actually fixed. The right way by a role.
1. Solution architect finalizes embedded planning roadmap. 2. Basis lead ensures all required licenses are applied and activated. 3. PP functional lead revalidates planning configuration post-activation. 4. Business leadership signs off on advanced planning readiness.
What not to do, common wrong fixes.
1. Assuming embedded planning activates automatically. 2. Ignoring license validation until after go live. 3. Blaming system instability without reviewing activation logs. 4. Allowing planning users to test without full activation. Advanced planning requires deliberate activation, not assumption.
Follow-up 1. Why is planning activation often overlooked?
Answer: because teams focus heavily on core conversion tasks such as data and code remediation. Planning strategy decisions are sometimes deferred. However, embedded planning requires explicit architectural commitment.
Follow-up 2. Can activation be performed after go live?
Answer: technically yes, but it introduces operational disruption. Planning behavior changes immediately once activated. Activating post-go live without controlled testing increases business instability.
Follow-up 3. Curveball. Why do license conflicts surface late in projects?
Answer: because license validation is often treated as administrative. In reality, it directly controls functional capability. Architecture assumptions become visible only when system switches are enforced.
Exclusive pro tip.
Before conversion, confirm advanced planning architecture decisions in writing. Activation issues are governance gaps disguised as technical errors.
Scenario 43. Embedded production planning and detailed scheduling migration failures.
During ECC to S/4HANA conversion, organizations moving from standalone advanced planning systems to embedded production planning and detailed scheduling face unexpected data migration gaps. Planning data, heuristics, or resource models do not transfer correctly, causing planning inconsistencies immediately after go live.
Scenario classification.
1. Complexity, critical advanced planning disruption. 2. Phase during conversion window and early stabilization. 3. Primary ownership PPDS lead. 4. Supporting basis lead. 5. Business ownership, head of advanced planning.
Diagnostic dashboard, symptoms and evidence.
How embedded production planning and detailed scheduling migration failures surface. 1. Symptom: planning runs complete but generate unrealistic or incomplete schedules. 2. Red flag: missing planning versions, resources, or heuristic profiles after migration. 3. Business impact: capacity overload or underutilization across critical work centers. 4. Detection: migration cockpit logs show skip planning objects or mapping errors. 5. Technical proof: planning results differ significantly between legacy system snapshots and S/4HANA outputs. Insight: if planning logic feels unfamiliar, the migration path likely missed structural planning objects.
Why this happens, scenario analysis and root cause.
1. Embedded planning uses a different data model than legacy advanced planning systems. 2. Not all planning versions and custom heuristics have automated migration paths. 3. Queue monitoring and mapping validation were incomplete before cutover. 4. Planning architecture ownership was not clearly assigned during transformation. Advanced planning migration is architectural, not merely technical.
Why this is a migration-exclusive failure.
1. ECC environments relied on external advanced planning structures. 2. S/4HANA consolidates planning logic into embedded architecture. 3. Migration eliminates legacy synchronization mechanisms. 4. The failure occurs only when shifting architectural paradigms. Transformation replaces integration layers with embedded logic, exposing migration gaps.
Governance and accountability, RACI model.
Accountable means the person who answers if advanced planning collapses. Responsible means the person executing the migration and validation. 1. Accountable, PPDS lead for planning architecture sign-off. 2. Responsible, basis lead for system activation and queue validation. 3. Consulted, PP functional lead for alignment with production processes. 4. Informed, head of advanced planning for operational continuity. Enterprise governance separates strategic planning accountability from technical migration execution.
Ownership, who actually fixes it.
Fixing embedded planning migration failures requires structural validation. 1. PPDS lead validates planning versions, resources, and heuristic configurations. 2. Basis lead monitors queues and system consistency during activation. 3. PP functional lead confirms alignment between planning results and execution reality. 4. Business leadership reviews planning outputs against operational KPIs.
Who gets blamed versus who owns it.
1. Blamed basis for migration instability. 2. Blamed SAP for planning model differences. 3. Actual owner PPDS lead for architectural validation. 4. Root cause insufficient mapping of legacy planning constructs.
How this is actually fixed, the right way by a role.
1. PPDS lead performs structured validation of all migrated planning objects. 2. Basis lead validates activation parameters and system consistency. 3. PP functional lead executes controlled planning simulations for regression testing. 4. Head of advanced planning approves planning accuracy before operational release.
What not to do, common wrong fixes.
1. Assuming migration cockpit transfers all planning logic automatically. 2. Blaming performance without validating resource models. 3. Running production planning without reconciliation against legacy snapshots. 4. Allowing planners to adjust results manually without structural correction. Manual corrections mask structural migration defects.
Follow-up 1. Why are planning results different even when data seems correct?
Answer: embedded planning applies different algorithms and constraints compared to legacy advanced planning systems. Even small differences in resource definitions or heuristics create noticeable output shifts. Structural alignment must be validated before assuming data integrity.
Follow-up 2. Can legacy planning snapshots be reused directly?
Answer: not reliably. Embedded architecture interprets planning models differently. Snapshots help benchmarking but cannot replace validation and adjustment within the new framework.
Follow-up 3. Curveball. Why do these issues often appear only after real production load?
Answer: test environments rarely simulate full capacity and parallel planning runs. Under real load, scheduling conflicts and constraint logic differences become visible. Production stress reveals architectural gaps missed during testing.
Exclusive pro tip.
Treat embedded production planning and detailed scheduling migration as a new planning implementation, not a technical upgrade. Architecture validation is mandatory before trusting planning outputs.
Category 2 wrap-up. When conversion execution becomes the real risk.
During the conversion window, the system does not fail because of business logic. It fails because of technical sequencing, activation timing, and migration discipline. These incidents prove that even perfect master data can collapse under poor execution governance.
Transition from technical execution to planning intelligence.
Once the system is technically converted, a more dangerous challenge begins. Planning logic itself changes. Algorithms behave differently, enforcement becomes stricter, and performance assumptions shift. This is where business users start saying, MRP worked in ECC, why is it different now?
Category 3. MRP Live and Planning Behavior Shift.
This category focuses on algorithmic logic and performance transformation. S/4HANA introduces MRP Live, new aATP logic, embedded planning structures, and HANA-based execution. These changes do not just improve speed. They fundamentally alter planning behavior and decision outcomes.
Scenarios covered in Category 3.
Scenario 44, MD01 versus MD01N results drift. Primary owner PP functional lead, supporting ABAP lead HANA AMDP. Scenario 45, planning results drift after migration. Primary owner PP functional lead, supporting business planner BPO. Scenario 46, lot size calculation changes. Primary owner PP functional lead, supporting MM functional lead. Scenario 47, rescheduling logic behavior. Primary owner PP functional lead, supporting MM purchasing lead. Scenario 48, safety stock recalculation differences. Primary owner PP functional lead, supporting MM inventory lead. Scenario 49, planning time fence changes. Primary owner PP functional lead, supporting business planner BPO. Scenario 50, exclusion keys not supported. Primary owner ABAP lead HANA, supporting PP functional lead. Scenario 51, custom MRP baddies not triggered. Primary owner ABAP lead HANA, supporting PP functional lead. Scenario 52, aATP replaces classic ATP. Primary owner SD functional lead, supporting PP functional lead. Scenario 53, net requirements calculation differences. Primary owner PP functional lead, supporting ABAP lead if custom. Scenario 54, MRP exception messages differ. Primary owner PP functional lead, supporting business planner BPO. Scenario 55, pegging logic changes. Primary owner PP functional lead, supporting project manager. Scenario 56, subcontracting planning differences. Primary owner MM functional lead, supporting PP functional lead. Scenario 57, phantom explosion behavior changes. Primary owner PP functional lead, supporting CO functional lead. Scenario 58, multi-level bomb planning drift. Primary owner PP functional lead, supporting CO functional lead. Scenario 59, CTM optimization profile loss. Primary owner PPDS lead, supporting basis lead. Scenario 60, production planning and detailed scheduling versus MRP Live Planning drift. Primary owner PPDS lead, supporting PP functional lead. Scenario 61, aATP rule-based ATP not migrated. Primary owner SD functional lead, supporting PP functional lead. Scenario 62, MRP Live AMDP reimplementation. Primary owner ABAP lead HANA, supporting PP functional lead.
Scenario 44, MD01 versus MD01N results drift.
After conversion to S/4HANA, planners execute MD01N expecting identical results to classic MD01. Instead, procurement proposals differ, exception messages change, and planned orders shift unexpectedly. What worked for years in ECC suddenly behaves differently under MRP Live.
Scenario classification.
1. Complexity critical core planning logic shift. 2. Phase post-conversion and stabilization. 3. Primary ownership PP functional lead. 4. Supporting ABAP lead HANA AMDP. 5. Business Ownership Business Planner BPO.
Diagnostic dashboard, symptoms and evidence.
How this failure manifests in planning cycles and how to detect it early. 1. Symptom: MD01N generates fewer or different planned orders compared to MD01. 2. Red flag: planners report missing proposals or changed exception messages. 3. Business impact: supply planning becomes inconsistent, production schedules fluctuate. 4. Detection: parallel test runs between MD01 and MD01N during testing phases. 5. Technical proof: MRP Live execution logs show algorithmic filtering of unsupported logic. Insight: this is not a system bug. It is a shift from classic MRP to HANA-based planning logic.
Why this happens, scenario analysis and root cause.
1. MRP Live runs on HANA and excludes unsupported classic logic. 2. Certain custom enhancements and baddies are ignored by MD01N. 3. Planning parameters are interpreted differently in MRP Live. 4. Performance-optimized logic removes legacy fallback behaviors. S/4HANA prioritizes deterministic and high-performance planning logic.
Why this is a migration-exclusive failure.
1. Classic MRP logic in ECC tolerated legacy configuration inconsistencies. 2. MRP Live enforces strict compatibility rules. 3. Custom planning logic may not automatically transfer to HANA execution. 4. The shift only becomes visible after activating MD01N in S/4HANA. The migration changes the planning engine itself, not just the database.
Governance and accountability, RACI model.
In ECC to S/4HANA Brownfield programs, ownership follows a RACI structure where authority and execution are clearly separated across work streams. 1. Accountable PP functional lead: the person who gets fired if planning fails. 2. Responsible ABAP lead: HANA aATP, the person who redesigns or reimplements unsupported logic. 3. Consulted basis lead for performance validation. 4. Informed business planner for operational impact confirmation. Aligned with enterprise governance models, where functional leads own module risk and technical leads execute remediation.
Ownership: who actually fixes it.
Correcting planning drift requires architectural analysis, not parameter tweaking. 1. PP functional lead compares classic and live planning logic and adjusts configuration. 2. ABAP lead reviews unsupported enhancements and redesigns logic using HANA-compliant methods. 3. Basis lead validates runtime performance after adjustments. 4. Business planner executes controlled regression testing before production deployment.
Who gets blamed versus who owns it.
1. Blamed SAP for changing MRP behavior. 2. Blamed basis for performance differences. 3. Actual owner PP functional lead for planning configuration governance. 4. Root cause: planning engine transformation under S/4HANA.
How this is actually fixed, the right way by a role.
1. PP functional lead documents delta logic between classic MRP and MRP Live. 2. ABAP lead reimplements unsupported baddies using HANA-compliant logic. 3. Basis lead benchmarks performance before final activation. 4. Business planner signs off after parallel run validation.
What not to do, common wrong fixes.
1. Switching back permanently to classic MD01 without root cause analysis. 2. Blaming system performance without reviewing planning configuration. 3. Ignoring unsupported enhancements in MRP Live. 4. Accepting planning drift without regression comparison. Avoid reverting to legacy behavior without understanding the algorithmic shift.
Follow-up 1. Why does MD01N exclude certain custom logic?
Answer: MRP Live executes on HANA-optimized procedures. Some classic enhancements and exits are not supported in this environment and require redesign using HANA-compliant methods.
Follow-up 2. Should we disable MRP Live if differences appear?
Answer: temporarily for analysis, yes. Permanently, no. The long-term strategy should align with S/4HANA architecture rather than reverting to legacy execution.
Follow-up 3. Curveball. Why do some materials behave correctly while others drift?
Answer: MRP Live selectively processes materials based on compatibility criteria. Materials with unsupported logic are either excluded or processed differently, creating selective drift patterns.
Exclusive pro tip.
Always run parallel planning cycles during stabilization. Planning drift should be documented and explained before go live, not discovered during production shortages.
Scenario 45. Planning results drift after migration.
After ECC to S/4HANA migration, overall MRP results appear structurally different even though no master data changes were made. Planned orders shift dates, procurement quantities change, and exception messages increase. Business users insist nothing was modified, yet planning behavior is no longer identical.
Scenario classification.
1. Complexity high cross-material planning drift. 2. Phase post-go-live stabilization. 3. Primary ownership PP functional lead. 4. Supporting business planner BPO. 5. Business ownership supply chain director.
Diagnostic dashboard, symptoms and evidence.
How this planning drift appears across the supply chain and how to identify it early. 1. Symptom, planned order quantities or dates differ from historical ECC patterns. 2. Red flag, increase in exception messages without visible configuration change. 3. Business impact, safety stock violations and fluctuating production schedules. 4. Detection, side-by-side comparison of pre-migration and post-migration MRP results. 5. Technical proof, MRP run logs show different lot sizing or scheduling interpretations. Insight, if planning logic feels unstable, it is usually configuration interpretation under MRP Live.
Why this happens, scenario analysis and root cause.
1. MRP Live processes planning logic in memory on HANA. 2. Certain tolerance rules and planning parameters behave differently. 3. Lot sizing and scheduling parameters are recalculated with stricter enforcement. 4. Legacy configuration inconsistencies become visible under deterministic logic. The migration modernizes the planning engine, revealing hidden inconsistencies.
Why this is a migration-exclusive failure.
1. ECC planning relied on classic runtime evaluation. 2. S/4HANA introduces HANA-optimized algorithmic logic. 3. Readiness checks do not simulate complete production planning cycles. 4. Only real data volumes reveal behavioral shifts after migration. The drift is architectural, not transactional.
Governance and accountability, RACI model.
In brownfield migrations, governance follows a RACI structure separating accountability from execution. 1. Accountable, PP functional lead the person who gets fired if planning architecture fails. 2. Responsible, PP functional team executing configuration validation and adjustments. 3. Consulted, business planner for real-world validation of planning outputs. 4. Informed, supply chain director for operational impact oversight. Enterprise programs emphasize functional leads for module risk, supported by business validation layers.
Ownership, who actually fixes it.
Planning drift requires structured root cause analysis across configuration layers. 1. PP functional lead analyzes parameter interpretation differences in MRP Live. 2. Business planner validates material-level behavioral shifts. 3. ABAP lead supports if custom enhancements influence planning output. 4. Project governance ensures documented delta analysis before stabilization sign-off.
Who gets blamed versus who owns it.
1. Blamed SAP for altering core planning logic. 2. Blamed basis for system performance behavior. 3. Actual owner PP functional lead for configuration governance. 4. Root cause deterministic planning engine replacing legacy evaluation logic.
How this is actually fixed, the right way by a role.
1. PP functional lead performs structured delta analysis between ECC and S/4HANA outputs. 2. Business planner validates proposed corrections against operational reality. 3. ABAP lead revalidates any custom logic affecting planning. 4. Supply chain director approves updated planning governance standards.
What not to do, common wrong fixes.
1. Manually adjusting planned orders without root cause analysis. 2. Blaming HANA performance without reviewing planning parameters. 3. Ignoring cross-material impact during testing. 4. Assuming drift will stabilize automatically. Unanalyzed drift becomes long-term operational instability.
Follow-up 1. Why do some plants show drift while others do not?
Answer: configuration consistency varies across plants. Plants with stricter parameter governance experience fewer behavioral changes under MRP Live.
Follow-up 2. Is this always a configuration issue?
Answer: mostly yes. However, custom enhancements or unsupported logic may also influence results and require a BAP validation.
Follow-up 3. Curveball. Why did testing not reveal the full impact?
Answer: testing environments rarely replicate full production data volumes and complexity. Only real load conditions reveal algorithmic drift.
Exclusive pro tip.
Never rely solely on unit testing for planning validation. Use controlled full-scope regression planning cycles before final stabilization approval.
Scenario 46. Lot size calculation changes.
After ECC to S/4HANA migration, lot size calculations generate different procurement or production quantities even though no material master fields were intentionally changed. Planners notice excess stock in some materials and shortages in others. The logic feels similar, but the mathematical outcome is different.
Scenario classification.
1. Complexity, medium to high quantity distortion. 2. Phase, post-go-live stabilization. 3. Primary ownership, PP functional lead. 4. Supporting MM functional lead. 5. Business ownership, supply planning manager.
Diagnostic dashboard, symptoms and evidence.
How lot size drift appears in operational planning and how to detect it early. 1. Symptom: planned orders generated in unusually large or fragmented quantities. 2. Red flag: lot size key behavior differs between ECC and S/4HANA test comparison. 3. Business impact: overstock situations or frequent rescheduling of small production batches. 4. Detection: compare MD01 and MD01N outputs for representative materials. 5. Technical proof: MRP Live logs reflect recalculated rounding, minimum lot, or fixed lot size logic. Insight: quantity drift is rarely random. It usually traces back to parameter interpretation.
Why this happens, scenario analysis and root cause.
1. MRP Live evaluates lot sizing directly in HANA memory. 2. Rounding rules and minimum lot sizes are enforced more strictly. 3. Legacy inconsistencies in material master fields were tolerated in ECC. 4. Planning horizon and time fence interactions differ slightly under the new engine. The formula did not change randomly. Its enforcement did.
Why this is a migration-exclusive failure.
1. ECC Classic MRP applied evaluation logic sequentially. 2. S/4HANA processes lot size logic with optimized HANA execution. 3. Readiness checks do not simulate real planning cycles. 4. Only post-migration comparative testing reveals quantitative differences. What appears as a system defect is often a parameter precision issue.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, planning architecture ownership follows structured accountability principles. 1. Accountable PP functional lead: the person who gets fired if planning quantities destabilize operations. 2. Responsible PP functional team adjusting lot size configuration and validating logic. 3. Consulted MM functional lead for procurement parameter alignment. 4. Informed supply planning manager for operational validation. Enterprise governance assigns module risk ownership to functional leads and operational validation to business planners.
Ownership: who actually fixes it.
Correcting lot size behavior requires configuration review rather than manual adjustments. 1. PP functional lead reviews and standardizes lot sizing procedures. 2. MM functional lead validates procurement lot size dependencies. 3. Business planner performs comparative planning runs. 4. Project governance approves updated planning standards.
Who gets blamed versus who owns it.
1. Blamed HANA performance or new MRP engine. 2. Blamed master data team for incorrect quantities. 3. Actual owner PP functional lead for planning parameter governance. 4. Root cause stricter enforcement of lot size calculation logic.
How this is actually fixed, the right way by a role.
1. PP functional lead recalibrates lot size keys and rounding profiles. 2. MM functional lead confirms procurement consistency after adjustments. 3. Business planner executes full material regression testing. 4. Supply planning manager signs off on stabilized planning outputs.
What not to do, common wrong fixes.
1. Manually adjusting planned orders without correcting configuration. 2. Ignoring minimum lot size and rounding parameter alignment. 3. Blaming system performance without logic comparison. 4. Applying emergency fixes plant by plant without global governance. Manual corrections hide systemic planning flaws.
Follow-up 1. Why does rounding behave differently in S/4HANA?
Answer: MRP Live executes calculations directly in HANA with deterministic evaluation. This removes certain implicit tolerances that existed in ECC classic processing.
Follow-up 2. Can we revert to classic behavior?
Answer: not entirely. While some configuration adjustments can approximate ECC behavior, the S/4HANA planning engine enforces stricter consistency standards.
Follow-up 3. Curveball. Why do some materials show no change at all?
Answer: materials with clean and consistent lot size parameters typically remain stable. Drift appears primarily where legacy inconsistencies existed.
Exclusive pro tip.
Before go live, execute parallel planning comparisons for high-value materials. Quantitative drift is easier to correct before operational volume increases.
Scenario 47. Rescheduling logic behavior.
After migrating to S/4HANA, planners notice that rescheduling proposals are either more aggressive or less frequent compared to ECC. Orders that previously remained stable are now automatically brought forward or pushed out. The planning stability that users were familiar with appears disrupted.
Scenario classification.
1. Complexity high planning stability risk. 2. Phase post-go-live stabilization. 3. Primary ownership PP functional lead. 4. Supporting purchasing lead. 5. Business ownership supply chain planning manager.
Diagnostic dashboard, symptoms and evidence.
How rescheduling instability appears and how to identify it early. 1. Symptom: frequent forward or backward rescheduling messages in MRP Live. 2. Red flag exception messages increase significantly after migration. 3. Business impact: purchase orders and production orders are repeatedly adjusted, creating supplier confusion. 4. Detection: compare exception message volumes between ECC and S/4HANA planning runs. 5. Technical proof: MD01N logs show recalculated dates due to stricter lead time enforcement. Insight: rescheduling noise usually reflects parameter precision changes.
Why this happens, scenario analysis and root cause.
1. MRP Live evaluates lead times and safety buffers more strictly. 2. Planning time fence logic interacts differently with firmed orders. 3. Rounding and lot size adjustments cascade into date recalculations. 4. Legacy tolerance settings in ECC mask date misalignments. The algorithm did not become unstable. It became precise.
Why this is a migration-exclusive failure.
1. ECC tolerated minor scheduling deviations without frequent rescheduling. 2. S/4HANA recalculates requirements using in-memory deterministic logic. 3. Readiness checks do not simulate dynamic rescheduling behavior. 4. Only real planning cycles after migration expose instability. Planning turbulence appears only after enforcement becomes real.
Governance and accountability, RACI model.
In S/4HANA Brownfield programs, rescheduling governance follows structured accountability across planning workstreams. 1. Accountable PP functional lead: the person who gets fired if planning instability disrupts supply. 2. Responsible PP planning team adjusting scheduling parameters. 3. Consulted purchasing lead for supplier lead time validation. 4. Informed supply chain business owner for operational sign-off. Functional leads own algorithm stability, while business owners validate operational realism.
Ownership: who actually fixes it.
Stabilizing rescheduling behavior requires configuration refinement, not suppression of exception messages. 1. PP functional lead reviews rescheduling horizon and tolerance settings. 2. purchasing lead validates vendor lead time accuracy. 3. Business planner performs controlled simulation runs. 4. Supply chain manager approves updated planning policies.
Who gets blamed versus who owns it.
1. Blamed system instability or HANA recalculation speed. 2. Blamed suppliers for inconsistent lead times. 3. Actual owner PP functional lead for scheduling governance. 4. Root cause, stricter enforcement of lead time and time fence logic.
How this is actually fixed, the right way by a role.
1. PP functional lead fine-tunes rescheduling horizon parameters. 2. Purchasing lead recalibrates planned delivery times. 3. Business planner validates exception message reduction. 4. Supply chain manager confirms stabilized execution planning.
What not to do, common wrong fixes.
1. Suppressing exception messages without parameter review. 2. Manually adjusting dates repeatedly in production. 3. Blaming MRP Live performance instead of configuration logic. 4. Ignoring lead time master data inconsistencies. Exception noise is a symptom, not the disease.
Follow-up 1. Why are some materials more unstable than others?
Answer: materials with inconsistent lead times, safety stock, or time fence settings show amplified behavior under stricter S/4HANA logic. Stable master data remains relatively unaffected.
Follow-up 2. Does this mean MRP Live is less stable?
Answer: no. It means MRP Live is more deterministic. It recalculates dates precisely rather than tolerating small deviations that ECC often ignored.
Follow-up 3. Curveball. Why does instability increase under higher data volumes?
Answer: higher volume amplifies cumulative scheduling precision. Minor parameter gaps that were invisible in testing become visible under real operational load.
Exclusive pro tip.
Before go live, simulate high-volume planning cycles with realistic master data. Rescheduling stability should be validated under stress, not only under sample data conditions.
Scenario 48. Safety stock recalculation differences.
After ECC to S/4HANA migration, planners observe unexpected changes in safety stock behavior. Materials that were previously stable now generate additional planned orders or show increased stock buffers. The business perceives either overstocking or sudden shortages without clear explanation.
Scenario classification.
1. Complexity, high inventory and service level risk. 2. Phase, post-go-live stabilization. 3. Primary ownership, PP functional lead. 4. Supporting inventory lead. 5. Business ownership, supply chain planning manager.
Diagnostic dashboard, symptoms and evidence.
How safety stock instability appears and how to detect it early. 1. Symptom: sudden increase in planned orders despite unchanged demand. 2. Red flag: safety stock values recalculated differently after migration. 3. Business impact: excess inventory carrying costs or unexpected stockouts. 4. Detection: compare safety stock levels and net requirements between ECC and S/4HANA planning runs. 5. Technical proof. MD01N logs show recalculation based on updated coverage profile or MRP type logic. Insight: inventory drift usually reflects planning parameter recalibration.
Why this happens, scenario analysis and root cause.
1. MRP Live recalculates safety stock based on updated coverage profiles. 2. Forecast consumption logic interacts differently with safety stock buffers. 3. Dynamic safety stock calculations behave differently in in-memory processing. 4. Legacy ECC settings masked inconsistencies in planning parameters. S/4HANA increases mathematical precision in safety stock logic.
Why this is a migration-exclusive failure.
1. ECC classic MRP tolerated parameter inconsistencies across plants. 2. S/4HANA enforces deterministic net requirements calculation. 3. Readiness checks do not simulate dynamic safety stock behavior. 4. Only full production data reveals recalculation drift. Planning buffer enforcement changes only after migration.
Governance and accountability, RACI model.
In S/4HANA programs, inventory governance follows structured accountability between configuration and operations. 1. Accountable, PP functional lead: the person who gets fired if inventory instability affects service levels. 2. Responsible, PP planning team recalibrating safety stock parameters. 3. Consulted, inventory lead validating stock policy and replenishment strategy. 4. Informed, supply chain business owner for service level sign-off. Functional leads govern planning architecture, while business owners approve risk tolerance.
Ownership, who actually fixes it.
Stabilizing safety stock requires parameter refinement and cross-functional validation. 1. PP functional lead reviews coverage profile and MRP type configuration. 2. MM inventory lead validates reorder point and replenishment policy. 3. Business planner performs comparative simulation between legacy and new logic. 4. Supply chain manager approves updated safety stock strategy.
Who gets blamed versus who owns it.
1. Blamed HANA recalculation behavior. 2. Blamed demand forecast instability. 3. Actual owner PP functional lead for planning parameter governance. 4. Root cause stricter safety stock enforcement logic in S/4HANA.
How this is actually fixed, the right way by a role.
1. PP functional lead standardizes safety stock and coverage profiles. 2. MM inventory lead validates replenishment lead times. 3. Business planner validates simulation outputs under real demand scenarios. 4. Supply chain manager approves revised planning thresholds.
What not to do, common wrong fixes.
1. Increasing safety stock arbitrarily to silence shortages. 2. Ignoring parameter drift because stock appears available. 3. Blaming forecast accuracy without reviewing MRP settings. 4. Manually overriding planned orders repeatedly. Inflating buffers hides instability but increases cost.
Follow-up 1. Why does safety stock increase only for some materials?
Answer: materials with dynamic coverage profiles or forecast-driven planning types are more sensitive to recalculation. Stable consumption-based materials may show minimal change.
Follow-up 2. Can this be prevented before go live?
Answer: yes. By performing full-volume simulation runs with production data and validating safety stock outputs against business policy before activation.
Follow-up 3. Curveball. Why do finance teams notice this before planners?
Answer: because inventory valuation changes immediately reflect in financial reports, while planners focus on operational proposals. Cost visibility often reveals buffer inflation first.
Exclusive pro tip.
Never migrate planning parameters blindly. Validate safety stock logic under real demand volatility before go live to avoid silent inventory inflation.
Scenario 49. Planning time fence changes.
After ECC to S/4HANA migration, planners notice that firmed planned orders are being rescheduled or new procurement proposals are generated inside the planning time fence. The system appears to override what used to be protected planning horizons, creating confusion in short-term production scheduling.
Scenario classification.
1. Complexity high short-term planning disruption. 2. Phase post-go-live stabilization. 3. Primary ownership PP functional lead. 4. Supporting business planner BPO. 5. Business ownership production planning manager.
Diagnostic dashboard, symptoms and evidence.
How planning time fence instability appears and how to detect it early. 1. Symptom: firmed planned orders are rescheduled or replaced by new proposals. 2. Red flag: MRP Live generates procurement elements inside previously protected time fences. 3. Business impact: shop floor sequencing instability and last-minute changes to production schedule. 4. Detection: compare MD01 and MD01N results for materials with defined planning time fence values. 5. Technical proof: MD01N logs show different firming logic behavior compared to ECC. Insight: when short-term plans shift unexpectedly, review firming logic first.
Why this happens, scenario analysis and root cause.
1. MRP Live interprets planning time fence parameters differently from classic MRP. 2. Firming types are recalculated under the new in-memory planning algorithm. 3. Custom enhancements in ECC may have modified firming behavior. 4. Legacy materials were configured without strict time fence governance. Algorithmic interpretation changes create planning instability.
Why this is a migration-exclusive failure.
1. ECC allowed flexible firming interpretations under classic planning. 2. S/4HANA enforces standardized MRP Live logic. 3. Planning time fence behavior changes only when MD01N becomes active. 4. Readiness checks do not simulate short-term firming behavior. The enforcement shift happens only after migration.
Governance and accountability, RACI model.
Planning governance requires clarity between accountability and execution. 1. Accountable, PP functional lead, the person who gets fired if production schedule stability collapses. 2. Responsible, PP planning team validating and adjusting firming types. 3. Consulted, business planner reviewing operational feasibility. 4. Informed, production planning manager for approval of time fence policy. Functional leads define planning architecture. Planners validate operational impact.
Ownership, who actually fixes it.
Time fence stability requires configuration validation and simulation. 1. PP functional lead reviews firming type configuration and planning time fence parameters. 2. Business planner executes comparative simulation between ECC and S4HANA. 3. ABAP lead evaluates custom enhancements impacting firming logic if applicable. 4. Production planning manager signs off on stabilized planning behavior.
Who gets blamed versus who owns it.
1. Blamed MRP Live algorithm changes. 2. Blamed system upgrade side effects. 3. Actual owner PP functional lead responsible for planning configuration. 4. Root cause misaligned firming logic under new planning engine.
How this is actually fixed, the right way by a role.
1. PP functional lead standardizes firming type settings across planning areas. 2. Business planner validates time fence behavior under multiple demand scenarios. 3. ABAP lead adjusts custom logic affecting planning execution if required. 4. Production planning manager approves revised short-term scheduling policy.
What not to do, common wrong fixes.
1. Disabling firming logic entirely to stop rescheduling. 2. Manually locking planned orders without reviewing configuration. 3. Blaming demand volatility without analyzing planning parameters. 4. Ignoring differences between MD01 and MD01 end results. Short-term manual overrides create long-term planning chaos.
Follow-up 1. Why does the planning time fence behave differently only in some plants?
Answer: because firming types and time fence parameters are often configured inconsistently across plants. S4HANA enforces the defined configuration strictly, exposing those inconsistencies.
Follow-up 2. Can we continue using classic MD01 to avoid this issue?
Answer: temporarily yes, but it defeats the purpose of migration. Long-term stabilization requires aligning configuration with MRP Live logic rather than reverting to legacy behavior.
Follow-up 3. Curveball. Why does finance sometimes support stricter firming behavior?
Answer: because unstable short-term planning directly affects inventory valuation and production variance. Controlled firming improves cost predictability even if planners initially resist it.
Exclusive pro tip.
Before go live, simulate planning time fence scenarios with real demand volatility. Stabilizing firming logic early prevents emergency schedule overrides after migration.
Scenario 50. Exclusion keys not supported in MRP Live.
After ECC to S4HANA migration, planners notice that materials previously controlled by MRP exclusion keys are now being planned unexpectedly. MRP Live ignores certain classic exclusion logic, resulting in procurement proposals for materials that were intentionally excluded from planning in ECC.
Scenario classification.
1. Complexity high planning governance risk. 2. Phase post-go-live stabilization. 3. Primary ownership ABAP lead HANA. 4. Supporting PP functional lead. 5. Business ownership production planning manager.
Diagnostic dashboard, symptoms and evidence.
How exclusion key gaps appear and how to detect them early. 1. Symptom: materials previously excluded from MRP are now generating planned orders. 2. Red flag: MD01 end results differ significantly from classic MD01 outputs. 3. Business impact: unnecessary procurement proposals increase inventory exposure. 4. Detection: compare planning results between ECC Classic MRP and S4HANA MRP Live. 5. Technical proof: SAP documentation confirms certain exclusion keys are not supported in MRP Live. Insight: if planning suddenly expands scope, review unsupported exclusion logic.
Why this happens, scenario analysis and root cause.
1. MRP Live was redesigned with a simplified planning algorithm. 2. Certain classic MRP exclusion keys are not technically supported in the new engine. 3. Custom logic tied to exclusion keys is bypassed in in-memory processing. 4. Migration activates MRP Live without fully reviewing legacy planning dependencies. Algorithm simplification removes legacy planning constructs.
Why this is a migration-exclusive failure.
1. ECC Classic MRP supported extended exclusion key logic. 2. S/4HANA MRP Live does not replicate all classic behaviors. 3. The planning engine shift occurs only during migration. 4. Readiness checks do not simulate detailed exclusion scenarios. Unsupported logic surfaces only after activation of MRP Live.
Governance and accountability, RACI model.
In S/4HANA planning governance, accountable is the person who gets fired if the planning model fails. Responsible is the person who implements the technical correction. 1. Accountable PP functional lead for overall planning architecture stability. 2. Responsible ABAP lead HANA for adapting unsupported logic. 3. Consulted production planning manager for business validation. 4. Informed procurement leadership for inventory impact awareness. Functional leads own planning risk. Technical leads execute remediation.
Ownership, who actually fixes it.
This issue requires redesign, not parameter tweaking. 1. ABAP lead HANA evaluates alternative enhancement techniques compatible with MRP Live. 2. PP functional lead redesigns planning control strategy without unsupported keys. 3. Business planner validates planning scope after redesign. 4. Production planning manager signs off on revised planning governance.
Who gets blamed versus who owns it.
1. Blamed MRP Live for overplanning materials. 2. Blamed SAP simplification decisions. 3. Actual owner PP functional lead for relying on unsupported logic. 4. Root cause legacy exclusion constructs not compatible with new engine.
How this is actually fixed, the right way by a role.
1. ABAP lead HANA implements supported planning enhancement techniques. 2. PP functional lead replaces exclusion logic with valid planning parameters. 3. Business planner performs regression testing across material groups. 4. Procurement leadership reviews inventory exposure impact.
What not to do, common wrong fixes.
1. Reverting permanently to classic MD01. 2. Ignoring planning anomalies assuming they are minor. 3. Hard-coding material blocks without reviewing planning strategy. 4. Disabling MRP Live to preserve legacy behavior. Temporary bypasses create architectural fragmentation.
Follow-up 1. Why were exclusion keys removed from MRP Live?
Answer: MRP Live was redesigned for performance and simplification. Certain legacy constructs were not re-implemented in the in-memory engine. SAP prioritized algorithm efficiency over full backward compatibility.
Follow-up 2. How can we identify unsupported keys before go live?
Answer: by reviewing SAP simplification documentation and performing comparative MD01 and MD01 and simulations. Early sandbox testing reveals planning deviations before they impact production.
Follow-up 3. Curveball. Why does this sometimes increase inventory levels?
Answer: because excluded materials suddenly become part of planning scope. The system generates procurement proposals for materials previously ignored, increasing supply without corresponding demand adjustments.
Exclusive pro tip.
Before activating MRP Live, audit all exclusion keys and classic planning controls. Unsupported constructs must be redesigned, not assumed to behave identically in S/4HANA.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers. Required for your SAP functional modules interviews jobs like SAP Consultant jobs, SAP FICO Consultant jobs, SAP SD Consultant jobs, SAP PP Consultant jobs, SAP Ariba Consultant jobs, SAP Extended Warehouse Management EWM Consultant jobs, SAP Plant Maintenance PM Consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Scenario 51. Custom MRP baddies not triggered.
After migrating to S/4HANA and activating MRP Live, custom planning enhancements that worked in ECC are no longer executed. Planning results appear simplified. Certain materials are not prioritized correctly, and planners notice that embedded business rules are silently ignored.
Scenario classification.
1. Complexity critical custom logic loss. 2. Phase post-go-live stabilization. 3. Primary ownership ABAP lead HANA. 4. Supporting PP functional lead. 5. Business ownership production planning manager.
Diagnostic dashboard, symptoms and evidence.
How missing baddie execution appears and how to detect it early. 1. Symptom planning results differ despite unchanged master data. 2. Red flag custom priority logic or lot sizing behavior disappears after migration. 3. Business impact critical materials are not planned according to strategic rules. 4. Detection compare planning logs between ECC Classic MRP and S/4HANA MRP Live. 5. Technical proof. Debugging shows Classic MRP baddies are not called in MD01 in execution. Insight. If planning logic simplifies unexpectedly, custom code may be bypassed.
Why this happens, scenario analysis and root cause.
1. MRP Live runs on an in-memory algorithm different from Classic MRP. 2. Classic enhancement spots are not compatible with the new execution model. 3. Custom ABAP code tied to Classic baddies is not automatically migrated. 4. Migration activates MRP Live without re-implementing enhancements in aATP or HANA-based logic. MRP Live changes the execution engine, not just performance.
Why this is a migration-exclusive failure.
1. ECC Classic MRP supported traditional ABAP-based baddies. 2. S/4HANA MRP Live requires HANA-optimized enhancement techniques. 3. The shift in execution engine occurs only during migration. 4. Legacy enhancement dependencies are exposed after activation. The algorithm upgrade invalidates certain legacy extension points.
Governance and accountability, RACI model.
In S/4HANA planning governance, accountable is the person who gets fired if planning fails. Responsible is the person who rewrites the enhancement logic. 1. Accountable PP functional lead for overall planning design integrity. 2. Responsible ABAP lead HANA for re-implementing enhancements in supported frameworks. 3. Consulted business planner for validating planning behavior. 4. Informed production leadership regarding potential planning rule changes. Functional leads own planning architecture. ABAP leads execute technical adaptation.
Ownership, who actually fixes it.
This issue requires redesigning custom logic within supported frameworks. 1. ABAP lead HANA identifies unsupported Classic baddies and redesigns logic using HANA-compatible methods. 2. PP functional lead documents required planning rules and validates new behavior. 3. Business planner performs comparative regression testing. 4. Production planning manager signs off on updated planning outputs.
Who gets blamed versus who owns it.
1. Blamed MRP Live for ignoring business logic. 2. Blamed SAP for removing enhancement points. 3. Actual owner ABAP lead and PP functional lead for not re-implementing enhancements. 4. Root cause incompatible Classic extension model.
How this is actually fixed, the right way by a role.
1. ABAP lead HANA Re-implements custom logic using supported enhancement frameworks. 2. PP functional lead ensures planning configuration aligns with new logic. 3. Business planner validates behavior across multiple planning scenarios. 4. Solution architect reviews compliance with clean core principles.
What not to do, common wrong fixes.
1. Switching permanently back to classic MRP. 2. Ignoring missing logic assuming simplification is acceptable. 3. Reintroducing unsupported modification techniques. 4. Copying old ABAP logic without optimizing for HANA execution. Unsupported enhancements create long-term technical debt.
Follow-up 1. Why are classic baddies not automatically migrated?
Answer: because MRP Live runs on a fundamentally different execution model. Classic baddies were designed for traditional ABAP runtime, while MRP Live leverages in-memory processing that requires optimized enhancement techniques.
Follow-up 2. How can teams prepare for this before go live?
Answer: by performing a custom code impact analysis focused on MRP enhancements, identifying classic baddies, and testing MD01N behavior in sandbox systems helps expose gaps early.
Follow-up 3. Curveball. Why do planners sometimes prefer the simplified result?
Answer: because simplification removes complex logic that may have accumulated over time. However, removing strategic planning rules without governance can create subtle supply risks.
Exclusive pro tip.
Before activating MRP Live, inventory every custom baddie in planning. If it is critical in ECC, it must be redesigned, not assumed to work automatically in S/4HANA.
Scenario 52. aATP replaces classic ATP.
After ECC to S/4HANA migration, advanced available to promise replaces classic ATP logic. Sales orders that previously confirmed instantly now show different confirmation dates, partial confirmations, or unexpected backorder results. Business teams assume planning is broken, but the logic engine has fundamentally changed.
Scenario classification.
1. Complexity critical order fulfillment impact. 2. Phase post-go-live stabilization. 3. Primary ownership SD functional lead. 4. Supporting PP functional lead. 5. Business ownership order fulfillment manager.
Diagnostic dashboard, symptoms and evidence.
How the ATP logic shift manifests and how to detect it early. 1. Symptom: sales orders receive different confirmation quantities compared to ECC. 2. Red flag: backorder processing results change even with identical stock levels. 3. Business impact: customer commitments shift unexpectedly, impacting service levels. 4. Detection: compare ECC ATP results with S/4HANA aATP simulation before cutover. 5. Technical proof: aATP configuration shows new rule-based confirmation strategies active. Insight: if confirmation behavior changes without stock changes, ATP logic has shifted.
Why this happens, scenario analysis and root cause.
1. S/4HANA introduces advanced ATP with rule-based and backorder optimization capabilities. 2. Classic ECC ATP logic relied on simpler checking mechanisms. 3. Custom ATP enhancements may not be migrated automatically. 4. Migration activates new confirmation strategies without full business alignment. The engine upgrade alters how availability is calculated.
Why this is a migration-exclusive failure.
1. Classic ATP logic in ECC did not use rule-based optimization. 2. S/4HANA replaces or enhances ATP with aATP functionality. 3. The transition happens only during migration. 4. Business expectations remain anchored to ECC confirmation behavior. New logic without expectation alignment creates perceived failure.
Governance and accountability, RACI model.
In availability governance, accountable is the person who answers to sales leadership if deliveries fail. Responsible is the person configuring or adapting the ATP rules. 1. Accountable SD functional lead for confirmation strategy alignment. 2. Responsible SD functional team for configuring aATP rules and backorder logic. 3. Consulted PP functional lead for supply and planning constraints. 4. Informed sales and customer service leadership. Functional leads define availability policy. Technical teams implement supporting logic.
Ownership, who actually fixes it.
Resolving this requires business rule redesign, not system rollback. 1. SD functional lead reviews and redesigns aATP configuration rules. 2. PP functional lead validates supply chain constraints feeding ATP. 3. Integration team verifies interface alignment with external order systems. 4. Order fulfillment manager validates confirmation scenarios end-to-end.
Who gets blamed versus who owns it.
1. Blamed S/4HANA for changing order confirmations. 2. Blamed planning team for insufficient stock. 3. Actual owner SD functional lead for confirmation rule governance. 4. Root cause transition from classic ATP to advanced rule-based ATP.
How this is actually fixed, the right way by a role.
1. SD functional lead configures appropriate checking rules and backorder strategies. 2. PP functional lead aligns planning parameters with ATP expectations. 3. Business process owner tests realistic sales scenarios. 4. Solution architect ensures alignment with clean core principles.
What not to do, common wrong fixes.
1. Switching off advanced ATP features without evaluation. 2. Manually overriding confirmations for every order. 3. Blaming stock levels without reviewing ATP configuration. 4. Recreating legacy confirmation behavior without governance. Quick overrides destroy systemic availability logic.
Follow-up 1. Why does aATP produce different results even with the same stock?
Answer: because aATP uses rule-based logic, prioritization strategies, and backorder processing that differ from ECC. The same stock can be allocated differently based on new confirmation policies and sequencing logic.
Follow-up 2. Should we replicate ECC behavior exactly in aATP?
Answer: not necessarily. Migration offers an opportunity to modernize availability strategy. However, changes must be deliberate and aligned with business goals, not accidental side effects of system activation.
Follow-up 3. Curveball. Why do customers sometimes experience better service after aATP?
Answer: because rule-based confirmation can optimize allocation more intelligently. When configured properly, aATP improves fairness and responsiveness. The issue is not the tool, but how it is governed.
Exclusive pro tip.
Before activating advanced ATP, simulate critical sales scenarios and compare confirmation logic. Availability strategy must be a business decision, not a technical default.
Scenario 53. Net requirements calculation differences.
After migration to S/4HANA, planners notice that net requirements quantities differ from ECC results even though master data appears unchanged. Planned orders are either larger, smaller, or triggered at different times. The planning engine is working, but the calculation logic has subtly shifted.
Scenario classification.
1. Complexity, high planning accuracy risk. 2. Phase, post-go-live stabilization. 3. Primary ownership, PP functional lead. 4. Supporting ABAP lead if custom. 5. Business ownership, business planner, BPO.
Diagnostic dashboard, symptoms and evidence.
How requirement logic drift becomes visible in operations. 1. Symptom planned order quantities differ from historical ECC planning runs. 2. Red flag exception messages increase for shortage or excess stock. 3. Business impact inventory levels fluctuate unexpectedly or shortages increase. 4. Detection, compare MD01 results in ECC with MD01 and simulation in S/4HANA. 5. Technical proof. Net requirements calculation logs show different lot sizing or safety stock behavior. Insight. If quantity logic changes without master data change, planning calculation has shifted.
Why this happens, scenario analysis and root cause.
1. MRP Live uses optimized database procedures for calculation. 2. Lot sizing logic and safety stock consumption may be interpreted differently. 3. Custom enhancements in ECC MRP may not be active in MRP Live. 4. Migration activates stricter algorithmic consistency rules. S/4HANA recalculates demand using a refined planning engine.
Why this is a migration-exclusive failure.
1. ECC and S/4HANA use different calculation engines. 2. Custom logic embedded in classic MRP may not transfer automatically. 3. Algorithmic shifts only occur during system conversion. 4. Planning expectations remain aligned to legacy results. Engine upgrades change results even when data stays constant.
Governance and accountability, RACI model.
Accountable is the person who answers if inventory balloons or shortages spike. Responsible is the person validating and correcting the planning logic. 1. Accountable PP functional lead for planning logic governance. 2. Responsible PP functional team for reviewing lot sizing and safety stock settings. 3. Consulted ABAP lead if custom calculation logic exists. 4. Informed business planner and supply chain leadership. Planning architecture is owned functionally, even when technical recalculation occurs.
Ownership, who actually fixes it.
Fixing quantity drift requires recalibrating logic, not manual order edits. 1. PP functional lead reviews lot size procedures and safety stock parameters. 2. ABAP lead analyzes any custom MRP enhancements or calculation exits. 3. Business planner validates revised planning outputs against business expectations. 4. Project governance ensures regression testing across representative materials.
Who gets blamed versus who owns it.
1. Blamed S/4HANA planning engine. 2. Blamed master data team for incorrect safety stock. 3. Actual owner PP functional lead for planning configuration governance. 4. Root cause algorithmic shift combined with legacy expectation.
How this is actually fixed, the right way by a role.
1. PP functional lead aligns planning parameters with business policy. 2. ABAP lead reimplements required custom logic in HANA-compliant form if needed. 3. Business planner validates outputs through controlled simulation cycles. 4. Supply chain leadership signs off on recalibrated planning standards.
What not to do, common wrong fixes.
1. Manually adjusting planned orders daily. 2. Reverting to classic MRP without root cause analysis. 3. Blaming stock levels without checking calculation logic. 4. Ignoring exception message spikes after migration. Manual fixes mask algorithmic misalignment.
Follow-up 1. Why does safety stock behave differently in MRP Live?
Answer: MRP Live may consume safety stock differently depending on configuration and lot sizing procedures. The optimized calculation engine can interpret parameters more strictly than ECC, exposing inconsistencies that were previously tolerated.
Follow-up 2. Can custom exits from ECC be reused in S/4HANA?
Answer: not automatically. Classic user exits must be redesigned using HANA-compliant techniques such as aATP or CDS-based logic. Without reimplementation, legacy adjustments will not influence the new planning engine.
Follow-up 3. Curveball. Why can this sometimes improve inventory health?
Answer: because stricter calculation logic reduces hidden inefficiencies. When aligned properly, S/4HANA planning can produce leaner and more predictable supply results than legacy ECC logic.
Exclusive pro tip.
When net requirements change after migration, treat it as a planning recalibration exercise. Compare algorithm behavior first before touching master data.
Scenario 54. MRP exception messages differ.
After migrating to S/4HANA, planners observe that MRP exception messages differ from ECC even when material data remains unchanged. New exception types appear, while some legacy alerts disappear. The planning system behaves correctly, but the messaging logic has evolved.
Scenario classification.
1. Complexity medium planning interpretation risk. 2. Phase post-go-live stabilization. 3. Primary ownership PP functional lead. 4. Supporting business planner BPO. 5. Business ownership supply chain manager.
Diagnostic dashboard, symptoms and evidence.
How exception drift becomes visible in planning execution. 1. Symptom: planners see new or missing exception messages in MD01N. 2. Red flag: planning dashboard alerts no longer match historical ECC behavior. 3. Business impact: planners react incorrectly due to unfamiliar or missing alerts. 4. Detection: compare ECC MD0 for exception output with S/4HANA MRP Live results. 5. Technical proof: exception message configuration tables show revised mapping and priorities. Insight: if planners are confused, the issue is often message logic, not material logic.
Why this happens, scenario analysis and root cause.
1. MRP Live uses updated exception determination logic. 2. Certain ECC exception categories are consolidated or replaced. 3. Priority settings may differ in S/4HANA. 4. Custom exception handling enhancements from ECC may not be active. Exception logic reflects planning philosophy shifts.
Why this is a migration-exclusive failure.
1. Exception message structure changed in S/4HANA. 2. Planning engine logic and alert grouping evolved. 3. Legacy planner training is based on ECC message interpretation. 4. Conversion activates new message control standards. Alert behavior changes only when planning architecture changes.
Governance and accountability, RACI model.
Accountable is the person who answers when planners escalate confusion. Responsible is the person reviewing configuration and message control. 1. Accountable PP functional lead for exception configuration governance. 2. Responsible PP functional team for reviewing exception priorities and grouping. 3. Consulted business planner for real-world usability validation. 4. Informed supply chain leadership. Exception clarity is a functional responsibility, not a technical accident.
Ownership, who actually fixes it.
Fixing message drift requires configuration review and planner retraining. 1. PP functional lead reviews and aligns exception message control settings. 2. Business planner validates practical interpretation of revised messages. 3. Training team updates planning SOPs to reflect new alert behavior. 4. Governance ensures no custom enhancements are missing.
Who gets blamed versus who owns it.
1. Blamed S/4HANA for changing standard messages. 2. Blamed IT team for incorrect configuration. 3. Actual owner PP functional lead for alert governance. 4. Root cause evolution of planning message architecture.
How this is actually fixed, the right way by a role.
1. PP functional lead realigns exception configuration and priority settings. 2. Business planner tests alerts across representative materials. 3. Training lead updates planner guidance and documentation. 4. Supply chain manager signs off on revised exception governance.
What not to do, common wrong fixes.
1. Ignoring new exception messages as noise. 2. Manually overriding planning decisions without understanding logic. 3. Disabling exception alerts to reduce planner workload. 4. Blaming master data without reviewing message configuration. Silencing alerts does not solve planning misalignment.
Follow-up 1. Why do some ECC exception messages disappear in S/4HANA?
Answer: S/4HANA consolidates and optimizes exception categories to reduce redundancy. Certain legacy alerts are replaced by broader or more structured messages, aligned with MRP Live logic.
Follow-up 2. Can we customize exception priorities?
Answer: yes. Exception message control can be configured in planning settings. However, changes should be validated against business workflows to avoid misinterpretation.
Follow-up 3. Curveball. Why can improved exception logic increase planner productivity?
Answer: because consolidated and prioritized alerts reduce noise and focus planners on actionable risks. When aligned correctly, S/4HANA can streamline decision-making compared to ECC.
Exclusive pro tip.
When exception messages change after migration, review configuration and planner training together. Planning intelligence is as much behavioral as it is technical.
Scenario 55. Pegging logic changes.
After ECC to S/4HANA migration, planners notice that pegging relationships between supply and demand behave differently. Planned orders and purchase requisitions are no longer linked exactly as they were in ECC. Stock appears correct, but demand tracing becomes inconsistent.
Scenario classification.
1. Complexity, high demand traceability risk. 2. Phase, post-go-live stabilization. 3. Primary ownership, PP functional lead. 4. Supporting project manager. 5. Business ownership, supply chain planning head.
Diagnostic dashboard, symptoms and evidence.
How pegging inconsistencies become visible during execution. 1. Symptom: demand elements no longer show expected pegged supply in MD04. 2. Red flag: sales orders appear unlinked to production or procurement proposals. 3. Business impact: planners lose confidence in supply traceability and allocation. 4. Detection, compare pegging results between ECC MD04 and S4HANA planning runs. 5. Technical proof. MRP Live logs reveal different pegging evaluation sequences. Insight, if supply exists but tracing fails, pegging logic likely changed.
Why this happens, scenario analysis and root cause.
1. MRP Live processes net requirements differently from classic MRP. 2. Advanced planning logic prioritizes availability checks differently. 3. Changes in lot sizing or rescheduling influence pegging chains. 4. Parallel processing affects sequencing of supply allocation. Pegging reflects algorithm behavior, not just master data.
Why this is a migration-exclusive failure.
1. ECC Classic MRP use sequential single-thread processing. 2. S4HANA MRP Live introduces parallel and optimized evaluation. 3. Planning priorities may shift during migration. 4. The enforcement of deterministic logic alters pegging outcomes. Algorithm upgrades change supply traceability patterns.
Governance and accountability, RACI model.
Accountable is the person who answers when supply traceability breaks. Responsible is the person validating planning configuration and testing results. 1. Accountable PP functional lead for planning logic governance. 2. Responsible PP functional team for pegging configuration validation. 3. Consulted project manager for impact on supply commitments. 4. Informed supply chain planning head. Planning traceability must be owned at the functional architecture level.
Ownership, who actually fixes it.
Pegging drift requires configuration review and regression testing. 1. PP functional lead reviews MRP parameters influencing supply allocation. 2. PP functional team conducts controlled comparison testing between ECC and S4HANA. 3. Project manager coordinates cross-functional impact assessment. 4. Supply chain planning head signs off on revised pegging behavior.
Who gets blamed versus who owns it.
1. Blamed system performance due to parallel processing. 2. Blamed technical team for incorrect migration. 3. Actual owner PP functional lead for planning governance. 4. Root cause algorithmic shift in supply evaluation.
How this is actually fixed, the right way by a role.
1. PP functional lead revalidates planning control parameters and lot sizing. 2. Project manager oversees integrated regression testing across demand scenarios. 3. Business planner validates pegging transparency during live simulations. 4. Supply chain leadership confirms acceptance of updated logic.
What not to do, common wrong fixes.
1. Manually adjusting supply links without root cause analysis. 2. Reverting to classic MRP without strategic evaluation. 3. Ignoring planner confusion during stabilization. 4. Assuming pegging differences indicate master data corruption. Pegging differences are architectural, not transactional errors.
Follow-up 1. Does parallel processing cause pegging drift?
Answer: parallel processing changes evaluation sequencing. While mathematically consistent, the visual trace of supply to demand may differ compared to sequential ECC logic.
Follow-up 2. Can pegging behavior be customized?
Answer: planning parameters such as lot size and availability checks influence pegging outcomes. However, deep algorithmic behavior is governed by MRP Live architecture.
Follow-up 3. Curveball. Why is pegging transparency more important than exact replication of ECC?
Answer: because planners rely on clear traceability rather than identical sequencing. If transparency is maintained, planning performance improves even if behavior differs.
Exclusive pro tip.
Never aim to replicate ECC pegging exactly. Aim to validate that S4HANA planning logic is consistent, transparent, and aligned with business expectations.
Scenario 56. Subcontracting planning differences.
After ECC to S4HANA migration, subcontracting components are planned differently under MRP Live. Purchase requisitions and dependent requirements do not align exactly as they did in ECC. Planners observe unexpected timing shifts in subcontracting supply proposals.
Scenario classification.
1. Complexity, high procurement and production alignment risk. 2. Phase, post-go-live stabilization. 3. Primary ownership, MM functional lead. 4. Supporting PP functional lead. 5. Business ownership procurement head.
Diagnostic dashboard, symptoms and evidence.
How subcontracting planning drift becomes visible in procurement and execution. 1. Symptom. Subcontracting purchase requisitions are created with unexpected dates or quantities. 2. Red flag. Components are not reserved correctly for subcontracting vendors. 3. Business impact. Vendor deliveries are delayed and production schedules slip. 4. Detection. Compare subcontracting planning results between ECC and S/4HANA MRP Live runs. 5. Technical proof. MRP Live logs show altered component explosion timing for subcontracting bombs. Insight. If subcontracting proposals shift, planning logic must be reviewed.
Why this happens, scenario analysis and root cause.
1. MRP Live evaluates subcontracting BOM components differently from classic MRP. 2. Lead time scheduling logic changes under optimized HANA processing. 3. Lot sizing and safety stock parameters influence subcontracting supply proposals. 4. Material ledger and valuation integration may alter procurement timing. Subcontracting planning is sensitive to algorithmic shifts.
Why this is a migration-exclusive failure.
1. ECC subcontracting logic relied on sequential MRP processing. 2. S/4HANA MRP Live introduces optimized parallel logic. 3. Planning parameters may be reinterpreted under new architecture. 4. The shift becomes visible only after migration activates MRP Live. Migration activates stricter and faster planning evaluation.
Governance and accountability, RACI model.
Accountable is the person who answers if subcontracting supply fails. Responsible is the person who reviews configuration and procurement logic. 1. Accountable functional lead for subcontracting configuration governance. 2. Responsible PP functional lead for planning parameter validation. 3. Consulted procurement head for vendor lead time confirmation. 4. Informed supply chain leadership. Accountability defines architectural ownership. Responsibility defines execution.
Ownership, who actually fixes it.
Subcontracting drift requires coordinated review of planning and procurement settings. 1. functional lead reviews subcontracting special procurement keys and purchasing parameters. 2. PP functional lead validates MRP settings influencing component explosion. 3. Procurement head confirms vendor lead times and scheduling agreements. 4. Supply chain leadership approves revised planning logic.
Who gets blamed versus who owns it.
1. Blamed vendors for delayed deliveries. 2. Blamed system performance due to MRP Live speed. 3. Actual owner functional lead for subcontracting configuration. 4. Root cause planning algorithm shift after migration.
How this is actually fixed, the right way by a role.
1. functional lead realigns subcontracting procurement configuration. 2. PP functional lead adjusts MRP parameters and validates explosion results. 3. Procurement head confirms vendor scheduling consistency. 4. Business planner validates stability across multiple planning cycles.
What not to do, common wrong fixes.
1. Manually adjusting purchase requisitions without configuration review. 2. Blaming vendors without validating lead time parameters. 3. Switching off MRP Live to restore old behavior. 4. Ignoring long-term procurement impact during stabilization. Temporary fixes in procurement create long-term planning instability.
Follow-up 1. Why do subcontracting proposals shift after migration?
Answer: because MRP Live evaluates dependent requirements and lead times differently from classic MRP. Even small parameter differences can produce visible scheduling shifts.
Follow-up 2. Does material ledger affect subcontracting planning?
Answer: material ledger primarily impacts valuation, but integration with procurement timing can influence planning outcomes when cost-based logic interacts with supply proposals.
Follow-up 3. Curveball. Should companies try to replicate ECC subcontracting exactly?
Answer: not necessarily. The goal is planning stability and transparency, not identical sequencing. S/4HANA logic may be more optimized if governed correctly.
Exclusive pro tip.
When subcontracting behaves differently after migration, review planning parameters before blaming procurement execution. Architecture drives behavior.
Scenario 57. Phantom explosion behavior changes.
After migration to S/4HANA, phantom assemblies no longer explode exactly as they did in ECC. MRP Live generates different dependent requirements or planning levels, causing planners to question BOM integrity and costing consistency.
Scenario classification.
1. Complexity, high multi-level planning sensitivity. 2. Phase, post-go-live stabilization. 3. Primary ownership, PP functional lead. 4. Supporting CO functional lead. 5. Business ownership, production planning manager.
Diagnostic dashboard, symptoms and evidence.
How phantom assembly shifts surface during planning and costing. 1. Symptom, dependent requirements appear at unexpected levels in MRP results. 2. Red flag, phantom components generate separate procurement proposals instead of inline explosion. 3. Business impact, production sequencing becomes misaligned and cost roll-up shift. 4. Detection, compare multi-level BOM explosion results between ECC and S4HANA. 5. Technical proof, MD01N logs show altered explosion sequence under MRP live processing. Insight, phantom behavior is algorithm sensitive in S4HANA.
Why this happens, scenario analysis and root cause.
1. MRP Live processes multi-level BOMs using optimized HANA logic. 2. Phantom indicators interact differently with planning time fences and lot sizing. 3. Custom enhancements in ECC may have influenced explosion sequence. 4. Migration activates deterministic explosion sequencing under new architecture. Phantom assemblies behave differently when planning logic becomes stricter.
Why this is a migration-exclusive failure.
1. ECC allowed flexible interpretation of phantom explosion under classic MRP. 2. S4HANA MRP Live enforces structured multi-level processing. 3. Algorithm optimization changes explosion timing and requirement grouping. 4. The issue becomes visible only when MRP Live replaces classic MRP. Migration reveals subtle planning architecture differences.
Governance and accountability, RACI model.
Accountable is the person responsible for planning architecture if phantom logic misaligns. Responsible is the person validating configuration and BOM strategy. 1. Accountable, PP functional lead for multi-level planning governance. 2. Responsible, PP functional lead for phantom indicator validation and configuration review. 3. Consulted, CO functional lead for costing roll-up implications. 4. Informed, production planning manager. Accountability governs architecture. Responsibility governs execution.
Ownership, who actually fixes it.
Phantom explosion issues require structured planning analysis, not system rollback. 1. PP functional lead reviews phantom indicators and multi-level planning settings. 2. PP functional lead validates MRP parameters affecting explosion logic. 3. CO functional lead verifies cost roll-up consistency. 4. Production planning manager confirms operational feasibility.
Who gets blamed versus who owns it.
1. Blamed system performance under MRP Live. 2. Blamed HANA processing speed for unexpected behavior. 3. Actual owner PP functional lead for phantom configuration strategy. 4. Root cause algorithmic shift in multi-level planning.
How this is actually fixed, the right way by a role.
1. PP functional lead standardizes phantom assembly configuration across plants. 2. PP functional lead aligns planning parameters influencing explosion sequence. 3. CO functional lead revalidates costing structure after adjustments. 4. Production planning manager signs off on revised planning outcomes.
What not to do, common wrong fixes.
1. Removing phantom indicators without structural analysis. 2. Switching back to classic MRP to avoid planning drift. 3. Ignoring costing impact while adjusting BOM logic. 4. Applying emergency manual adjustments to dependent requirements. Planning consistency is more important than restoring legacy behavior.
Follow-up 1. Why do phantom assemblies behave differently in S4HANA?
Answer: because MRP Live processes BOM levels using optimized HANA logic that enforces deterministic explosion rules. The flexibility of classic MRP is replaced by structured sequencing.
Follow-up 2. Does this impact costing directly?
Answer: yes. If explosion timing changes, cost component roll-ups and variance calculations may shift. CO validation is critical to maintain valuation integrity.
Follow-up 3, curveball. Should companies redesign phantom strategy during migration?
Answer: migration provides an opportunity to standardize phantom usage. However, redesign must align with business execution capability, not only technical feasibility.
Exclusive pro tip.
When phantom behavior shifts after migration, analyze planning architecture before assuming system error. S/4HANA enforces discipline in multi-level logic.
Scenario 58, multi-level BOM planning drift.
After migrating to S/4HANA, multi-level BOM planning results no longer align with ECC outcomes. Dependent requirements are generated in different quantities or timing, creating confusion in procurement and capacity planning.
Scenario classification.
1. Complexity, critical multi-level planning impact. 2. Phase, post-go-live stabilization. 3. Primary ownership, PP functional lead. 4. Supporting CO functional lead. 5. Business ownership, production planning manager.
Diagnostic dashboard, symptoms and evidence.
How multi-level drift becomes visible across planning layers. 1. Symptom: lower-level components show unexpected shortages despite stable finished good demand. 2. Red flag: planning results differ significantly between MD01 and MD01 in simulation runs. 3. Business impact: procurement orders increase or decrease unpredictably, affecting supplier commitments. 4. Detection: compare net requirements across levels using classic and MRP Live Planning logs. 5. Technical proof: MD01 in execution logs reveal changed explosion sequence and requirement aggregation. Insight: multi-level drift is usually algorithmic, not master data corruption.
Why this happens, scenario analysis and root cause.
1. MRP Live processes BOM levels using in-memory HANA logic. 2. Requirement grouping and lot sizing calculations behave differently than ECC. 3. Custom logic in ECC may have influenced net requirement calculations. 4. Migration shifts planning from flexible batch processing to deterministic logic. Planning logic changes are subtle but compound across levels.
Why this is a migration-exclusive failure.
1. ECC Classic MRP allowed broader tolerance in multi-level calculations. 2. S/4HANA MRP Live enforces optimized algorithm consistency. 3. HANA-based aggregation changes requirement timing behavior. 4. This planning shift becomes visible only when classic MRP is replaced. Algorithm modernization exposes structural planning differences.
Governance and accountability, RACI model.
Accountable is the person who signs off on planning architecture integrity. Responsible is the person validating multi-level planning configuration. 1. Accountable, PP functional lead for end-to-end planning architecture. 2. Responsible, PP functional lead for validating lot sizing and explosion parameters. 3. Consulted, CO functional lead for cost and valuation alignment. 4. Informed, production planning manager. Accountability governs planning structure. Responsibility governs configuration execution.
Ownership, who actually fixes it.
Multi-level drift requires architectural review, not transactional correction. 1. PP functional lead analyzes lot sizing, scheduling, and requirement aggregation settings. 2. PP functional lead validates multi-level BOM consistency across plants. 3. CO functional lead verifies cost impact of requirement timing changes. 4. Production planning manager validates revised planning proposals.
Who gets blamed versus who owns it.
1. Blamed HANA performance for changing output. 2. Blamed SAP algorithm updates. 3. Actual owner PP functional lead for planning configuration alignment. 4. Root cause deterministic planning logic replacing flexible ECC behavior.
How this is actually fixed, the right way by a role.
1. PP functional lead aligns lot sizing and planning time fence configuration. 2. PP functional lead reviews multi-level planning strategy with business planners. 3. CO functional lead validates cost component consistency. 4. Production planning manager approves revised planning output after regression tests.
What not to do, common wrong fixes.
1. Forcing manual procurement orders to compensate for drift. 2. Switching off MRP Live to restore ECC-like behavior. 3. Ignoring cost impact of requirement timing shifts. 4. Assuming BOM master data is corrupted without algorithm analysis. Manual overrides hide algorithmic gaps and create long-term instability.
Follow-up 1. Why does MRP Live generate different quantities than ECC?
Answer: MRP Live uses in-memory processing and optimized aggregation logic. These algorithmic improvements change how dependent requirements are grouped and timed across BOM levels.
Follow-up 2. Is this considered a system defect?
Answer: in most cases, no. The system behaves according to redesigned planning logic. The issue lies in configuration alignment and expectation management rather than technical malfunction.
Follow-up 3. Curveball. Can this improve planning accuracy long-term?
Answer: yes, if configuration is optimized. Deterministic planning reduces ambiguity and improves consistency, but only when master data governance and lot sizing strategy are aligned.
Exclusive pro tip.
When multi-level planning drifts after migration, treat it as an architectural recalibration opportunity rather than a defect investigation.
Scenario 59. CTM or optimization profile loss in embedded planning.
During ECC to S/4HANA migration, advanced planning strategies such as capable to match or optimizer profiles used in APO do not migrate cleanly into embedded planning. After go-live, planning runs complete without errors, but constrained or priority-based results no longer behave as before.
Scenario classification.
1. Complexity, critical advanced planning strategy impact. 2. Phase, conversion window and post-go-live. 3. Primary ownership, PPDS lead. 4. Supporting basis lead. 5. Business ownership, advanced planning manager.
Diagnostic dashboard, symptoms and evidence.
How loss of advanced optimization logic appears in real operations. 1. Symptom: constrained materials are planned as if infinite capacity exists. 2. Red flag: planning runs execute faster but ignore previous priority sequences. 3. Business impact: high priority customer orders lose allocation preference. 4. Detection: compare historical APO planning results with embedded planning output. 5. Technical proof: missing optimizer or heuristic profile assignments in planning configuration. Insight: faster planning does not mean smarter planning.
Why this happens, scenario analysis and root cause.
1. Embedded planning does not automatically migrate APO optimizer profiles. 2. Certain capable to match logic is not supported natively in S/4HANA. 3. Planning versions and profiles require manual recreation. 4. Advanced planning assumptions are often undocumented in ECC. Migration removes silent dependencies on APO optimization logic.
Why this is a migration-exclusive failure.
1. ECC with APO maintained optimizer logic externally. 2. S/4HANA embedded planning changes architecture and profile handling. 3. There is no automated one-to-one migration for all advanced profiles. 4. The planning engine transition exposes undocumented strategic rules. What worked silently in APO must be redesigned explicitly in S/4HANA.
Governance and accountability, RACI model.
Accountable is the person who signs off on advanced planning architecture. Responsible is the person configuring and validating planning profiles. 1. Accountable PPDS lead for advanced planning strategy integrity. 2. Responsible PPDS lead for recreating heuristics and optimizer profiles. 3. Consulted basis lead for technical activation and performance validation. 4. Informed advanced planning manager for business priority confirmation. Accountability governs planning intelligence. Responsibility governs execution accuracy.
Ownership, who actually fixes it.
Advanced planning gaps require strategic reconstruction, not parameter tweaking. 1. PPDS lead documents and recreates optimization and heuristic profiles. 2. PPDS lead aligns constrained planning rules with business priority logic. 3. Basis lead validates system performance and technical activation. 4. Advanced planning manager signs off on constrained planning results.
Who gets blamed versus who owns it.
1. Blamed S/4HANA embedded planning engine. 2. Blamed performance optimization changes. 3. Actual owner PPDS lead for advanced planning configuration alignment. 4. Root cause, non-migrated optimization profiles from APO.
How this is actually fixed, the right way by a role.
1. PPDS lead rebuilds optimizer and heuristic configuration. 2. PPDS lead validates planning priority logic against historical scenarios. 3. Basis lead stress tests constrained planning under realistic load. 4. Advanced Planning Manager approves new planning strategy.
What not to do, common wrong fixes.
1. Switching off constrained planning to regain stability. 2. Assuming embedded planning will replicate APO automatically. 3. Ignoring business priority rules during migration. 4. Treating optimizer differences as minor performance changes. Advanced planning logic must be rebuilt intentionally, not assumed.
Follow-up 1. Why do planning results look simpler after migration?
Answer: because optimizer and constrained planning logic may not be active. Embedded planning defaults to standard heuristics unless advanced profiles are explicitly configured.
Follow-up 2. Can embedded planning fully replace APO optimization?
Answer: in many cases, yes, but configuration must be recreated manually. Without careful alignment, constrained logic and prioritization behavior will differ significantly.
Follow-up 3. Curveball. Why do teams underestimate optimizer migration?
Answer: because optimization rules are often embedded in legacy configuration without documentation. Migration forces explicit redesign, exposing strategic planning dependencies that were never formalized.
Exclusive pro tip.
When advanced planning appears simpler after migration, assume optimization logic was lost before assuming system improvement.
Scenario 60. PPDS versus MRP Live Planning Drift.
After ECC to S/4HANA conversion, organizations running embedded production planning and detailed scheduling alongside MRP Live notice that planning results no longer align. Quantities, dates, and resource loads differ even though master data appears correct. Business users question which engine is correct.
Scenario classification.
1. Complexity, critical dual planning engine conflict. 2. Phase, post-go-live stabilization. 3. Primary ownership, PPDS lead. 4. Supporting PP functional lead. 5. Business ownership, planning manager.
Diagnostic dashboard, symptoms and evidence.
How dual planning engine conflicts appear in daily operations. 1. Symptom: MRP Live proposes one set of dates while PPDS schedules different ones. 2. Red flag: capacity loads differ between classic MRP evaluation and detailed scheduling board. 3. Business impact: production planners manually override system results, reducing trust in automation. 4. Detection: side-by-side comparison of planned orders between MRP Live and PPDS. 5. Technical proof: planning mode and heuristic configuration inconsistencies between engines. Insight: two engines without harmonized governance create two versions of planning truth.
Why this happens, scenario analysis and root cause.
1. MRP Live performs infinite or simplified capacity logic by default. 2. PPDS executes finite scheduling with detailed constraints. 3. Planning parameters are not harmonized between engines. 4. Migration introduces embedded planning without redefining governance boundaries. Different algorithms naturally produce different results.
Why this is a migration-exclusive failure.
1. ECC often separated classic MRP and APO clearly. 2. S/4HANA embeds detailed scheduling inside the core system. 3. Dual planning becomes more tightly coupled during migration. 4. Architectural governance must be redesigned during transformation. Embedded architecture increases coordination complexity.
Governance and accountability, RACI model.
Accountable is the person who owns planning architecture integrity. Responsible is the person aligning configuration across engines. 1. Accountable PPDS lead for advanced scheduling strategy sign-off. 2. Responsible PP functional lead for harmonizing MRP parameters. 3. Consulted basis lead for performance and engine execution checks. 4. Informed planning manager for operational validation. Planning governance must be unified across all engines.
Ownership, who actually fixes it.
Engine drift is solved through parameter harmonization, not user overrides. 1. PPDS lead defines clear boundary between detailed scheduling and MRP responsibilities. 2. PP functional lead aligns planning parameters and lot sizing rules. 3. Basis lead validates runtime and integration consistency. 4. Planning manager confirms single source of planning truth.
Who gets blamed versus who owns it?
1. Blamed MRP Live performance. 2. Blamed embedded PPDS complexity. 3. Actual owner planning governance misalignment. 4. Root cause lack of defined planning engine boundaries.
How this is actually fixed, the right way by a role.
1. PPDS lead defines primary scheduling engine ownership. 2. PP functional lead harmonizes planning parameters. 3. Basis lead validates consistent runtime execution. 4. Planning manager approves consolidated planning strategy.
What not to do, common wrong fixes.
1. Allowing planners to manually override inconsistencies. 2. Running both engines without governance definition. 3. Blaming system performance for algorithmic differences. 4. Ignoring engine parameter documentation. Without governance, dual engines create dual confusion.
Follow-up 1. Which engine should be considered authoritative?
Answer: the organization must define a primary planning authority. Without a clear governance model, both engines may generate valid but conflicting outputs.
Follow-up 2. Is it safe to disable one engine?
Answer: only after strategic evaluation. Disabling advanced scheduling without understanding business constraints can reduce planning accuracy.
Follow-up 3. Curveball. Why does this issue often appear months after go-live?
Answer: because planning load and real business complexity increase over time. Initial testing rarely simulates full operational variability.
Exclusive pro tip.
If two planning engines disagree, the issue is not performance, it is governance.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Scenario 61. aATP rule-based available to promise not migrated.
During ECC to S/4HANA migration, classic rule-based available to promise logic is replaced by advanced available to promise. After go-live, sales orders are blocked, confirmations are delayed, or allocations behave unpredictably because legacy rule logic was never redesigned for advanced available to promise.
Scenario classification.
1. Complexity critical order confirmation blocking. 2. Phase during conversion and post-go-live. 3. Primary ownership SD functional lead. 4. Supporting PP functional lead. 5. Business ownership order fulfillment manager.
Diagnostic dashboard, symptoms and evidence.
How confirmation logic breaks after migration. 1. Symptom sales orders are rejected or confirmed with unrealistic dates. 2. Red flag backorder processing behaves differently compared to ECC. 3. Business impact, customer delivery reliability drops and manual overrides increase. 4. Detection, comparison of ECC confirmation logic versus advanced available to promise simulation. 5. Technical proof, missing condition records and rule mappings in advanced available to promise configuration. Insight, if confirmations look random, rule migration was incomplete.
Why this happens, scenario analysis and root cause.
1. ECC rule-based available to promise logic is not automatically converted. 2. Advanced available to promise uses new configuration frameworks. 3. Legacy allocation and product availability rules are not replicated. 4. Readiness checks identify activation but not behavioral equivalence. Activation does not equal behavioral migration.
Why this is a migration-exclusive failure.
1. ECC and S4HANA use different available to promise engines. 2. Advanced available to promise introduces new rule modeling concepts. 3. Migration replaces confirmation architecture entirely. 4. This logic shift only occurs during transformation. Order confirmation logic changes fundamentally in S4HANA.
Governance and accountability, RACI model.
Accountable is the person who signs off on confirmation strategy. Responsible is the person implementing the new rule configuration. 1. Accountable, SD functional lead for confirmation architecture sign-off. 2. Responsible, SD functional lead for advanced available to promise configuration. 3. Consulted, PP functional lead for planning and capacity alignment. 4. Informed, order fulfillment manager for operational validation. Confirmation governance must be redesigned, not copied.
Ownership, who actually fixes it.
This is a configuration redesign, not a bug fix. 1. SD functional lead redesigns advanced available to promise rules and allocation logic. 2. PP functional lead aligns supply planning parameters. 3. Business process owner validates order confirmation results in end-to-end testing. 4. Basis lead ensures performance stability during high-volume backorder processing.
Who gets blamed versus who owns it.
1. Blamed system performance. 2. Blamed S4HANA algorithm changes. 3. Actual owner confirmation rule redesign oversight. 4. Root cause legacy logic assumptions not migrated.
How this is actually fixed, the right way by a role.
1. SD functional lead rebuilds rule-based confirmation in advanced available to promise. 2. PP functional lead validates supply synchronization. 3. Business owner executes full regression scenarios with realistic demand patterns. 4. Project lead signs off on confirmation governance model.
What not to do, common wrong fixes.
1. Copying ECC configuration screenshots into S4HANA. 2. Disabling advanced available to promise checks without analysis. 3. Allowing manual overrides to hide confirmation drift. 4. Assuming system performance is the primary cause. Confirmation chaos is rarely technical, it is architectural.
Follow-up 1. Why does advanced available to promise feel stricter than ECC?
Answer: because advanced available to promise enforces allocation and prioritization logic more explicitly. ECC allowed flexible confirmation adjustments. S4HANA requires structured rule modeling.
Follow-up 2. Can this be validated before go live?
Answer: yes, but only with realistic demand simulations and backorder processing scenarios. Unit testing alone is insufficient.
Follow-up 3. Curveball. Why do business users trust ECC confirmations more?
Answer: because ECC logic was familiar and forgiving. Advanced available to promise exposes hidden prioritization assumptions that were never formally defined.
Exclusive pro tip.
Advanced available to promise is not a technical upgrade. It is a governance redesign. Treat it as a business transformation project.
Scenario 62. MRP Live aATP reimplementation required.
During ECC to S4HANA migration, custom MRP enhancements built using classic baddies or user exits no longer execute under MRP Live. After go live, planning results ignore custom prioritization, substitution logic, or stock manipulation rules because MRP Live requires HANA-based aATP implementations instead of classic exits.
Scenario classification.
1. Complexity, critical core planning logic impact. 2. Phase during conversion and post-go live. 3. Primary ownership ABAP lead HANA. 4. Supporting PP functional lead. 5. Business ownership planning process owner.
Diagnostic dashboard, symptoms and evidence.
How custom planning logic silently disappears. 1. Symptom planning results differ significantly from ECC for identical master data. 2. Red flag custom baddies that worked in MD01 are not triggered in MD01N. 3. Business impact supply prioritization rules are ignored, leading to incorrect procurement proposals. 4. Detection debugging shows classic user exits not called during MRP live execution. 5. Technical proof missing aATP implementations for required MRP live enhancement spots. Insight: if MRP logic feels simplified, custom enhancements were not migrated.
Why this happens, scenario analysis and root cause.
1. MRP Live executes on HANA using SQL script-based aATP logic. 2. Classic baddies and user exits are not executed in MRP Live runtime. 3. Custom planning logic was built for the classic MRP engine. 4. Migration does not automatically convert classic exits into aATP logic. S/4HANA changes the execution engine, not just the transaction code.
Why this is a migration-exclusive failure.
1. ECC MRP relied on classic ABAP-based enhancement framework. 2. S/4HANA MRP Live runs directly on HANA database procedures. 3. Enhancement frameworks differ fundamentally between engines. 4. This incompatibility appears only when switching to MRP Live. It is not a bug. It is an architectural shift.
Governance and accountability, RACI model.
Accountable is the person who approves the planning logic architecture. Responsible is the person rewriting the enhancement in HANA. 1. Accountable PP functional lead for planning logic approval. 2. Responsible ABAP lead HANA for MDP reimplementation. 3. Consulted basis lead for HANA performance validation. 4. Informed planning business process owner for result verification. Aligned with enterprise governance. Functional leads own logic. ABAP owns implementation. Basis owns runtime stability.
Ownership, who actually fixes it.
This is a technical re-engineering project, not a configuration adjustment. 1. ABAP lead HANA redesigns classic enhancement logic into aATP-based implementation. 2. PP functional lead validates business rule equivalence. 3. Basis lead monitors performance impact of SQL script procedures. 4. Planning business owner approves final planning behavior.
Who gets blamed versus who owns it.
1. Blamed MRP Live performance. 2. Blamed HANA complexity. 3. Actual owner enhancement migration oversight. 4. Root cause classic exits incompatible with MRP Live architecture.
How this is actually fixed, the right way by a role.
1. ABAP lead HANA rewrites custom MRP enhancements using aATP framework. 2. PP functional lead validates planning logic through controlled test cycles. 3. Basis lead performs HANA performance optimization for new procedures. 4. Project architect ensures future enhancements follow HANA-compatible standards.
What not to do, common wrong fixes.
1. Forcing users back to classic MD01 to avoid rewriting logic. 2. Copying classic ABAP code into S4 without redesign. 3. Ignoring minor result differences assuming they are rounding issues. 4. Treating enhancement redesign as optional. Classic logic cannot survive inside a new execution engine.
Follow-up 1. Can we continue using classic MRP instead of MRP Live?
Answer: temporarily yes, but it defeats S/4HANA performance benefits. Long-term, SAP roadmap prioritizes MRP Live. Avoiding aATP redesign only delays the inevitable architectural alignment.
Follow-up 2. How early should aATP redesign begin?
Answer: before system conversion freeze. Enhancement inventory and compatibility assessment should be performed during readiness phase to avoid post-go-live planning disruptions.
Follow-up 3. Curveball. Why do teams underestimate enhancement migration?
Answer: because enhancements are often considered minor tweaks. In planning systems, even small logic changes cascade into supply chain instability. The technical depth of MDP is frequently underestimated.
Exclusive pro tip.
If you customized MRP and ECC, Assume it must be re-engineered for HANA. MRP Live is not a cosmetic upgrade. It is a database-native engine.
Category 3 Wrap-Up. When planning logic changes the business.
MRP Live and Advanced Planning Shifts are not cosmetic upgrades. They redefine how supply, demand, and prioritization logic execute inside the system. What worked predictably in ECC may behave differently under HANA-driven algorithms. If planning logic is misunderstood, execution instability is inevitable.
Transition from planning engine to shop floor reality.
Planning differences are dangerous, but execution failures are immediate. Once production orders are created, even minor behavioral changes can disrupt confirmations, goods movements, costing, and inventory accuracy. Now we move from algorithmic logic to real shop floor operations.
Category 4 Production Execution Behavior.
This category focuses on how S/4HANA alters execution behavior at the shop floor level. These incidents do not always appear during planning. They surface during confirmations, goods movements, backflushing, costing updates, and operational integration. If planning is architecture, execution is reality.
Scenarios covered in Category 4.
Scenario 63 Backflush timing differences. Primary owner PP functional lead. Supporting MM functional lead. Scenario 64 Confirmation logic changes. Primary owner PP functional lead. Supporting CO functional lead. Scenario 65 Automatic goods movement differences. Primary owner MM functional lead. Supporting PP functional lead. Scenario 66 Order release behavior changes. Primary owner PP functional lead. Supporting SD lead credit check. Scenario 67 Component availability check differences. Primary owner PP functional lead. Supporting SD lead aATP check. Scenario 68 Reservation creation timing differences. Primary owner PP functional lead. Supporting MM functional lead. Scenario 69 Batch determination behavior changes. Primary owner PP functional lead. Supporting MM batch management lead. Scenario 70 Order status flow differences. Primary owner PP functional lead. Supporting shop floor supervisor. Scenario 71 Scrap posting logic changes. Primary owner PP functional lead. Supporting CO functional lead. Scenario 72 Rework order processing differences. Primary owner PP functional lead. Supporting CO functional lead. Scenario 73 Milestone confirmation behavior changes. Primary owner PP functional lead. Supporting CO functional lead. Scenario 74 Collective order processing differences. Primary owner PP functional lead. Supporting CO functional lead. Scenario 75 Order split behavior differences. Primary owner PP functional lead. Supporting CO functional lead. Scenario 76 Capacity leveling results drift. Primary owner PP functional lead. Supporting business planner BPO. Scenario 77 Shop floor integration breaks. Primary owner integration lead PIPO. Supporting PP functional lead.
Scenario 63 Backflush timing differences.
After migration to S/4HANA, components that were previously backflushed at confirmation now post at a different timing event. Inventory levels fluctuate unexpectedly, and shop floor supervisors report mismatches between physical stock and system stock.
Scenario classification.
1. Complexity, medium execution instability. 2. Phase, post-go-live. 3. Primary ownership PP functional lead. 4. Supporting MM functional lead. 5. Business ownership shop floor supervisor.
Diagnostic dashboard, symptoms and evidence.
How this failure manifests on the shop floor and how to catch it early. 1. Symptom component stock reduces earlier or later than expected during confirmations. 2. Red flag inventory variance increases immediately after production confirmations. 3. Business impact warehouse and production teams lose trust in stock visibility. 4. Detection, compare confirmation postings and goods movement timestamps before and after migration. 5. Technical proof. Order confirmation logs show automatic goods movement triggered under revised control key logic. If stock timing changes, the issue is usually configuration logic, not warehouse error.
Why this happens, scenario analysis and root cause.
1. Control keys in routing determine automatic goods movement timing. 2. Backflush indicators at work center or material level were inconsistent. 3. Migration activated stricter confirmation integration logic. 4. Legacy inconsistencies between PP and MM configuration become visible. Execution timing depends entirely on master data discipline.
Why this is a migration-exclusive failure.
1. ECC tolerated loosely aligned backflush indicators. 2. S/4HANA integrates confirmation and inventory postings more tightly. 3. HANA-driven posting logic processes movements faster and in real time. 4. Timing inconsistencies surface only when the planning and execution engines are consolidated. What looks stable in ECC may have been loosely synchronized.
Governance and accountability, RACI model.
In enterprise migration programs, accountable means the person who gets fired if it fails. Responsible means the person who does the work. 1. Accountable PP functional lead for execution configuration architecture. 2. Responsible PP functional lead adjusts control keys and confirmation parameters. 3. Consulted MM functional lead for inventory posting implications. 4. Informed shop floor supervisor for operational validation. Aligned with enterprise governance standards, where functional leads own process logic and inventory integration.
Ownership, who actually fixes it.
Fixing this issue requires aligning routing, material master, and work center configuration. 1. PP functional lead reviews control keys and confirmation parameters in configuration. 2. PP functional lead validates backflush indicators across materials and operations. 3. MM functional lead verifies inventory movement type behavior. 4. Shop floor supervisor validates physical and system stock alignment.
Who gets blamed versus who owns it.
1. Blamed warehouse for incorrect stock handling. 2. Blamed basis for posting timing changes. 3. Actual owner PP functional lead for configuration alignment. 4. Root cause inconsistent backflush and control key governance.
How this is actually fixed. The right way by a role.
1. PP functional lead standardizes control key configuration across plants. 2. PP functional lead aligns backflush indicators at material and routing level. 3. MM functional lead tests movement type postings during confirmation scenarios. 4. Business process owner signs off after end-to-end regression testing.
What not to do, common wrong fixes.
1. Manually adjusting stock without fixing confirmation logic. 2. Disabling automatic goods movement without impact analysis. 3. Changing movement types without routing review. 4. Blaming users without validating configuration. Execution stability depends on structural consistency, not temporary corrections.
Follow-up 1. Why did ECC not expose this earlier?
Answer: ECC processing was less tightly integrated and slower in execution. Timing inconsistencies were masked by manual corrections and batch postings. S/4HANA processes confirmations and goods movements more deterministically.
Follow-up 2. Is this a master data or configuration issue?
Answer: it is both. Control keys drive execution behavior, while backflush indicators in material master enforce inventory movement timing. Both must be aligned.
Follow-up 3. Curveball. Why does this only appear in one plant?
Answer: because configuration and master data governance are often inconsistent across plants. Migration exposes plant-level deviations that were historically unmanaged.
Exclusive pro tip.
Before go-live, simulate confirmations with automatic goods movements in a sandbox and compare timestamps with ECC. Backflush timing issues are easier to prevent than to correct after production begins.
Scenario 64. Confirmation logic changes.
After migrating to S/4HANA, production order confirmations behave differently. Partial confirmations, milestone confirmations, or automatic goods movements trigger unexpected postings, leading to quantity variances and costing discrepancies.
Scenario classification.
1. Complexity, high execution and cost impact. 2. Phase, post-go-live. 3. Primary ownership, PP functional lead. 4. Supporting CO functional lead. 5. Business ownership, shop floor supervisor.
Diagnostic dashboard, symptoms and evidence.
How this failure manifests during shop floor execution and how to detect it early. 1. Symptom: confirmed quantities do not align with expected component consumption. 2. Red flag unexpected variance postings after confirmation. 3. Business impact production KPIs become unreliable and costing reports show inconsistencies. 4. Detection compare confirmation behavior between ECC and S/4HANA using identical test orders. 5. Technical proof confirmation logs show different triggering sequence for goods movement and activity posting. If confirmation changes behavior, the impact extends beyond production into finance.
Why this happens, scenario analysis and root cause.
1. S/4HANA integrates confirmation and costing logic more tightly. 2. Milestone confirmation configuration may differ from ECC settings. 3. Automatic goods movement logic is recalculated under unified posting architecture. 4. Legacy inconsistencies in routing and confirmation parameters become visible. Execution behavior is driven by configuration discipline, not system randomness.
Why this is a migration-exclusive failure.
1. ECC process confirmations with more tolerance for configuration variance. 2. S/4HANA enforces stricter integration between PP and CO modules. 3. HANA processing reveals timing and quantity mismatches instantly. 4. Migration activates unified data models that expose structural misalignment. What worked loosely in ECC becomes tightly controlled in S/4HANA.
Governance and accountability, RACI model.
In enterprise migrations, accountable means the person who gets fired if it fails. Responsible means the person who performs the configuration or correction. 1. Accountable PP functional lead for confirmation architecture integrity. 2. Responsible PP functional lead adjusts confirmation and milestone parameters. 3. Consulted CO functional lead for variance and costing implications. 4. Informed shop floor supervisor for operational validation. Enterprise governance separates architectural accountability from operational execution.
Ownership, who actually fixes it.
Correcting confirmation logic requires configuration alignment across execution and costing. 1. PP functional lead reviews confirmation types and milestone settings. 2. PP functional lead validates routing and work center integration. 3. CO functional lead reconciles variance and activity postings. 4. Shop floor supervisor validates practical usability after changes.
Who gets blamed versus who owns it.
1. Blamed operators for incorrect confirmations. 2. Blamed finance for unexpected variances. 3. Actual owner PP functional lead for confirmation configuration. 4. Root cause legacy confirmation settings exposed by S/4HANA integration.
How this is actually fixed, the right way by a role.
1. PP functional lead standardizes confirmation types across plants. 2. PP functional lead aligns milestone and partial confirmation rules. 3. CO functional lead validates cost postings under controlled test scenarios. 4. Business process owner signs off after reconciliation testing.
What not to do, common wrong fixes.
1. Manually adjusting variances without fixing configuration. 2. Disabling milestone confirmations to avoid discrepancies. 3. Changing costing settings without cross-module validation. 4. Assuming operator error without analyzing logs. Quick fixes in confirmation logic create deeper financial instability.
Follow-up 1. Why do milestone confirmations behave differently?
Answer: S/4HANA recalculates milestone triggers within a more integrated planning and costing model. If configuration was loosely maintained in ECC, migration exposes sequencing and posting logic inconsistencies.
Follow-up 2. Can this impact financial closing?
Answer: yes. Incorrect confirmation logic directly affects WIP and variance postings. Month-end settlement becomes unreliable if confirmation behavior is not stabilized early.
Follow-up 3. Curveball. Why does the issue appear only for certain order types?
Answer: because confirmation parameters are often configured at order type level. Migration exposes inconsistencies between plants or order categories that were historically overlooked.
Exclusive pro tip.
Before go live, simulate full order lifecycle including confirmation, goods movement, and settlement. Confirmation logic is not just a shop floor action, it is a financial trigger.
Scenario 65. Automatic goods movement differences.
After S/4HANA migration, Automatic goods movements triggered during order confirmation behave differently. Components are either not issued correctly or overissued, creating stock inconsistencies and unexpected accounting postings.
Scenario classification.
1. Complexity, high inventory and financial impact. 2. Phase, post-go-live. 3. Primary ownership, functional lead. 4. Supporting PP functional lead. 5. Business ownership, warehouse manager.
Diagnostic dashboard, symptoms and evidence.
How this issue appears during execution and how to detect it early. 1. Symptom, components remain in stock despite order confirmation. 2. Red flag, negative stock or unexpected inventory adjustments after confirmation. 3. Business impact, inventory accuracy drops and financial reconciliation becomes unstable. 4. Detection, compare ECC and S/4HANA automatic goods movement behavior in controlled testing. 5. Technical proof, material document logs show missing or duplicate movement postings. If inventory shifts unexpectedly, automatic movement logic is the first checkpoint.
Why this happens, scenario analysis and root cause.
1. S/4HANA integrates material document and accounting document creation in real time. 2. Backflush indicators may not align with routing or work center configuration. 3. Movement type controls behave differently under unified data architecture. 4. Legacy inconsistencies in BOM or storage location settings surface during execution. Automatic goods movement is configuration-driven, not system randomness.
Why this is a migration-exclusive failure.
1. ECC tolerated timing mismatches between confirmation and goods issue. 2. S/4HANA enforces tighter integration between PP and MM. 3. Real-time posting eliminates historical buffering behavior. 4. Migration activates stricter validation of movement types and stock determination. Loose coupling in ECC becomes strict enforcement in S/4HANA.
Governance and accountability, RACI model.
Accountable means the person who carries final architectural responsibility. Responsible means the person executing configuration corrections. 1. Accountable, functional lead for inventory movement integrity. 2. Responsible, functional lead adjusts movement type and backflush configuration. 3. Consulted, PP functional lead for routing and confirmation alignment. 4. Informed, warehouse manager for operational validation. Clear separation of accountability and execution. Ensures stable inventory governance.
Ownership, who actually fixes it.
Resolving automatic goods movement issues requires cross-module validation. 1. functional lead reviews movement type configuration and stock determination rules. 2. PP functional lead validates backflush indicators in routing and work centers. 3. functional lead ensures valuation and posting logic is consistent. 4. Warehouse manager confirms physical stock alignment after correction.
Who gets blamed versus who owns it.
1. Blamed warehouse team for incorrect stock handling. 2. Blamed operators for wrong confirmation entries. 3. Actual owner, functional lead for movement configuration. 4. Root cause, configuration gaps exposed by S/4HANA real-time integration.
How this is actually fixed, the right way by a role.
1. functional lead harmonizes movement type and account determination settings. 2. PP functional lead aligns backflush logic in routing and production versions. 3. functional lead validates inventory and financial postings in regression tests. 4. Business process owner approves end-to-end goods issue simulation results.
What not to do, common wrong fixes.
1. Manually adjusting stock without fixing configuration. 2. Changing movement types randomly to bypass errors. 3. Ignoring valuation postings during testing. 4. Blaming operators without analyzing routing settings. Stock corrections without architectural fixes only postpone the problem.
Follow-up 1. Why does backflush behave inconsistently across plants?
Answer: backflush logic is often configured differently at plant or work center level. Migration highlights these differences because S/4HANA enforces consistent movement validation and posting integration.
Follow-up 2. Can this impact financial statements?
Answer: yes. Automatic goods movement directly affects inventory valuation and cost of goods manufactured. Incorrect configuration leads to accounting imbalances and reconciliation challenges.
Follow-up 3, curveball. Why does the issue appear only during high production volume?
Answer: under heavy load, timing and sequence of postings become critical. S/4HANA processes movements in real time, exposing concurrency and configuration inconsistencies that were previously buffered in ECC.
Exclusive pro tip.
Always simulate automatic goods movement with real production quantities before go live. Inventory accuracy is a direct reflection of configuration discipline.
Scenario 66. Order release behavior changes.
After migration to S/4HANA, production order release behaves differently. Orders that were automatically released in ECC now remain in created status or are blocked due to integration checks such as credit exposure or availability validation.
Scenario classification.
1. Complexity high execution blocking. 2. Phase post-go-live. 3. Primary ownership PP functional lead. 4. Supporting SD lead credit check. 5. Business ownership production manager BPO.
Diagnostic dashboard, symptoms and evidence.
How this issue manifests during execution and how to identify it early. 1. Symptom: production orders remain in created status and cannot be released. 2. Red flag credit or availability blocks appear during order release. 3. Business impact: shop floor scheduling is disrupted and production start dates slip. 4. Detection: compare release logs and credit integration settings between ECC and S/4HANA. 5. Technical proof: system logs show release blocked by integration checks not previously enforced. If order release suddenly fails, integration enforcement is usually the trigger.
Why this happens, scenario analysis and root cause.
1. S/4HANA introduces tighter integration between production and sales credit management. 2. Availability and compliance checks are enforced earlier in the process. 3. Custom release user exits may no longer trigger in the same sequence. 4. Configuration assumptions carried from ECC do not align with new validation logic. Order release is no longer an isolated PP event. It is cross-module governed.
Why this is a migration-exclusive failure.
1. ECC allowed release before certain cross-module validations were complete. 2. S/4HANA enforces integrated checks in real time. 3. Migration activates embedded credit and availability logic automatically. 4. Legacy release customizations may not align with new processing sequences. What was loosely connected in ECC becomes strictly validated in S/4HANA.
Governance and accountability, RACI model.
Accountable means the person who carries final architectural responsibility. Responsible means the person executing configuration and process corrections. 1. Accountable PP functional lead for production order control design. 2. Responsible PP functional lead adjusts release strategy and control parameters. 3. Consulted SD lead for credit management integration impact. 4. Informed production manager for operational execution alignment. Clear accountability prevents cross-module blame shifting during go-live stabilization.
Ownership: who actually fixes it.
Correcting release behavior requires both configuration and integration validation. 1. PP functional lead reviews order type and release control configuration. 2. SD lead validates credit check and availability control integration. 3. PP functional lead tests release scenarios across plants. 4. Production manager confirms release timing aligns with shop floor scheduling.
Who gets blamed versus who owns it.
1. Blamed shop floor supervisors for not releasing orders. 2. Blamed SAP system for being overly restrictive. 3. Actual owner PP functional lead for release configuration governance. 4. Root cause integration enforcement activated by S/4HANA architecture.
How this is actually fixed. The right way by a role.
1. PP functional lead aligns release strategy with S/4HANA integration rules. 2. SD lead adjusts credit management settings where necessary. 3. PP functional lead performs regression testing on release scenarios. 4. Business process owner validates release process through pilot runs.
What not to do, common wrong fixes.
1. Bypassing credit checks without analyzing root cause. 2. Manually forcing release in production. 3. Ignoring integration logs during troubleshooting. 4. blaming user behavior instead of configuration. Forced releases hide governance gaps that resurface during audits.
Follow-up 1. Why did this not occur in ECC?
Answer: ECC allowed certain validations to occur later in the process or be bypassed by custom enhancements. S/4HANA integrates and enforces checks earlier, exposing configuration gaps immediately.
Follow-up 2. Can we disable credit checks for production orders?
Answer: technically possible but risky. Disabling integration checks can create financial and compliance exposure. Proper alignment between PP and SD is a more sustainable solution.
Follow-up 3. Curveball. Why do only some plants experience release blocks?
Answer: plant-specific configuration differences, credit exposure rules, or availability control settings may vary. Migration highlights these inconsistencies under unified validation logic.
Exclusive pro tip.
Test production order release with full integration scenarios including credit and availability before go live. Release logic is now enterprise governed, not plant isolated.
Scenario 67. Component availability check differences.
After ECC to S/4HANA migration, component availability checks during production order processing behave differently. Materials that previously passed availability validation now trigger shortages, confirmations are blocked, or orders cannot proceed due to stricter checking logic.
Scenario classification.
1. Complexity high execution disruption. 2. Phase post-go-live. 3. Primary ownership PP functional lead. 4. Supporting SD lead aATP check. 5. Business ownership production manager BPO.
Diagnostic dashboard, symptoms and evidence.
How the issue surfaces during execution and how to identify it early. 1. Symptom: production orders show component shortages despite stock being available. 2. Red flag: availability control messages differ between ECC and S/4HANA. 3. Business impact: production delays and emergency material movements increase. 4. Detection: compare availability control settings and checking rules before and after migration. 5. Technical proof: system logs show stricter availability check results under S/4HANA logic. If availability suddenly becomes stricter, configuration alignment is the likely cause.
Why this happens, scenario analysis and root cause.
1. S/4HANA integrates availability logic more tightly with advanced aATP functionality. 2. Checking rules and scope of check may default differently after migration. 3. Custom availability enhancements from ECC may no longer execute in the same sequence. 4. Integration between PP and SD planning logic is enforced more consistently. Availability logic is no longer loosely configurable. It is systematically enforced.
Why this is a migration-exclusive failure.
1. ECC allowed flexibility in availability checking sequences. 2. S/4HANA activates advanced aATP and unified checking frameworks. 3. Migration may automatically enable integration points not fully tested. 4. Differences surface only when real-time order processing begins. The logic did not change randomly. The enforcement level did.
Governance and accountability, RACI model.
Accountable means the person who owns the architectural integrity. Responsible means the person executing configuration corrections. 1. Accountable: PP functional lead for production availability design. 2. Responsible: PP functional lead adjusts checking rules and scope of check. 3. Consulted: SD functional lead for advanced aATP integration alignment. 4. Informed: production manager for operational impact validation. Clear accountability ensures availability logic is aligned across modules.
Ownership: who actually fixes it.
Resolving availability differences requires cross-module configuration review. 1. PP functional lead reviews and aligns availability control settings. 2. SD functional lead validates advanced aATP integration impact. 3. PP functional lead performs regression testing across plants. 4. Production manager confirms material staging aligns with execution needs.
Who gets blamed versus who owns it.
1. Blamed: warehouse team for not staging components. 2. Blamed: system for falsely reporting shortages. 3. Actual owner: PP functional lead for availability configuration alignment. 4. Root cause: stricter availability enforcement under S/4HANA.
How this is actually fixed. the right way by a role.
1. PP functional lead reviews and standardizes scope of check configuration. 2. SD functional lead validates advanced aATP rule alignment. 3. PP functional lead conducts end-to-end availability regression tests. 4. Business process owner validates component staging against real scenarios.
What not to do, common wrong fixes.
1. Disabling availability checks entirely. 2. Manually adjusting stock to bypass system messages. 3. Ignoring integration between production and sales logic. 4. Treating availability issues as warehouse errors. Shortcuts in availability logic compromise planning integrity.
Follow-up 1. Why do shortages appear even when stock exists?
Answer: because availability logic may consider reservations, sales commitments, or safety stock differently in S/4HANA. The stock may be physically present but not considered available under stricter checking rules.
Follow-up 2. Can we revert to ECC-style availability logic?
Answer: not entirely. While configuration can be adjusted, S/4HANA is built around unified availability control. Proper alignment rather than rollback is the sustainable approach.
Follow-up 3. Curveball. Why do only certain materials trigger this issue?
Answer: material-specific checking groups, plant settings, or ATP integration rules may vary. Migration exposes inconsistencies that were tolerated in ECC but strictly enforced in S/4HANA.
Exclusive pro tip.
Always simulate production order availability checks with real demand and reservation data before go live. Availability logic in S/4HANA is integrated across modules and cannot be treated as a standalone PP setting.
Scenario 68. Reservation creation timing differences.
After ECC to S/4HANA conversion, reservations for components are created at different stages of the production order lifecycle. In some cases, reservations are delayed. In others, they are generated earlier than expected. This timing shift creates confusion in inventory visibility and staging processes.
Scenario classification.
1. Complexity, medium to high inventory visibility impact. 2. Phase, post-go-live. 3. Primary ownership, PP functional lead. 4. Supporting MM functional lead. 5. Business ownership, warehouse manager.
Diagnostic dashboard, symptoms and evidence.
How reservation timing differences appear operationally and how to detect them early. 1. Symptom: warehouse reports missing or unexpected reservations during order release. 2. Red flag: reservations are created only at release instead of creation or vice versa. 3. Business impact: material staging becomes inconsistent and production start is delayed. 4. Detection: compare order type settings for reservation creation timing before and after migration. 5. Technical proof: order logs show reservation generation at different status transitions than ECC. Reservation timing controls inventory transparency across the plant.
Why this happens, scenario analysis and root cause.
1. Order type configuration may default differently during migration. 2. S/4HANA enforces stricter status-driven logic for reservation generation. 3. Custom user exits influencing reservation timing may not trigger identically. 4. Integration with inventory management is more tightly synchronized. Reservation timing is controlled by configuration, not randomness.
Why this is a migration-exclusive failure.
1. ECC tolerated loosely aligned reservation triggers. 2. S/4HANA aligns reservation logic with real-time inventory updates. 3. Migration may reset order type parameters to standard behavior. 4. Timing differences only surface during real operational cycles. What changed is enforcement of process sequence.
Governance and accountability, RACI model.
Accountable means the person who answers for incorrect process design. Responsible means the person executing configuration correction. 1. Accountable PP functional lead for production order configuration design. 2. Responsible PP functional lead adjusts reservation timing parameters. 3. Consulted MM functional lead for inventory impact validation. 4. Informed warehouse manager for operational alignment. Clear governance prevents inventory confusion across departments.
Ownership, who actually fixes it.
Reservation timing must be aligned with business staging strategy. 1. PP functional lead reviews and corrects order type settings. 2. MM Functional Lead validates reservation integration with stock management. 3. PP Functional Lead conducts controlled order lifecycle testing. 4. Warehouse Manager validates staging and picking consistency.
Who gets blamed versus who owns it?
1. Blamed warehouse for incorrect staging. 2. Blamed system for unpredictable reservations. 3. Actual owner PP Functional Lead for order type configuration. 4. Root cause reservation trigger settings changed or enforced differently.
How this is actually fixed, the right way by a role.
1. PP Functional Lead realigns reservation creation timing to match business process. 2. MM Functional Lead validates stock availability and reservation consistency. 3. PP Functional Lead executes regression tests across multiple order types. 4. Business Process Owner approves final lifecycle sequence.
What not to do, common wrong fixes.
1. Manually deleting reservations to bypass confusion. 2. Blaming warehouse staff without reviewing configuration. 3. Ignoring order type parameter differences across plants. 4. Applying inconsistent fixes without lifecycle testing. Reservation timing errors compound quickly across plants.
Follow-up 1. Why do some order types behave differently?
Answer: because reservation timing is controlled at the order type level. During migration, certain order types may revert to standard settings. Differences appear only when specific types are processed.
Follow-up 2. Can this affect inventory valuation?
Answer: indirectly yes. Incorrect reservation timing can distort available stock figures, leading to incorrect planning or emergency procurement, which ultimately impacts valuation flows.
Follow-up 3. Curveball. Why was this not visible during testing?
Answer: because testing often focuses on order creation rather than full lifecycle execution. Reservation timing differences usually appear during release, confirmation, or staging activities.
Exclusive pro tip.
Always validate reservation behavior across order creation, release, confirmation, and closure phases. Reservation timing defines how inventory is seen by planning and warehouse simultaneously.
Scenario 69. Batch determination behavior changes.
After ECC to S/4HANA conversion, batch determination during production, order release, or goods issue behaves differently. Certain batches that were previously selected automatically are no longer proposed, or unexpected batches are picked. This creates operational confusion and compliance risk in batch-managed environments.
Scenario classification.
1. Complexity, high compliance and execution risk. 2. Phase, post-go-live. 3. Primary ownership, PP functional lead. 4. Supporting MM functional lead. 5. Business ownership, quality manager.
Diagnostic dashboard, symptoms and evidence.
How batch determination inconsistencies appear and how to detect them early. 1. Symptom: production orders select incorrect or no batches during component issue. 2. Red flag: strategy records exist but are not triggered consistently. 3. Business impact: incorrect material consumption, quality deviations, and audit findings. 4. Detection: compare batch search strategies and classification assignments before and after migration. 5. Technical proof: batch determination analysis shows changed access sequence or condition record behavior. Batch logic is sensitive to classification and strategy configuration.
Why this happens, scenario analysis and root cause.
1. Batch search strategy configuration may not fully align with S/4HANA logic. 2. Classification data may be incomplete or inconsistently migrated. 3. Access sequence behavior can differ under embedded real-time processing. 4. Custom enhancements influencing batch selection may not trigger identically. Batch determination depends on master data integrity and strategy consistency.
Why this is a migration-exclusive failure.
1. ECC allowed loosely aligned classification and batch strategy combinations. 2. S/4HANA enforces tighter integration between batch management and real-time stock updates. 3. Migration activates stricter validation of class characteristics. 4. Differences only appear when actual goods issue is performed. The migration reveals gaps that ECC tolerated silently.
Governance and accountability, RACI model.
Accountable means the person who answers if batch selection violates process rules. Responsible means the person configuring and correcting the logic. 1. Accountable PP functional lead for production batch strategy design. 2. Responsible functional lead for batch search strategy configuration. 3. Consulted quality manager for compliance and traceability validation. 4. Informed warehouse supervisor for execution alignment. Clear RAC prevents compliance exposure in regulated industries.
Ownership, who actually fixes it.
Batch determination issues require coordinated functional correction. 1. PP functional lead reviews production order and component batch determination settings. 2. functional lead corrects batch search strategies and classification consistency. 3. Quality manager validates characteristic-based selection rules. 4. Master data team ensures class assignments are complete and accurate.
Who gets blamed versus who owns it.
1. Blamed warehouse for incorrect batch picking. 2. Blamed system for random batch proposals. 3. Actual owner PP and functional leads for batch configuration alignment. 4. Root cause, strategy, or classification gaps exposed by S/4HANA enforcement.
How this is actually fixed, the right way by a role.
1. PP functional lead aligns batch determination settings at order level. 2. functional lead validates and corrects batch search strategies and condition records. 3. Quality manager reviews compliance requirements and characteristic dependencies. 4. Master data team performs structured classification cleanup.
What not to do, common wrong fixes.
1. Manually overriding batch selection without root cause analysis. 2. Changing search strategies without testing cross-plant impact. 3. Ignoring classification inconsistencies during migration. 4. Assuming it is a warehouse execution error. Batch errors escalate quickly into compliance findings.
Follow-up 1. Why do only certain materials show batch issues?
Answer: because only materials with specific classification or strategy conditions are affected. If characteristics are incomplete or inconsistent, batch selection fails selectively rather than globally.
Follow-up 2. Can this impact audit compliance?
Answer: yes. Incorrect batch determination can violate traceability or expiration rules. In regulated industries, this becomes a compliance exposure rather than a simple configuration issue.
Follow-up 3. Curveball. Why was this not caught during unit testing?
Answer: unit testing often uses limited data sets with ideal classification. Real production data with diverse batch characteristics exposes gaps only during live goods issue execution.
Exclusive pro tip.
Always validate batch determination with real production scenarios and historical classification data. Strategy consistency is more important than technical activation.
Scenario 70. Production order status flow differences.
After ECC to S/4HANA conversion, production order status transitions such as created, released, confirmed, technically completed, and closed behave differently. Certain automatic status updates no longer trigger as expected, and orders remain stuck in intermediate states, impacting execution and financial settlement.
Scenario classification.
1. Complexity, high execution and financial impact. 2. Phase post-go-live. 3. Primary ownership PP functional lead. 4. Supporting shop floor supervisor. 5. Business ownership production manager.
Diagnostic dashboard, symptoms and evidence.
How order status inconsistencies manifest and how to detect them early. 1. Symptom: orders remain in release status despite confirmations being completed. 2. Red flag: technically completed status does not trigger automatic settlement preparation. 3. Business impact: orders remain financially open and distort period-end reporting. 4. Detection: compare status update logic in test and production using status overview analysis. 5. Technical proof: system status and user status logs show missing or altered update triggers. Order status is not cosmetic. It controls execution and accounting logic.
Why this happens, scenario analysis and root cause.
1. Status management logic may have been enhanced in ECC through custom code. 2. Certain automatic status transitions rely on background jobs or event triggers. 3. S/4HANA may enforce stricter validation before allowing status progression. 4. Custom exits influencing status updates may no longer trigger identically. Status flow depends on both configuration and technical enhancement behavior.
Why this is a migration-exclusive failure.
1. ECC tolerated loosely structured status dependencies. 2. S/4HANA introduces real-time validation and tighter integration with finance. 3. Enhancement logic may be impacted during SPDD or SBAU adjustments. 4. Differences only surface under real execution volume. Migration activates stricter governance over order lifecycle.
Governance and accountability, RACI model.
Accountable means the person who answers when orders remain financially open. Responsible means the person correcting configuration or enhancement logic. 1. Accountable PP functional lead for order lifecycle design. 2. Responsible ABAP lead if custom status logic requires correction. 3. Consulted CO functional lead for financial impact validation. 4. Informed production manager for operational consequences. Clear accountability prevents execution delays and settlement discrepancies.
Ownership, who actually fixes it.
Correcting status flow requires both functional and technical validation. 1. PP functional lead reviews status profile and business transaction configuration. 2. ABAP lead analyzes enhancement logic affecting automatic status updates. 3. CO functional lead validates that settlement prerequisites are correctly triggered. 4. Production manager validates lifecycle alignment with shop floor reality.
Who gets blamed versus who owns it.
1. Blamed finance for open orders at month end. 2. Blamed shop floor for not completing confirmations. 3. Actual owner PP functional lead and ABAP lead for lifecycle logic. 4. Root cause, enhancement and configuration drift exposed by S/4HANA.
How this is actually fixed, the right way by a role.
1. PP functional lead realigns status profile configuration with S/4HANA standards. 2. ABAP lead corrects or replaces legacy status management enhancements. 3. CO functional lead ensures financial closure prerequisites are triggered correctly. 4. Business process owner validates end-to-end order lifecycle testing.
What not to do, common wrong fixes.
1. Manually updating order status en masse without analyzing root cause. 2. Ignoring settlement impact during technical closure. 3. Disabling user status checks to accelerate order flow. 4. Blaming production execution without reviewing configuration. Status manipulation without governance creates financial instability.
Follow-up 1. Why do some orders close correctly while others do not?
Answer: because status transitions may depend on specific confirmations, goods movements, or settlement conditions. Orders with complete execution data behave correctly, while incomplete or custom-enhanced orders expose gaps.
Follow-up 2. Can this impact month-end close?
Answer: yes. Orders that remain technically open prevent correct WIP calculation and settlement. This directly affects financial reporting accuracy and audit validation.
Follow-up 3. Curveball. Why did this not appear during integration testing?
Answer: because integration testing typically covers nominal flows. Real production data and edge case lifecycle transitions only surface under operational volume after go live.
Exclusive pro tip.
Never treat production order status as a cosmetic field. It is the backbone of both operational execution and financial integrity in S/4HANA.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving. Interview questions and answers where almost 80% of the people are failing to answer. System design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Scenario 71. Scrap posting logic changes.
After ECC to S/4HANA migration, scrap postings during confirmations behave differently. Scrap quantities may post with different movement types, valuation logic, or cost allocation impact. Finance begins noticing unexpected variance shifts, and production supervisors report inconsistent scrap accounting.
Scenario classification.
1. Complexity, high costing and inventory impact. 2. Phase post-go-live. 3. Primary ownership, PP functional lead. 4. Supporting CO functional lead. 5. Business ownership, production manager.
Diagnostic dashboard, symptoms and evidence.
How scrap posting inconsistencies appear and how to detect them early. 1. Symptoms, scrap quantities post but variance values differ from ECC historical averages. 2. Red flag, cost component split shows abnormal scrap allocation. 3. Business impact, production order variances increase unexpectedly and distort profitability analysis. 4. Detection, compare confirmation scrap postings before and after migration using variance reports. 5. Technical proof, movement type configuration and account determination show valuation rule differences. Scrap is not just quantity, it is cost logic embedded in execution.
Why this happens, scenario analysis and root cause.
1. S/4HANA enforces tighter integration between scrap posting and material ledger valuation. 2. Account determination logic may have changed during conversion. 3. Confirmation parameters controlling scrap type behavior may differ from ECC defaults. 4. Cost component mapping and settlement structure may have been adjusted. Scrap behavior is influenced by configuration and costing integration.
Why this is a migration-exclusive failure.
1. ECC and S/4HANA treat valuation and material ledger integration differently. 2. Material ledger mandatory activation alters scrap cost flow. 3. Historical scrap percentages hide configuration weaknesses. 4. Migration activates stricter financial reconciliation rules. The system did not become wrong. The valuation engine became stricter.
Governance and accountability, RACI model.
Accountable means the person who answers for variance distortion. Responsible means the person correcting configuration or costing logic. 1. Accountable, PP functional lead for scrap execution configuration. 2. Responsible, CO functional lead for variance and valuation alignment. 3. Consulted, MM functional lead for movement type impact. 4. Informed, production business process owner for operational validation. Clear accountability prevents financial surprises during month end.
Ownership, who actually fixes it.
Correcting scrap behavior requires alignment between execution and costing logic. 1. PP functional lead validates confirmation parameters and scrap configuration. 2. CO functional lead recalibrates variance categories and cost component mapping. 3. MM functional lead reviews movement types and account determination. 4. Production manager confirms shop floor posting accuracy.
Who gets blamed versus who owns it.
1. Blamed shop floor for excessive scrap. 2. Blamed finance for incorrect variance. 3. Actual owner PP and CO functional leads for configuration alignment. 4. Root cause valuation logic shifts under S/4HANA enforcement.
How this is actually fixed, the right way by a role.
1. PP functional lead standardizes scrap handling parameters and confirmations. 2. CO functional lead aligns variance categories and settlement profiles. 3. MM functional lead validates posting keys and movement logic. 4. Business process owner validates results through controlled variance testing.
What not to do, common wrong fixes.
1. Adjusting scrap percentages manually to hide variance. 2. Reversing postings without analyzing cost impact. 3. Blaming production efficiency without reviewing configuration. 4. Ignoring material ledger influence on scrap valuation. Scrap manipulation without governance creates audit exposure.
Follow-up 1. Why do scrap variances spike immediately after go live?
Answer: because material ledger integration recalculates valuation logic in real time. Historical ECC behavior may have masked minor inconsistencies. S/4HANA exposes those differences immediately.
Follow-up 2. Can this impact profitability reporting?
Answer: yes. Scrap valuation feeds directly into production variance and cost of goods sold. Even small configuration differences can distort product margin analysis.
Follow-up 3. Curveball. Why was this not caught in testing?
Answer: testing often focuses on quantity posting accuracy. Cost component and variance reconciliation may not be deeply validated until the first financial close.
Exclusive pro tip.
If scrap behavior changes after migration, investigate valuation integration before questioning operational efficiency.
Scenario 72. Rework order processing differences.
After ECC to S/4HANA migration, rework orders behave differently in terms of cost collection, component consumption, and settlement. Production teams notice unexpected postings, while finance observes abnormal variance categories linked to rework activities.
Scenario classification.
1. Complexity, high execution and costing sensitive. 2. Phase, post-go-live. 3. Primary ownership, PP functional lead. 4. Supporting CO functional lead. 5. Business ownership, production manager.
Diagnostic dashboard, symptoms and evidence.
How rework inconsistencies appear and how to identify them early. 1. Symptom: rework orders collect costs but do not settle as expected. 2. Red flag: variance reports show unexpected rework cost distribution. 3. Business impact: product profitability appears distorted due to incorrect rework allocation. 4. Detection: compare ECC and S/4HANA rework order settlement profiles. 5. Technical proof: settlement rules and order type configuration differ after conversion. Rework logic touches both execution and financial accuracy.
Why this happens, scenario analysis and root cause.
1. Rework order types may have different settlement profiles in S/4HANA. 2. Cost element structures changed under material ledger enforcement. 3. Integration between PP and CO settlement logic became stricter. 4. Historical ECC configuration inconsistencies surface under S/4 validation. Rework orders are cost collectors first, production tools second.
Why this is a migration-exclusive failure.
1. ECC allowed flexible settlement behavior for rework. 2. S/4HANA enforces harmonized cost object structures. 3. Material ledger mandatory integration alters valuation flow. 4. Conversion exposes mismatched order type configuration. The architecture enforces discipline that ECC tolerated.
Governance and accountability, RACI model.
Accountable means the person who answers for incorrect cost allocation. Responsible means the person executing configuration or settlement correction. 1. Accountable PP functional lead for order type and execution configuration. 2. Responsible CO functional lead for settlement and variance structure alignment. 3. Consulted ABAP lead if custom settlement logic exists. 4. Informed production business process owner for operational impact. Clear accountability prevents recurring rework cost distortions.
Ownership, who actually fixes it.
Rework stability requires alignment between order types and settlement logic. 1. PP functional lead reviews and harmonizes rework order type configuration. 2. CO functional lead validates settlement profiles and cost flow. 3. ABAP lead checks for custom logic affecting rework settlement. 4. Production manager validates operational execution consistency.
Who gets blamed versus who owns it.
1. Blamed production for high rework cost. 2. Blamed finance for settlement errors. 3. Actual owner PP and CO functional leads for configuration alignment. 4. Root cause, order type, and settlement profile mismatch post-conversion.
How this is actually fixed, the right way by a role.
1. PP functional lead standardizes rework order types across plants. 2. CO functional lead redefines settlement structure and variance categories. 3. ABAP lead validates custom enhancement compatibility. 4. Business process owner confirms financial and operational alignment.
What not to do, common wrong fixes.
1. Manually adjusting settlement postings without root cause analysis. 2. Closing rework orders prematurely to hide variance. 3. Blaming shop floor inefficiency without reviewing configuration. 4. Ignoring material ledger integration impact. Rework misalignment is a configuration issue, not a productivity issue.
Follow-up 1. Why does rework cost increase after migration?
Answer: because S/4HANA enforces more transparent variance allocation under material ledger. Costs previously absorbed or hidden in ECC become visible through stricter settlement rules.
Follow-up 2. Can this affect audit compliance?
Answer: yes. Incorrect settlement allocation may distort financial reporting and profitability statements. Auditors may question unexplained rework variance spikes.
Follow-up 3. Curveball. Why was rework stable in ECC but unstable in S4HANA?
Answer: ECC tolerated flexible or inconsistent configuration across plants. S4HANA harmonizes cost object structures and exposes differences that were previously hidden.
Exclusive pro tip.
If rework costs spike after migration, investigate settlement configuration before questioning operational efficiency.
Scenario 73. Milestone confirmation behavior changes.
After ECC to S4HANA conversion, milestone confirmations trigger different backflush and goods movement behavior. Production orders that previously consumed components smoothly now post unexpected quantities or timing differences, impacting both inventory and cost capture.
Scenario classification.
1. Complexity, high inventory and costing sensitive. 2. Phase, post-go-live. 3. Primary ownership, PP functional lead. 4. Supporting CO functional lead. 5. Business ownership, shop floor supervisor.
Diagnostic dashboard, symptoms and evidence.
How milestone confirmation drift appears and how to detect it early. 1. Symptom: component consumption post earlier or later than expected. 2. Red flag: inventory differences appear immediately after confirmation. 3. Business impact: cost variance spikes due to misaligned backflush timing. 4. Detection: compare milestone confirmation parameters between ECC and S4HANA. 5. Technical proof: operation control key and milestone indicator configuration differ post-conversion. Milestone logic controls both material and cost flow timing.
Why this happens, scenario analysis and root cause.
1. Control keys and milestone indicators were inconsistently maintained in ECC. 2. S4HANA enforces stricter integration between confirmation and goods movement. 3. Material ledger mandatory activation affects posting sequence. 4. Conversion harmonizes configuration that was previously plant-specific. Confirmation is not just operational, it is financial.
Why this is a migration-exclusive failure.
1. ECC allowed flexible milestone posting combinations. 2. S4HANA tightens confirmation integration logic. 3. Backflush validation is more deterministic in S4HANA. 4. Legacy inconsistencies surface only under new posting architecture. What was tolerated flexibility becomes enforced synchronization.
Governance and accountability, RACI model.
Accountable means the person responsible for confirmation architecture. Responsible means the person executing configuration corrections. 1. Accountable PP functional lead for confirmation and control key configuration. 2. Responsible PP functional lead executing milestone configuration corrections. 3. Consulted CO functional lead for cost flow validation. 4. Informed shop floor supervisor for operational timing impact. Milestone misalignment impacts both inventory and profitability.
Ownership: who actually fixes it.
Stabilizing milestone behavior requires configuration discipline. 1. PP functional lead reviews control keys and milestone indicators. 2. CO functional lead validates cost impact after confirmation adjustments. 3. Shop floor supervisor tests confirmation flow in controlled scenarios. 4. Basis lead monitors posting performance if runtime spikes occur.
Who gets blamed versus who owns it?
1. Blamed production for incorrect confirmations. 2. Blamed inventory for stock discrepancies. 3. Actual owner PP functional lead for configuration alignment. 4. Root cause inconsistent milestone control configuration post-migration.
How this is actually fixed, the right way by a role.
1. PP functional lead harmonizes milestone and backflush configuration. 2. CO functional lead revalidates variance categories impacted by timing shifts. 3. Shop floor supervisor executes regression testing of confirmation scenarios. 4. Basis lead monitors performance during high-volume confirmations.
What not to do, common wrong fixes.
1. Manually adjusting stock differences without correcting control keys. 2. Changing confirmation quantities to compensate for timing errors. 3. Disabling milestone logic entirely without architectural review. 4. Ignoring cost impact of confirmation timing. Milestone issues are configuration-driven, not user-driven.
Follow-up 1. Why does milestone confirmation affect costing?
Answer: milestone confirmations trigger automatic goods movements and activity postings. Any timing or configuration difference directly impacts cost capture and variance reporting.
Follow-up 2. Is this purely a PP issue?
Answer: no. It directly impacts inventory valuation and cost allocation. Coordination between PP and CO is essential for stable confirmation logic.
Follow-up 3. Curveball. Why did it work for years in ECC?
Answer: ECC tolerated flexible control key usage across plants. S/4HANA harmonizes and enforces configuration standards, exposing inconsistent setups.
Exclusive pro tip.
If inventory and cost drift begins immediately after confirmations, audit milestone and control key configuration before blaming operators.
Scenario 74. Collective order processing differences.
After ECC to S/4HANA migration, collective orders behave differently in terms of automatic order creation, settlement flow, and component staging. What previously functioned as a tightly linked parent-child structure may now produce unexpected order splits or settlement inconsistencies.
Scenario classification.
1. Complexity, high structural production impact. 2. Phase, post-go-live. 3. Primary ownership, PP functional lead. 4. Supporting CO functional lead. 5. Business ownership, production manager, BPO.
Diagnostic dashboard, symptoms and evidence.
How collective order drift appears and how to detect it early. 1. Symptom suborders are not automatically linked or settled as expected. 2. Red flag settlement errors appear during period-end processing. 3. Business impact work-in-process valuation becomes inconsistent. 4. Detection, validate collective order indicators in routing and material master. 5. Technical proof, order type configuration differs from ECC structure. Collective orders are configuration-driven chains, not simple order links.
Why this happens, scenario analysis and root cause.
1. Collective order indicators were inconsistently maintained in ECC. 2. S/4HANA enforces stricter order settlement and integration logic. 3. Material ledger mandatory activation impacts internal order valuation. 4. Routing structure differences surface after migration harmonization. Order hierarchy misalignment becomes visible only under S4 enforcement.
Why this is a migration-exclusive failure.
1. ECC allowed more flexible collective order structures. 2. S/4HANA tightens settlement and integration consistency. 3. Migration consolidates order type settings across plants. 4. Legacy configuration inconsistencies are exposed during structural validation. The migration standardizes logic that ECC tolerated.
Governance and accountability, RACI model.
Accountable means the person who owns the production architecture. Responsible means the person who executes configuration corrections. 1. Accountable PP functional lead for collective order configuration design. 2. Responsible PP functional lead executing routing and order type corrections. 3. Consulted CO functional lead for settlement and WIP validation. 4. Informed production manager for operational impact review. Collective order stability requires architectural ownership.
Ownership, who actually fixes it?
Fixing collective order issues requires structural configuration alignment. 1. PP functional lead reviews collective order indicators and routing design. 2. CO functional lead validates settlement rule and WIP behavior. 3. Production manager tests multi-level order execution scenarios. 4. Basis lead monitors performance if order hierarchy processing slows.
Who gets blamed versus who owns it?
1. Blamed finance for incorrect settlement postings. 2. Blamed system for breaking automatic order links. 3. Actual owner PP functional lead for routing and order type governance. 4. Root cause structural configuration inconsistencies carried from ECC.
How this is actually fixed, the right way by a role.
1. PP functional lead standardizes collective order indicators across plants. 2. CO functional lead revalidates settlement profiles and cost flow. 3. Production manager executes regression testing of hierarchical orders. 4. Basis lead reviews runtime behavior during high-volume order creation.
What not to do, common wrong fixes.
1. Manually adjusting settlement documents without fixing order structure. 2. Disabling collective order usage without business analysis. 3. Changing routing randomly to force link recreation. 4. Ignoring WIP impact during testing. Order hierarchy problems require architectural correction.
Follow-up 1. Why do collective orders impact WIP so heavily?
Answer: collective orders consolidate cost and material flows across parent and child structures. Any misalignment affects settlement timing and valuation accuracy.
Follow-up 2. Is this mainly a costing issue?
Answer: no. It starts with routing and order type configuration in PP. Costing only reflects the structural logic defined in production configuration.
Follow-up 3. Curveball. Why does it pass initial testing?
Answer: small volume tests may not trigger full hierarchical settlement scenarios. Issues typically surface during month-end processing with real production data.
Exclusive pro tip.
Always simulate full settlement cycles for collective orders before go live. Structural issues rarely appear during basic functional testing.
Scenario 75. Order split behavior differences.
After ECC to S/4HANA migration, production order split behavior changes unexpectedly. Partial quantities that previously created clean child orders may now carry different settlement rules, capacity allocations, or material document flows.
Scenario classification.
1. Complexity, high execution and cost impact. 2. Phase post-go-live. 3. Primary ownership PP functional lead. 4. Supporting CO functional lead. 5. Business ownership production manager BPO.
Diagnostic dashboard, symptoms and evidence.
How order split instability appears and how to detect it early. 1. Symptom: child orders inherit unexpected settlement rules or cost collectors. 2. Red flag: variance calculation differs between parent and split orders. 3. Business impact: cost visibility becomes fragmented across multiple order numbers. 4. Detection: validate order type split configuration and settlement profile alignment. 5. Technical proof: settlement rule tables show inconsistent inheritance logic. Order splits are configuration-driven, not purely transactional.
Why this happens, scenario analysis and root cause.
1. Order type control parameters differ between ECC and S/4HANA templates. 2. Settlement profile inheritance logic changes under mandatory material ledger. 3. Capacity allocation logic recalculates during split execution. 4. Legacy customizing was never harmonized across plants. S/4HANA enforces structured financial and capacity consistency.
Why this is a migration-exclusive failure.
1. ECC allowed flexible order inheritance behavior. 2. S/4HANA standardizes settlement and valuation flows. 3. Material ledger mandatory activation alters cost propagation. 4. Configuration inconsistencies surface only after structural alignment. What worked silently in ECC becomes visible under S/4 governance.
Governance and accountability, RACI model.
Accountable means the person who owns the production and financial architecture. Responsible means the person who executes configuration corrections. 1. Accountable PP functional lead for order type and split design. 2. Responsible PP functional lead implementing configuration adjustments. 3. Consulted CO functional lead validating settlement and variance logic. 4. Informed production manager reviewing operational implications. Order split stability depends on configuration discipline.
Ownership, who actually fixes it.
Correcting split behavior requires cross-functional validation. 1. PP functional lead reviews order type split parameters and inheritance logic. 2. CO functional lead validates settlement profile and cost component behavior. 3. Production manager performs real production split simulations. 4. Basis lead monitors runtime performance if high-volume splits are executed.
Who gets blamed versus who owns it.
1. Blamed finance for variance discrepancies. 2. Blamed system for inconsistent child order creation. 3. Actual owner PP functional lead for configuration alignment. 4. Root cause, settlement, and split inheritance misconfiguration.
How this is actually fixed, the right way by a role.
1. PP functional lead standardizes split control parameters across plants. 2. CO functional lead revalidates settlement and variance structure. 3. Production manager tests multi-scenario production quantities. 4. Project lead approves architectural harmonization.
What not to do, common wrong fixes.
1. Manually adjusting child order settlement without fixing configuration. 2. Suppressing variance postings to hide financial drift. 3. Ignoring split testing during integration cycles. 4. Blaming material ledger without configuration validation. Split logic issues are structural, not transactional.
Follow-up 1. Does material ledger always affect order splits?
Answer: yes, because material ledger enforces parallel valuation and cost propagation rules. When orders split, valuation must remain consistent across all resulting objects.
Follow-up 2. Can order splits be disabled to avoid complexity?
Answer: they can be limited, but that impacts operational flexibility. The correct solution is configuration alignment, not functional restriction.
Follow-up 3. Curveball. Why do split errors appear only during month-end?
Answer: because settlement and variance calculations execute in full during financial closing. Small test cycles may not trigger full financial reconciliation.
Exclusive pro tip.
Always simulate order split and full settlement cycles in quality systems, using realistic production volumes before go live.
Scenario 76. Capacity leveling results drift.
After ECC to S/4HANA migration, capacity leveling and dispatching results no longer match previous planning outcomes. Orders are scheduled in different sequences, overloads appear in unexpected periods, and planners lose confidence in system-driven scheduling.
Scenario classification.
1. Complexity, high planning and execution risk. 2. Phase, post-go-live. 3. Primary ownership, PP functional lead. 4. Supporting business planner, BPO. 5. Business ownership, production manager, BPO.
Diagnostic dashboard, symptoms and evidence.
How capacity instability becomes visible and how to detect it early. 1. Symptom: work centers show overloads despite unchanged demand. 2. Red flag: dispatching results differ between test and production environments. 3. Business impact: production sequencing becomes unpredictable and throughput drops. 4. Detection: compare capacity evaluation reports before and after migration. 5. Technical proof: scheduling logs show different prioritization or reduction strategies. Scheduling drift is usually configuration or algorithm-driven, not transactional.
Why this happens, scenario analysis and root cause.
1. Capacity formula parameters were adjusted during template harmonization. 2. Scheduling profiles behave differently under S/4HANA optimization logic. 3. Parallel processing impacts dispatching sequence consistency. 4. Planning parameters were never fully standardized across plants. Small configuration shifts can produce large scheduling changes.
Why this is a migration-exclusive failure.
1. ECC scheduling tolerated inconsistent capacity formulas. 2. S/4HANA emphasizes real-time capacity recalculation. 3. Parallel execution alters order prioritization behavior. 4. Algorithmic changes surface only after system conversion. Migration activates stricter and faster scheduling logic.
Governance and accountability, RACI model.
Accountable means the person who owns capacity design and planning architecture. Responsible means the person who executes the scheduling configuration. 1. Accountable PP functional lead for capacity and scheduling configuration. 2. Responsible PP functional lead implementing leveling and dispatching parameters. 3. Consulted business planner validating real production constraints. 4. Informed production manager reviewing operational feasibility. Capacity governance must align system logic with real shop floor constraints.
Ownership, who actually fixes it.
Resolving capacity drift requires joint validation between system design and operational reality. 1. PP functional lead reviews scheduling profiles and reduction strategies. 2. Business planner compares system output with historical planning logic. 3. Production manager validates execution feasibility on the shop floor. 4. Basis lead reviews performance parameters impacting scheduling runtime.
Who gets blamed versus who owns it.
1. Blamed system performance because schedules changed. 2. Blamed planners for incorrect prioritization. 3. Actual owner PP functional lead for configuration governance. 4. Root cause algorithm and parameter changes after migration.
How this is actually fixed. The right way by a role.
1. PP functional lead revalidates scheduling and reduction profiles. 2. Business planner conducts scenario-based leveling simulations. 3. Production manager confirms sequence alignment with constraints. 4. Project lead enforces cross-plant configuration harmonization.
What not to do, common wrong fixes.
1. Hard-coding manual dispatch sequences to override system logic. 2. Ignoring overload alerts assuming they are system noise. 3. Reducing capacity artificially without business validation. 4. Blaming parallel processing without configuration review. Capacity instability cannot be solved with shortcuts.
Follow-up 1. Why does scheduling change even when demand is the same?
Answer: because scheduling depends on parameters such as reduction strategy, finite capacity logic, and prioritization rules. Even small configuration changes can alter the final dispatching order.
Follow-up 2. Is this a performance issue or a configuration issue?
Answer: most cases are configuration-driven. Performance influences speed, but scheduling drift typically originates from parameter alignment and algorithm behavior changes.
Follow-up 3. Curveball. Why do planners lose trust in the system after migration?
Answer: because historical mental models no longer match system output. If the logic is not clearly explained and validated, confidence erodes even if the algorithm is technically correct.
Exclusive pro tip.
Always perform capacity leveling regression tests with realistic production volumes before and immediately after go live.
Scenario 77. Shop floor integration breaks.
After ECC to S/4HANA conversion, shop floor integration with MES, PIPO, or third-party systems stops functioning correctly. Confirmations fail to post, production feedback does not update orders, or goods movements are delayed. Production continues physically, but the system becomes desynchronized.
Scenario classification.
1. Complexity critical execution blocking. 2. Phase cutover and post-go live. 3. Primary ownership integration lead PIPO. 4. Supporting PP functional lead. 5. Business ownership production manager BPO.
Diagnostic dashboard, symptoms and evidence.
How integration failures appear operationally and how to identify them early. 1. Symptom: confirmations from MES do not update production orders in S/4HANA. 2. Red flag: interface queues show failed or stuck messages. 3. Business impact: inventory becomes inaccurate and WIP reporting diverges from reality. 4. Detection: monitor integration logs and interface monitoring dashboards immediately after cutover. 5. Technical proof: error logs show mapping inconsistencies or missing authorization objects. When physical production continues but system data stops, integration is the fault line.
Why this happens, scenario analysis and root cause.
1. Interface payload structures changed after S/4HANA data model simplification. 2. Custom enhancements were removed during SPDD and SBAU adjustments. 3. Authorization objects differ between ECC and S/4HANA. 4. Middleware mappings were not updated to reflect structural changes. Integration failures are rarely random. They are structural mismatches.
Why this is a migration-exclusive failure.
1. ECC integration logic relied on legacy table structures. 2. S/4HANA simplifies and consolidates production-related tables. 3. Middleware mappings remain unchanged unless explicitly updated. 4. These failures appear only when real production traffic flows through the new system. Migration changes structure even when business process appears identical.
Governance and accountability, RACI model.
Accountable means the person who owns integration architecture and business continuity. Responsible means the person who corrects the interface logic. 1. Accountable, integration lead for end-to-end interface design. 2. Responsible, integration developer updating mappings and payload structures. 3. Consulted, PP functional lead validating production process impact. 4. Informed, production business process owner for operational awareness. Integration governance requires clear separation between architectural accountability and technical execution.
Ownership, who actually fixes it.
Resolving shop floor integration failures demands coordinated technical and functional action. 1. Integration lead reviews interface design against S/4HANA data structures. 2. Integration developer updates middleware mappings and error handling. 3. PP functional lead validates confirmation and goods movement alignment. 4. Basis lead verifies system connectivity and authorization consistency.
Who gets blamed versus who owns it.
1. Blamed shop floor users for incorrect confirmations. 2. Blamed S/4HANA upgrade for breaking interfaces. 3. Actual owner, integration architecture and mapping governance. 4. Root cause, structural data model changes not reflected in interface logic.
How this is actually fixed, the right way by a role.
1. Integration lead redesigns payload mapping aligned with S/4HANA structures. 2. Integration developer reprocesses failed messages after correction. 3. PP functional lead performs end-to-end confirmation validation tests. 4. Production manager signs off once transactional integrity is restored.
What not to do, common wrong fixes.
1. Manually correcting orders without fixing the interface. 2. Restarting middleware repeatedly without root cause analysis. 3. Blaming authorization without reviewing payload structure. 4. Ignoring minor queue errors assuming they will self-resolve. Integration instability multiplies quickly if not addressed structurally.
Follow-up 1. Why does integration appear stable in testing, but fail in production?
Answer: because test volumes are limited and often do not simulate real-time production traffic. High concurrency and real business complexity expose structural gaps that sandbox testing misses.
Follow-up 2. Is this purely a technical problem?
Answer: no. While technical mappings are involved, functional validation ensures that confirmations and goods movements reflect real shop floor logic. Both streams must collaborate.
Follow-up 3. Curveball. Why is this more dangerous than a visible system outage?
Answer: because production continues physically while the system becomes inaccurate. This creates hidden inventory discrepancies and financial misstatements before anyone realizes the data gap.
Exclusive pro tip.
Always execute live volume simulation for shop floor interfaces during cutover rehearsal. Interface stability must be proven under real production load.
Category 4 wrap-up. When execution breaks, business stops.
Planning logic issues create confusion. Execution failures create shutdowns. In S/4HANA, even subtle behavioral differences in confirmations, backflush, or goods movements can cascade into inventory errors, costing distortions and operational paralysis. Production execution is where architectural discipline is truly tested.
Part 1 wrap-up. From structural readiness to shop floor stability.
In Part 1, we covered pre-conversion structural risks, conversion window incidents, MRP Live and Planning behavior shifts, and production execution behavior. These categories define whether your migration survives technically and operationally. If Part 1 is not stabilized, Part 2 becomes damage control instead of optimization.
Transition to Part 2. Financial integrity, integration, performance, and advanced planning.
If Part 1 protects operational continuity, Part 2 protects financial integrity, cross-module stability, system performance, custom logic, and advanced planning architecture. These are the areas where long-term audit risks, compliance failures, and performance collapses emerge months after go-live.
Part 2 Overview, the hidden risk zones after go-live.
Part 2 dives into costing, WIP and settlement, cross-module integration, HANA performance, extensibility impacts, post-go-live ghost issues, and advanced planning with PPDS. These are not visible during cut-over weekend. They surface during first month-end close, real production load, or audit review.
Part 2 Categories and Scenario Coverage.
Category 5, Costing, WIP and Settlement Impact, Scenarios 78 to 90. Category 6, Cross-Module Integration Failures, Scenarios 91 to 102. Category 7, HANA Performance and Parallelism Impact, Scenarios 103 to 112. Category 8, Extensibility and Modification Surprises, Scenarios 113 to 124. Category 9, Post-Go-Live Ghost Issues, Scenarios 125 to 136. Category 10, Advanced Planning and Embedded PPDS, Scenarios 137 to 144. Part 2 focuses on long-term stability, governance maturity, and architectural depth beyond initial conversion success.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP Consultant jobs, SAP FICO Consultant jobs, SAP SD Consultant jobs, SAP PP Consultant jobs, SAP Ariba Consultant jobs, SAP Extended Warehouse Management EWM Consultant jobs, SAP Plant Maintenance PM Consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem-solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
For more exciting tips, tricks, and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers, for 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.